This day is the second day for the conference of Chemical Jordanian International Process Safety Conference. Yesterday we have a very successful day. We have more than 2,000 attendants, 2,000 participants, and we more than 45 world country. I pleased to introduce Mr. Azmi Sharif, Director Institute of Containment Management for Oil and Gas, Malaysia. The title of the speech for the keynote will be Process Safety in Industrial Revolutions number 4. Mr. Azmi will be have a presentation 25 minutes and 5 minutes for questions. Please, Mr. Azmi, share your screen. Your floor is yours.
Assalamu alaikum and very good afternoon to everybody. I am Prof. Azmi Muhammad Sharif. I'm the director of the Institute of Containment Management, University Technology Petronas Malaysia, and this university is under one of the university under the National Oil Company of Malaysia, Petronas. My title of presentation is Process Safety in Industrial Revolution 4.0. Okay, and in the institute we have one center called that Center of Advanced Process Safety, looking more on the process safety matters, and we are doing a lot of research, consultancy, and also training for the local and international. Right, and I would like to thank you to the Jordanian International Chemical Process Safety conference organizer for inviting me for this speech. Okay, before I start my presentation directly for the process safety, let us look at directly on the revolutions based on this industry. It was started in 18th century, basically with the first revolution, focusing more on the mechanization of the manufacturing. Okay, manufacturing, and this is where the introduction of the steam and water power, and it was really a breakthrough that they be able to revolutionize the manufacturing industry, then make the speed 8 times more than the normal process by using the steam technology. And the example of that train in this vehicle, but basically that make the train move faster than before. And then they move from this first industrial revolution to the second revolution. And in this second revolution is where the invention of the mass production through the assembly lines using the electrical power. Okay, then we can see the possibility to mass produce on the products such as motor cars. So that how that moved from one revolution to the first revolution to the second revolution, and then come the third revolutions in 70s, looking on basically partial automations or semi-automation of the production lines using electronics, programmable logic controllers that utilizing the robotics in order to speed up the process. And currently, or this decade, basically we are at the Industrial Revolution 4.0, focusing more on autonomous, on the decision making of the cyber physical system using machine learning through cloud technology. So this is really a breakthrough that make the people work autonomously, like what we are doing here. I'm in Malaysia, you are anywhere in the world, that allow us to communicate through this kind of conference. All right. So the question is how the process safety should take advantage of this current technology available in order to make sure and control the issue of the industrial accidents. So what actually the drivers of this Industry 4.0? Basically, the term the Industry 4 is derived from the German, the high-tech strategy from German government in 2011 for promoting the computerization of the manufacturing in this new area. Okay. In this new area, digital manufacturing, digitization, digital play a crucial role. And we basically have identified 9 drivers that make this technology successful in this Industrial Revolution 4.0. So what are those 9? Basically, these are on the advanced manufacturing solutions. Advanced manufacturing means that autonomous cooperation, industrial robots, and so on. Additive manufacturing that allow for the 3D printing, augmented reality that allow us to make the real cases into our digital information, simulation work, horizontal and vertical integration that allow the data integration and data transfer in easier way. Industrial internet through the network and machines and product. We have cloud to manage the huge data that previously that we not be able to do that. And cyber securities that we can ensure the data be able to manage securely in this level. And more important is on the big data analytics, that full evaluation of data is available through this. So by having these all 9 drivers in one for this Industry 4.0, that's allow us basically move forward to a better, to ensure a better safety in process plant. In order to be able to utilize this kind of technology, we have to understand the 2 terms that we use in this Revolution 4 is about what it means by digitization and what is meaning by the digitalization, right? So what is the digitalization? Digitalization is the use of the digital technology to improve the business, the tool itself. So this is a fundamental requirements in order to allow our business or processes to do. So for example, we have like a brick and mortar business before, like we have this supermarket, a big supermarket that currently we can change to the e-commerce platform through like eBay, to the digitalization. Still we'll be able to get the product through this kind of technology. And digitization is the transformation of your information, existing non-digital process into the digital one. That means we have to translate and transform whatever information or data into in the digital platform. So let's say, for example, using cloud-based accounting system to replace a paper filing system in a bank, for example. So this is one of the example that we do. So another example is like we using the mail or email instead of typewriters to the Google Docs. So these are the different or the meaning of digitization and digitalization. So what will be the expected advantage? Of course, with this kind of technology, basically we have the flexibility in doing our work or business, the speed that go beyond our expectation, the productivity that increase, even though we are not really need to be on the directly work using our hand. Quality will be more perfect because we put that into a digitalization method to the real time production. And of course, product competitions will be better compared to the in terms of the cost and time. So let's look at, we understand about the revolution, we understand about the technology and how to relate with the process safety. And we understand that in the process safety, we have many accidents happen worldwide, previously and even now. Recently, it was the accident in Indonesia just a few days ago. Okay, in Indonesia that involved the refinery plant. So we have already put a lot of the comprehensive safety program in order to manage, to prevent, and to mitigate this kind of accident. But accidents still happen. Look at the stages that we do in order to make sure the safety. We started with during the R&D stage, conceptual engineering. We have also safety process during the basic engineering, detail engineering, equipment procurement and construction, commissioning, operations until the end of the life of our plant. Okay, we put everything, but we still that thing is using our common system. So why don't we take the advantage of the current digital or industrial 4.0? So if we are clear, our understand what will be the requirement. In this case, I put the perspective. For the process safety, our objective is basically to prevent and mitigate the possibility of this accident. So if you have chemical process, everybody know that there are 3 major accidents always happen in industry or in a process plant. There are toxic release, explosion, and fire. And we put that clearly on the strategies of the process safety system or layer of protections there through inherent safety by eliminating and reducing the hazard without add-on safety system. And the passive safety is a safety attribute to the design itself, like the thickness of the process vessel. And then the third is we add another one, safety systems, add-on safety system, the instrument, in order to avoid consequence due to process deviations, that we call it active. And then on the procedure, we put that the operating procedures, rules, and management, especially to manage human factors. So we have all that kind of strategy and objective. Okay, this is our traditional way to do that. So how we be able to take the advantage of this industrial 4.0 revolution into the perspectives of process safety? So in order to do that, we try to understand what would be the similarity between the process safety and also the cluster or industrial 4.0. And industrial 4.0, on my left-hand side, you can see that I lift down the keyword that normally used in this information and communication technologies, like automation, cloud computing, data mining, genetic algorithm, human factors, IT, and so on. There is a whole list there. And basically, when we align threat to process safety, only few that really align with requirement of process, like automation, human factors, integration, maintenance, optimization, and simulation. That is something. So at least there are few keywords that we can use, or which is direct related, and there are few other keywords that we want to take advantage from this keyword from the cluster industry 4.0. And if you look at the potential connection between this, like in our case of process safety, we have numbers of important key processes in processes, like process safety management, risk assessment, risk analysis, risk management, process hazard analysis, safety culture, inherent safety. That are all basically be able to basically utilize the term that available in the world. So we can use the perspective using the big data and analytics requirements in our process safety process, cloud, industrial internet, cyber security, and so on. So that is a potential, and the only thing is how to do it. So let's look at on the example here on process safety management. Everybody understand that under the process safety management, there are pillars for PSM. Under the process safety management, we know about our commitment to process safety and understanding hazard, actually how to control hazard, managing risks, how to go there and learn from experience. And from this, if you look, selected few elements in risk-based process safety. Look at the commitment, we are talking about process safety information and employee participation. Understanding has it looking on the process safety information as well, together the process hazard analysis, and how to manage risk. We are looking on the operating procedures, hot work permit, mechanical integrity, contractors training, management of change, and so on. And learn from experience is through the incident investigation and compliance of audit. So these are the element that we normally refer to, which is also available in OSHA for the element of PSM2. So there is a link between that two. So we understand this process safety management, how we can link into the industry 4.0 to take the advantage of this industry 4.0. I mean, through the information and communication technology. So as you understand that the one that we want to look at is that is the information on process safety management. The first part is we want to digitize the information so that we can transfer to the digital tool. So in order to that, understanding of the PSM is very important, starting with understanding the set of guidelines and regulations available in the PSM. There are many issues contributing to the effective implementation of PSM, and more this like human error, that we have to be aware on that thing. In this context, the digitization of PSM can be more effective, okay, to overcome the shortcomings. For the effective PSM, the element process safety information as the should be the heart to all in order to make sure that effective digitization of PSM is of paramount importance. So if we go very detailed about PSI, what to digitize? Basically in OSHA requirement, it's already detailed out the requirement. So we should thank you to those who's contributing to identify this kind of information, so we can directly look at in detail and the requirements, and then we need that information to be in. And of course, each industry have also their own unique data that just can add on within this three important process safety information element is under the chemical, process technology, and process equipment. As an example, in the chemical, the requirement data based on OSHA is like toxicity information, permissibility exposure limit, physical data, reactivity data, corrosive data. So there's a long list there, but we can also have a unique data as add-on to this requirement of chemical. Similarly, like process technology and process equipment too. I need to skip because the time is not on my side now. All right. So in order to better digitizing the information, we need to go a little bit detailed in order to translate that into the actual information according to the flowchart. If you look at on the flowchart, the requirement in order to develop we have to develop the PSI system first before we have that system. Or you already have the PSI, but how we be able to organize it properly? So in the OSHA, basically, is provide information, and also for the risk-based information from the CCPS also available this information. So in order to develop the PSI, there is a code, the standard provided. So first we develop PSI, and then we have to, if it is already available, then we can update and review our processes, hazardous chemical processes. And then we can review also inside that process technology, and we can also process equipment. So three areas cover: chemical, process technology, and process equipment on the process safety information. And then if everything is complete, how we want to put into the perspective. So in order to put the perspective, it's easier. Like say, for example, if you look at our plan, like a PNID, when you want to include the information, okay, you follow like a PNID where you start from the feed until to your product. So if you look at that, if you use the PNID, your platform, then you can choose this PNID node. And from the node, you can choose what equipment and stream. And from within this, basically we look at what data is required based on the chemical process technology and process equipment, and then we can conduct and update PSI accordingly. So it should be very straightforward and simple, because we have guidance through this kind of standard, but understanding is very, very important. So how we translate to the digitization opportunity in this case? So we need to look at on which one we can digitize, which one is actually we not really need to digitize. In this part, if you look at on the process, if we start in the using the PNID, there are a manual part that we have to decide, okay, where to start, where to end, how to divide the node, and so on. But the simple way is if we follow the heads-up technique, a heads-up node, that should be sufficient in order to develop this PSI. And from there, basically, we can digitize the information based on the flowchart that shown here as an example. Okay. And then from this part, I mentioned that how we digitize, and then from this digitization, we can transform the digital information, the tool. And we can do this also for the others like PHA, OP, operating procedure, hot work permit, mechanical integrity, and so on. So this will give the benefit to us through the quick automatic studies or survey, update the changes automatically, quick respond to the changes, to get the information. That means information available at all time, without need to go through the filing and system. If we have the Excel filing also, we still need time. So we need to, we can digitize that for more efficient in terms of data. So this can allow us to do the quick and live assessment on that, because this is we are talking about automation and automatic. Okay, and with that, using that, we can avoid human errors, especially on the data filing and also data sourcing. To find the data, and that can avoid the issue of accident due to the unavailability of data within the system. So if you look at that process safety management industry, the direct application 4.0 drivers for process safety management are like industrial internet cybersecurity, and these two drivers could help to avoid or minimize this accident and prevent the future loss through easy access to the collection of data from process and object. And therefore, the potentials of hazard can be identified and known in order to alert the workers. Other technology drivers like big data, analytics, and cloud will be beneficial in order to analyze, allowing a large amount of data to be stored, referred for planning, monitoring. So you are controlling all the data and the whole plan in your hand, on one system, easier to access through this advancement of the technology. Okay, I have another example. I think I want to skip this example because I have only 25 minutes on presentation. Okay, I will go through directly to general impact of this industry 4.0 impact for process safety. Sorry that I have to skip the example on inherent safety. So potential impact on industry 4.0 technological drivers relevant to process. You can see that the big data, even though the advantage we can get the unlimited data, reduce uncertainty, improve capacity, but the drawback is we have to make sure and the data is reliable. That is the issue. We can put all the data when you transfer. It can be the data also is not incorrect. So we need to come up with certain selection criteria in order to screen the right data, and we have to make sure also the confidential data is be given the priority. In terms of the internet and cybersecurity, there is an improved interaction between equipment, machinery, and detectors of anomalies, improved process monitoring and control, remote monitoring and control, but the issue is drawback is about the network reliability. Our network sometimes up and down depending on the area. So if we have a very good network, that should be an issue. And the cyber security is another issue that we have to make sure that we have protections of our cyber. I think there are a few more examples. I think because the chairman only provided me 25 minutes, of my presentation, I think I would like to conclude my presentation. The future opportunity of Industry 4.0 in process safety. You can see that process safety in era Industry 4 require industrial standard and guidelines to ensure safe operation process plant with the fear of cybersecurity issues. Along with data analytics, smart handling of this data is necessary to take the full advantage of this opportunity. The design, fabric, operation process plant need to be upgraded in context of Industry 4.0. We are talking about autonomous operation. We have to go for it. Do not afraid. So then we also have to look at on this for inherently safer and sustainable process plant to avoid recurrence of accidents. And finally, the future workers require human machine internet skill and capability. Sorry that I've do that kind of speed in order to complete my presentation. And with that, I would like to thank you. Thank you very much to listen to my presentation.
Thank you very much, Dr. Azmi, for this very informative presentation. You addressing very important issues about the integration between the existing process safety management system and digitalization. Also, we hope that maybe we have some guideline or some code of knowledge about the new how to integrate between the process safety management system and fourth revolution. Also, we hope that many or a lot of research or booklets or guidelines about how to integrate big data and industrial internet with cyber security with the process safety management system. And we hope maybe in the near future we can have some HAZOP study, automated HAZOP study, and we hope that we have a process hazard analysis automated without any manual or human work in that field. A lot of thank Mr. Azmi for this very important very issues, and we know that a lot of center in the world and the process safety have how to integrate innovations with the process safety management system, like German Excellence Safety Center have a lot of study about how to integration between the aspects of the process safety management system with innovation system. I appreciate your participations, and I am trust that your representation will be very useful to all participants. Maybe I think if there's some questions we have or 1 minute, or we don't have any time, so that we switch to a new speakers. And we know that you have a very big or very big schedule, so that a lot of thanks for you, Mr. Azmi. The next speaker will be. Thank you very much.
Thank you, Mr. Yaacob. Yeah.
Thank you very much. The next speaker is Dr. Stephen Petter, Director of Energy Institute, Intelligent Business Analytics, UK. The title of this conference paper will be about the Energy Institute, Process Safety Management System Framework, Performance Monitoring, and Associated Audit, what we called a high-level framework of the EI applications. Dr. Stephen, by the way, he is the author for the second edition of the EI high-level framework. We have the pleasure to arrange maybe before 3 months ago workshop with EI, and Dr. Stephen was one of the key speaker of that. Please, Dr. Stephen, the floor is yours.
Thank you very much, Yaacob. Can you hear me okay? Can you see the slides?
Yeah, very clear.
Thank you. Hello, everyone. Welcome. I hope you and all your loved ones are safe in these very challenging times. And I'm very pleased to be presenting here today. Yesterday and today, you've heard a lot and will hear a lot about the challenges of process safety management. I will, however, present an opportunity for you to raise to these challenges and effectively manage process safety.
Dr. Stephen, can you share your presentation, please?
I know, Yaacob?
Yeah, very clear. Thank you very much.
Okay, I'll just go to the start. Can you see now, Yaacob?
Yes, but maybe not the first slide.
Okay, so just gonna hang on a sec. Bear with me, gentlemen. Can you see now the first slide?
No. Yes. Now the first slide, maybe. Yes. Yes.
Yeah. Okay.
Please.
Well, basically, gentlemen and ladies, I will introduce the Energy and Process Safety Management Framework, the digitization and visualization of associated performance monitoring and audit and applications. So basically, the context is there's a number of incidents in the energy industry in various parts of the world, at upstream installations, refineries, and petrol storage facilities. I've highlighted the increasing importance of effective process safety management, the escalating consequences of incidents, calling individuals into account in public, investor confidence undermined, increased scrutiny by regulators and governments. And to give you a context from a financial perspective, this was presented by Marsh Risk latter part of last year. Of the top 100 incidents in loss prevention, the lowest, so the 100 of the incidents resulted in 175 million loss. We've got a lot of historical failings in this area, guys. We've got the Buncefield in the UK, Texas City, Deepwater Horizon, and yep, very recently, the Balagan refinery, a tragedy again. Recently linked to the COVID, a startup in India, following a shutdown for the COVID pandemic, a startup resulted in a release of gas, resulting in 12 people killed, including children. So what the manager need to know? How likely am I to have an incident-free day today and tomorrow? They need to address 3 questions. How will we do that? What can go wrong? What systems are in place to prevent things going wrong? And how we know we're doing this? I think means I do not know. So the CEO's challenge, and all of you guys in this sector, is don't hurt anyone, don't harm anyone, make or exceed the fiscal target. So from my perspective, guys, the word map on the left-hand side, the word cloud, is the elements of what is included in the Energy Institute's high-level process safety framework. And it does what it says. In the UK, the 3 questions from the boardroom that must be answered is, do we understand what can go wrong? Do we understand what systems are in place to prevent things going wrong? And do we know these systems are working effectively? 6 tenets of process safety leadership in high hazard operations. They need to satisfy themselves that major hazards are recognized and the worst potential consequences are understood throughout the business. Plant and equipment are provided which is fit for purpose to reduce the risks from major hazards to tolerable levels. Systems and procedures are provided which ensure proper operation from plant and equipment and which maintain their integrity. Sufficient staff with appropriate experience and training are provided to implement the systems and procedures. And very important, emergency procedures that respond adequately to foreseeable incidents are both in place and practiced. Incident investigation, monitoring and auditing performance take place in order to learn from experience and promote continuous improvement. So this is where the framework come in. It was developed by the industry, for the industry. It will be run through again this afternoon by Mr. Lee Alford. The new revision will be published in Q2 2021. So I'll focus quickly, guys, on the 4 focus areas. There are 20 key elements and 200 expectations, and there are a set of published guidelines to show that you can implement the good practices and process safety performance indicators. The PSM Sanco model basically highlights the dynamic and fluid situation of process safety managing whatever sector you're in. There are 4 areas: process safety leadership, risk identification and assessment, risk management, review and improvement. So to contextualize this, gentlemen, no review and improvement without risk management, no risk management without risk identification and risk assessment, no risk identification and assessment without process safety leadership. So this is the framework in its entirety with the 4 focus areas and the 20 elements and the around 200 expectations. So each element, there are 20 key aspects of the operation we need to manage appropriately in order to assure the integrity of the operation. Each of the 20 elements has a series of expectations that are set requirements for meeting the aims and objectives of each element, and the expectation of things we should be doing in order to assure the integrity of the operation. So we've developed with the EI and our colleagues the EI's process safety performance measure. This is fully aligned to the framework elements and expectations, and it ensures senior executives and managers of supervision understand how likely they are to have an incident-free day tomorrow, have an up-to-date, clear and consistent understanding of compliance and performance levels across their organization on an absolute basis and relative to their peers. It identifies areas of strength and weakness versus a recognized framework, have robust basis for developing compliance, performance and improvement plans, and demonstrate that they are leading on occupational health and safety leadership. It helps business and organizations like your own meet business challenges like aging assets, changing regimes and maintenance, etc., margin pressure, mergers and acquisition activity, seller buyer side due diligence. It is established where we've replicated and digitized and visualized all of the performance measures for the 20 elements, the 4 focus areas, and the 200 expectations on the EI's process safety management framework. It is a fully integrated system that can be menu driven, so you can take all of it, you can take some of it, you can align it with your business framework management systems, and you can select, and you can also aggregate values of where you are in compliance with the 4 focus areas. It's very intuitive and user friendly. It gives you graphical representation. As I say, you can interrogate every level from the CEO boardroom down to operational staff on the site, and you can select. Each element gives you a pictogram and a visualization of where you are against compliance, against the expectations of the framework. And as I say, the image on the right shows you can select it, so you can select all of the elements and the expectations, or you can just select the ones you're interested in. Benefits of this implication: I've implemented this framework in several organizations, from UK oil and gas to high hazard manufacture. And one example, a case that I published with Mr. Alford, was over an 18-month period for an oil terminal in the UK. There was a significant reduction in administrative tasks and resources for data capture, data entry, and data analysis. We had a 0 accident frequency rate, 0 process safety incidents, improved compliance and efficiency. And again, very important in this one, we look at this, ladies and gentlemen, is improved financial performance. Subsequently, we've developed now, as the new framework revision is going to be published, an auditing tool, which is essential in my view from process safety management. So auditing is a process where an organization can review and continually manage, evaluate the effectiveness of their process safety management system. Is a positive and proactive means of checking the process safety performance of an organization and identify extent of compliance with statutory and management system requirements. The application that we've developed allows for a systematic and robust audit of the process safety management system by either internal, so that's your own teams, or external auditors. This allows for a consistent approach to the audits and reporting to identify gaps and inform continuing improvement, and also give you big data where you can learn lessons and enhance the corporate memory of the organization. And this will be of value to senior management, should be fully committed to the concept of auditing and effective implementation within the organization. This application allows senior management to see real-time visualization and tracking of compliance. So it's, again, it's a fully digitized system. Every element is covered. So you've got the 4 focus areas, distilled down to each element, distilled down to each expectation. It gives you then graphical representation of where you are. It's a scored auditing, which delivers a formal report in PDF, and also graphical representation, so you can present to your teams, your sites, your management. You can use it as a benchmarking tool against all of your facilities. So we've seen a lot, we've talked a lot, and we will be talking a lot about how do we avoid process safety incidents within our operations. So from a practitioner's perspective, that's me. this is quite straightforward. I believe that we all should follow a systematic management approach by fully implementing the Energy Institute Process Safety Management Framework in its entirety. Implement the Energy Institute Process Safety Monitoring application and implement the Energy Institute's robust audit process to ensure compliance. You know, it makes sense. There's maybe argument about the different frameworks. In my perspective, whatever framework you're following, they're systematic, they need to be robust, they need to be fully implemented, they need to be measured, because if you measure it, you manage it. And then finally, you need to keep your closed loop systems by carrying out robust internal and external audits of your process safety management framework. So that's a quick run through, Yaqub. I'm open to any questions, or if you want to leave it to the panel, entirely up to you, sir. Thank you very much.
Dr. Stephen, I have questions. We're waiting the second editions of the EI, high level framework, and we have maybe we have ideas to translate the EI to Arabic language because it's very effective. We think that's very effective. I have questions, Dr. Stephen.
Yeah.
Because you are the author of the second edition of the EI. We know that the CCPS normally will have some example and case study for we normally have case study and some examples. And we know that you have a much survey for the implementation of the system. The implementation's results, and it can be published to help the company to make the decision to use your EI high-level framework. Please, in 2 minutes maximum. Can you unmute?
Yeah, okay, thank you, Yaqub. Unmute now, thank you very much. Yes, Yaqub, yeah, there is case studies published, and the new framework revision is due to be published in Q2. And basically, there are examples and tools that can be used in there where this has been implemented. So that is available. I believe that JEA is talking to the Energy Institute, and they've signed a memorandum of understanding where translation is going to be covered off. And I believe that we'll be reaching out to you guys to see how you inform that process. So to make sure that it's fully aligned. So that's all in hand, Yaqub. Lee will be on later on today, and I'm sure he'll reinforce that. So there are publications. I can share with you an article I wrote with myself about Lee of the one example in our case study. We can share with you the appendix of the revision. I'm sure Lee will be able to do that, which give you some framework to how companies can either fully implement it or they can align it with their existing systems. Because the applications and the digitization tools I presented here are also fully alignable to CCPS and also OSHA. So you haven't got to reinvent the wheel. There will be some modifications required, but it's basically about getting this kind of a framework and a systematic approach to prevent the horrific catastrophic failures we have encountered, and again exemplified by several recent ones, that we need to be moving on. Do you know what I mean? So hopefully that answers your question. Any questions you want to send down the line to either myself or Lee, because I'll catch up with Lee later on. Is that okay, sir?
I'd like to thank Dr. Stephen. We appreciate your knowledge and your deep knowledge in the process safety management system. The next speaker will be Mr. Abdulatif Al-Baitawi, a professional business freelance consultant and a trainer based in Dubai, United Arab Emirates. The title of the conference paper will be International Institute Risk and Safety Management, Risk Management and Leadership Competence Framework. Mr. Abdulatif, the floor is yours.
Thank you, Yaqub. Can you see my presentation?
And it's still loading.
Okay.
Okay, please maximize your presentation, Dr. Abdulatif.
All right.
Please maximize.
So Bismillah ar-Rahman ar-Rahim. Assalamu alaikum and greetings everyone. It is a pleasure to take part in this conference, and I'm proud to be a member of Jordan Engineers Association, member of the Energy Institute, and a fellow specialist in the International Institute of Risk and Safety Management, which I'll be talking about their management and leadership competence framework today. Just to give you a bit background about RRSM, it's a non-for-profit professional body established around 46 years ago, based in the UK. It has international reach. We have local branches in UAE, in Qatar, Oman, Saudi Arabia, and some other places in the world. It is a community for individuals who has a common desire to better manage risks and better make decisions in business. Membership is open to individuals who want to stand out in their workplace for their risk competence, technical ability, and leadership. So the RRSM developed a very useful tool that can be used by professionals in the area of risk management. And we're going to talk about this tool in a minute. So we all agree that it is important to manage, to protect people, assets, environment, also maintain a good reputation of our organizations, and of course, profits. The question is always who's responsible for that? The simple answer is everyone's responsible for managing risks, each one in his or her position in the organization. However, to be able to successfully manage risk, you need a culture in your organization where risks are openly discussed, challenged, and escalated. Now, being competent in risk management, of course, have so many benefits, and these benefits equally apply to those working in any or all risk disciplines and in all decision makers across any organization. For effective risk management, we need three things. We need specialized risk expertise. So depending on which area you work and what's the activities, what are the context of the organization. So we need specialized expertise in different areas, process safety, occupational health and safety, ergonomics, etc. We also need timely and empowered decentralized management decision making. You should have a very, very powerful way of making decisions in a timely manner to be able to effectively manage the risks encountered. We also need a central risk management system which coordinates and underpins organizational policies, processes, cultures, and leadership at all levels. And this is becomes very critical and important for larger organizations who has maybe number of operations, number of activities, a number of sites that they manage. So having a central system, a management system is key and very important in order to effectively manage risks. So about this framework, this is really a very flexible tool developed by RRSM with a consultation and collaboration with the industry experts. And the competencies which we will look at in a minute are presented in a very generic way, which make it applicable within the context of your own area of risk management. So so there are three levels that are set in this framework, and these levels are the operational, managerial, and strategic. When we say operational, we expect that the person or the professional understands and has knowledge with some application. You go to a higher level, which is the managerial level. At this level, we expect to have a clear application of this knowledge. And of course, the top level, which is the strategic one, then you have a reasoned advice and depth complexity. We will see in a minute how this applies. But before that, let's understand, the principles that the framework was designed based upon. So firstly, we all agree that risk management is core business discipline, and it should be embedded into all job roles. So it's really everyone in the organization, whether he's an operator, a maintenance technician, a supervisor, an engineer, an accountant, any position, yeah, the risk management should be embedded in these job roles. The second principle is that everyone is a manager of risk and opportunity. Thirdly, everyone needs good leadership skills. Now, the skills may differ from one person to another, depending on the responsibilities and the role, but still, everyone needs some good leadership skills. Risk management is an enabler, and it supports innovation, increased performance, and builds individual and organization resilience. We've been listening to our speakers yesterday and today about, again, new ways of doing things, managing process safety. We just listened to Professor Azmi about, again, the Industrial Revolution and how we can apply that to process safety. So again, risk management should enable those kind of innovations in order to better perform. Also, of these principles, the competencies are purposely presented in a generic way, so it can be applied to different areas of responsibilities and locations. So this framework is not only applicable to the United Kingdom or Europe or Middle East or Asia or Africa, it applies everywhere. And it's not only applicable to industries such as oil and gas, chemical manufacturing, food, but it applies to everything, even if it's a hospital, a school, a small company. No one person or function can manage all the risks. In any organization, there are many risks, depends again on the size and the type of activity, but no one person in this organization can manage everything. Competencies and leadership behaviors are accumulated as individual progress. So who can use this framework, or who can benefit from this framework? Really, we have so many users, types of users that can use the framework. So this could be the risk and safety professionals, like process safety professionals. It also can be the employers and HR professionals, regulators. We keep hearing from our respected speakers about the importance of having regulations when it comes to process safety management. Universities, those institutes who prepare the future generation, recruitment agencies, and of course the International Institute for Risk and Safety Management itself. I won't go in details to each one of them, although it's really important to know, but I'll just take one example to elaborate more. So if we say the risk and safety professionals, for example, the process safety professionals, they want to use this framework. So this framework will help them do an assessment, a self-assessment. So where me as a professional, where do I stand? What are my expertise so far? What are my qualifications so far? How do I compare, with my peers in the same field? It also helps in career planning. So if I start at a certain, working at a certain company in a certain position, how do I plan for my career? How do I want to progress in my career? I can use this tool to help me. Of course, it's a useful tool for continual professional development, CPD, which is key to really every profession, but more to people working in risk and safety management. And if you are a member in WRSM, then also it helps you in attaining your professional membership. So the framework has a number of technical competencies, which are 7. And these technical competencies are very detailed in the framework itself. I'm not going to talk about each one of them in details, but it's nice to know that this includes the organizational context, role of risk management, strategy, objectives, policy and procedures, project change management, stakeholder engagement, data management, risk and organization reporting. Okay, to clarify more, so if I'm a professional using this framework and I have to go to each of these technical competencies, what do I do? So I took an example, data management. If I'm at the operational level, then most probably I'm only collecting these data. This could be process data, safety data, whatever the data is, and just doing very preliminary analysis. If I go to a higher level, which is the managerial level, then most probably I'm analyzing the data collected and identifying trends and anomalies. And I do give insights to decisions about the strategy. If I go to the top level, which is the strategic level, then I'm analyzing these trends and anomalies to find solutions and deliver or challenge the strategy. So the point is that I look at each one of these technical competencies and I start assessing myself and finding where do I fit in these, one of these three levels. The same applies to the leadership behaviors. So we have, again, 8 leadership behaviors: emotional intelligence, influencing, collaborative, communicative, innovative, ethical, determined, and systematic. In a similar way, if we take innovative as an example, so at the operational level, the professional contributes to discussion on new ways of work and open to learn from others. However, at managerial level, you expect to encourage others by challenging them and seek to learn and motivate others also to learn. And the strategic level, so the people at the strategic level, they create environment where ideas overcome challenges and they seek opportunities to improve as an individual and as an organization in a whole. In summary, the framework can help people and organizations judge the level of risk competence required to build personal or organizational capability, giving them a benchmark against which to recruit, retain, and develop staff. It's a good risk management competence and can provide both the individual and organization with a real competitive edge. Now, the framework will be available to everyone, and it's also available on the website. So I invite everyone really to look and read through the framework. It's not very complicated. It's easy, but it's really very useful tool. And I'm sure you'll benefit of this, and it's available to anyone, even if you're not a member in WRSM. Thank you for listening, and I'll give like a minute or two for questions if there are any.
Mr. Abdul Latif, thank you for very interesting framework. I have questions. Do you have some structured diagram for your framework, like CCBS house of the process safety, like house of the quality, so that the people will be easy to understand your framework in just one figure or one diagram?
No, there isn't like, if you say, a diagram or a process flow chart for that. But if you read the framework itself, the document, it's easy and self-explanatory. There are tables, of course, there that makes it easier also to follow on this. But no, there isn't a process flow chart for this.
Because it's much easier yeah, okay.
I understand. Yeah, I agree with you. Yeah.
Okay, thank you, Mr. Abdul Latif, for very informative excellence model for the IRRSM. The next speaker will be Mr. Mahmoud Saim, consultant, CEO of the Shared Risk Pakistan. The title will be the title for the conference paper, Why Hazub and Luba Fail. Mr. Saim, the floor with you.
Thank you, Yaqub. Can you hear me?
Yeah, very clear. Please
right.
share your presentation.
Can you see my screen?
Yeah. If you can maximize, thank you very much.
All right, thank you very much, Yaqub, for inviting me to this seminar and listening to yesterday's speakers. It's a wonderful and very well-organized seminar. Indeed, like me, everyone will agree that we learned a lot yesterday and the learning session today. Very, very good effort, and thank you to all the speakers and all the listeners as well. Just 2 days before this workshop, we have seen a major fire in Indonesia. Why I chose this topic, why Hazubs fail or why Lubas fail, is because we keep seeing these incidents. We do Hazubs and Lubas for a reason, to prevent these major accidents. So I went through a number of failures through books and through literature and through investigation reports. And I'll show you one slide before I enter into my presentation formally, that we are almost failing in HAZOPs and LOPA almost every time. Yes, it's a big statement to say almost every time, but yes, I'll show you. There's a formal study about this. So I'll just touch very fundamental stuff, nothing very technical here, very basics. And I expect people to focus on these basics, because failing to meet or comply with these basics is the cause that has often LOPAs fail. A brief about me: I'm a technical safety consultant. I have 20 plus years experience in process and process safety engineering, worked with Engro, PDO, and BP as process safety engineer. And last 6 years, I'm working independently as a process safety consultant, and I've been doing a number of process safety services for various organizations across the globe. And this presentation is based on my learning of these studies, these workshops with all of these organizations. It's not that this is something very theoretical. I have tried to gather my personal experiences based on my interactions with various organizations, various workshops. Why I chose this subject is because you see these accidents happening, and someone, especially this guy, Paul Weber, he looked into the CSP incident investigation reports. He developed a statistical analysis of all the investigations done by CSP in the last around 15 or 16 years. And he identified common causes in all of those accidents. And look at this. In all of the accidents, PHA failed. And he found out that CSP investigations revealed that either the accident scenario was totally missed out in HAZOP or PHA or whatever tool or technique was used for PHA, or there were shortcomings that led to failure. 100%, that's a very worrying number for any process safety engineer, and should be worrying for every manager and leader. Number two common cause is inadequate safeguards, 56%. Despite compliance to standards, despite claims of adhering to rugger gaps, we have gone through some presentations on compliance with standards, rugger gaps, compliance with company engineering practices. We still see 56%, and that's even after when these IC 61511, 61508, this is becoming very common practice. That's still studies. Yesterday, Dr. Abdulaziz of Aramco gave a very good presentation on LOPA, and we see, and he identified the issues with LOPA, and I think he almost covered whatever I'm going to talk, and it's a repeat of his presentation, almost a repeat of his presentation. And we see here that failure in PHA, 100% inadequate safeguard in 56%, which means that in organizations, all of those organizations will be falling somewhere between these numbers. Even if there's no accident happening, it's just a matter of time. We have seen 2 days ago, major refinery failure. Professor Kletz wondered many years ago what went wrong, and then he came back and said it's still going wrong. In his first book, What Went Wrong, he writes down, and this is the summary of process safety engineering. That is, most of the incidents are very simple. No esoteric knowledge or detailed study was required to prevent. Only a knowledge of what happened before. Very important. In HAZOPs, we are not doing some rocket science or engineering or any calculations. We are just applying knowledge of what happened before. And it's our failure to apply that knowledge in HAZOPs that leads to failure of that HAZOP or that PHA or that book. Why we do so, why we fail to learn is because all knowledge we have, we do not want to use. It mostly goes to waste. Accidents are not due to lack of knowledge, but failure to use the knowledge. It's not that we do not have. We have seen, every day we meet very competent people. In this seminar, we have seen excellent presentations that are of very, very high quality, depicting that there is a very, very high level of process safety knowledge available with people. But then why a refinery burnt out just 2 days ago? Why it is still going wrong? Because human nature does not like to admit or reveal knowledge of problems. We are shy to admit that we have problems in our organization, we have problems in our operations and our practices. We believe accidents cannot happen in our organization, in our plant, in our refinery, in our sugar industry, in our power plant. We believe we are perfect. Now let's look at some of the common causes which I have encountered in past 15 years of HAZOPing. Number one, lack of leadership support. Yes, I have found out that most of the leaders are not convinced that PHAs or HAZOPs are of any benefit to the organization. They do it under various obligations or pressures, complies with codes and standards, complies with regulations or what. They are not convinced that this exercise is going to add real value to their productivity, to their safety, to their reputation or the market. That is the reason they do not dedicate the best resources or all the resources needed in terms of time and money. They just want it to be done as a checklist item. And that is why the managers are not convinced, and the leaders are not convinced, the managers are not interested. They believe either HAZOP is a HSC responsibility or their achievement or their target, or it's just that it is a checklist item, and hence they have to do it just because someone is asking to do it. In some way, they plan a bad HAZOP and then convince themselves in the end, look, HAZOP didn't do any benefit. Yes, it will not do any benefit if you do not want to get any benefit. One of the subsequent reasons arriving out of leadership commitment is overspeeding, because you're not given adequate time. Yesterday, Dr. Abdulaziz mentioned it, that people want HAZOPs and LOPA to be finished in 2 days, 3 days, very fast. Do it, because we have to do other important tasks in our organization. Overspeeding, project time pressures. And the HAZOP leader fails to keep team focused. They indulge in design reviews. I'll come to that. They indulge in time wastages, the discussions, and hence actual HAZOPing or PHAing is very limited. Timelines are often cast in stone. Project managers, especially, they say this HAZOP or this LOPA has to be done in this week or these many days, and that's it. You have to finish it. Finish or not, these are the dates. There are budgetary constraints, there are time constraints. If you do not give adequate time, you shouldn't expect the team to do a quality discussion on HAZOP. Then another evil, people are not dedicated for PHA. The team member come in the room, tasked with other important deadlines, so they do multitasking. Many times it's irritating for the facilitator, it's irritating for other participants. They just keep indulge in emailing, preparing other stuff, sending their presentations for next day for other stuff. They are just physically present in the room. They're not participating. HAZOP is a brainstorming session. It's not that we need you physically. It's not that we will ask you a question and then you are required to answer. You are here to participate in a discussion, in a debate, share your experience. It's not that we are inviting you because we may have some question for you. Some people always ask me, call me when you have a question for me. Call me when you need me. If I have to do that, then I can do a HAZOP on my desk, send you worksheets for your comments. No, that's not it. The brainstorming means brainstorming. Everyone must participate and experience share their experience. Another issue with all the HAZOPs is that HAZOPs convert into the design reviews. People start reviewing, will the design work? Will this work? Should there be a better opportunity or there's an alternate design? No, that's not. We are here to judge whether we can successfully and safely operate the design. We are not here to design the review, whether this valve is good enough size, whether there's a need of bypass or not. No, we are not here to do that. We are here to discuss what if the bypass is left open. Do not bring an immature or unreviewed design into the HAZOP. Another issue with the HAZOPs is that the ground rules of HAZOP are not discussed prior to entering the HAZOP room. People start debating the rules during the workshop. For example, is a check valve a safeguard against reverse flow or not? Why are you discussing this in HAZOP? Why didn't you issue a terms of reference with rules of the game? Why you didn't agree with the terms of, it's like playing a football match without setting the rules.
Mr. Saim, the remaining 2 minutes.
All right.
Okay.
And then the common issue with all the HAZOPs is incomplete PSI package or inadequate information available in the room. Like yesterday, Dr. Abdulaziz saying, if you bring wrong information or less information, you will end up either an over design or an under design. You need to have all the required information, all the desired information as per the TOR in the HAZOP. If you say, okay, we will search during the HAZOP, that will waste time. If you say we'll give it later on, that is not the way. You have to bring all the information in the room right at that moment. Another issue with the HAZOPs is linked to the risk ranking. The risk ranking we do in the HAZOPs and LOPA is directly linked to the layers of protection, as we have gone through in the LOPA presentation yesterday. There are various layers of protection involved in any design, and we assign certain risk reduction credit to each of these layers of protection. Sometimes we assign over credit and sometimes under credit. We have to agree on which layer of protection gives how much risk reduction. For example, we often give a high credit to a locked open valve marked on a schematic. Okay, that's a very good safeguard, but only if there is a robust management system in place at the ground to manage locked open or locked closed valves. In one of the HAZOPs, I was doing the operations and the process. They insisted we have locked open valves, so we are not going to take it as a scenario for blocked outlet.
Mr. Saim, a lot of thanks for your for informative and lesson learned for implementation of the HAZOP. I agree with you that all knowledge where we have, if not used, it will be waste. A lot of thanks, Mr. Saim.
The next
speaker will be Mr. Noor. Thank you very much. Mr. Noor Quddus, Research Associate, Texas A&M University, USA. The title for the conference paper will be Managing Storage Facility for Hazardous Substance. Dr. Noor, the floor is yours, and you can share what your presentation. Please unmute Okay, thank you.
Can you say it?
Yeah. And your voice is clear. Let's share your presentation. Thank you.
Greetings, everyone. This is like early in the morning here. So good morning, and probably some part in the world, this is in the afternoon. So my name is Nur Kudus. I'm a research engineer at the Mary Kay O'Connor Process Safety Center at Texas A&M University. The title of my talk today is Managing Storage Facilities for Hazardous Substances. And the title or the topic came out from the Beirut explosion that happened last year. So these are the two incidents that are, I mean, we all are very familiar with. The first on the left one, we have a Beirut explosion site that happened last year, killed at least like 200 people, injured many others. And we have like a lot of asset damage and the human displacement, a lot of misery that we all know. But there are a couple of incidents regarding ammonium nitrate storage, involving ammonium nitrate storage. And one of them actually here, I mean, a few miles from Texas A&M was waste fertilizer explosion site. So the incident killed 15 people, including 12 emergency responders. And we don't have any incident investigation report available to us at this moment from Beirut explosion or other similar incidents like Tianjin, but we can share some of the lessons learned from waste explosion. So the key lessons learned from waste explosion as investigated and published by Chemical Safety Board, CSB, cover like 19 recommendations for 6 federal, 4 state, and 1 local agencies. So, and if on the left side, you see that a lot of those recommendations are regarding training, outreach, and guideline documents. Only one regarding code and standards, and 2 are regulations. So we understand that how the emphasis on outreach program and training program, like to different agencies, to different industry bodies. And on the right side, we see that the topic they highlighted, that hazard identification, because the hazards of ammonium nitrate storage was not perceived very well by many people, and pre-incident planning, facility siting, and chemical inventory reporting that they have large bulk storage of ammonium nitrate and no one knows about it. And emergency response and fire protection. These 2 I will cover less in today's talk, that emergency response. And finally, the risk communication that tied back to training and outreach program, that how risk communication is important because a lot of people or a lot of stakeholders are not aware of ammonium nitrate hazards, although it is very well known in scientific community. So there are a few specific recommendations for the storage facilities, and they include, these are the 5 points that I'll come back, reiterate many times in this presentation, that prohibit combustible material for the construction of this storage facility. So this is because if there is a fire and these are combustible material, then they will aggravate the fire and make the condition or deteriorate the condition. And the second is a define adequate ventilation, that ventilation is required, absolutely required, but we have to define ventilation, that whether we completely dependent on natural ventilation or the forced ventilation or air conditioning system, or what type of ventilation system, engineered or non-engineered, we have to adopt. And the third one require automatic sprinklers and a smoke detection system and any other firefighting system. And a lot of agencies tie these requirements with the bulk quantity that you can store. And the last two are require isolation. That means ammonium nitrate cannot be stored along with a lot of other substances because of the potential contamination or potential or source as a source of ignition. So we have those things settled out. We know that what are the material like organic substances cannot be stored with ammonium nitrate and so on. And establish separation distances like what might be a reasonable distance for the local community, other community housing like schools or hospitals, something like that, that we need to establish that separation distances. And just after waste explosion in the United States, there are several executive orders, and that followed by some changes in regulations. And as part of that, OSHA issued process safety management for storage facilities in 2017. OSHA says that OSHA has process safety management, the program which has 14 elements, but OSHA emphasized 7 of those elements, particularly employee participation, process safety information, process hazard analysis, mechanical integrity, training, operating procedure, emergency planning and response. There are hardly anyone who will doubt that these 7 components are actually essential for a storage facility. Although being a storage facility not as an operational unit, we sometimes, OSHA PSM exclude storage facility from PSM implementation. But my take on this is management of change is another element that should be seriously considered by OSHA PSM for the storage facilities. So you can tie all these elements to the initial findings of the CSB, that hazard identification, the ventilation requirement, and the status of those systems in the mechanical integrity, the PSI you can relate to what are the substances that are incompatible with ammonium nitrate storage and so on. And the people who are dealing with these substances or dealing with the storage facilities, they need to understand all above. So the training and operating procedures are absolutely relevant. So OSHA has some specific guidance for ammonium nitrate storage requirements, and they suggested to follow some of the NFPA guidelines. Here, we see that they require for adequate ventilation, the non-combustible material for the building material. And this is one additional one that they say that storage has to be maintained below 130 degree Fahrenheit. That is around 53 or 54 degree Celsius. That above that you have to take a certain engineer control. And avoid contamination. This comes in many documents that ammonium nitrate decomposes when they're stored with different substances, and or if there are contamination with the prills. So there are different mechanisms proposed in the literature for the ammonium nitrate, and we will not go into that detail, but we understand that contamination is a very important parameter for ammonium nitrate. And not more than 2,500 tons of bagged ammonium nitrate shall be stored in a building structure not equipped with automatic sprinkler system. So here we have some guidelines for the fire protection system. We'll see that in detail in a couple of slides. And here also like some portable and portable fire extinguishing requirement. So apart from OSHA document, there are the chemical advisory, safe storage, handling, and management of ammonium nitrate, jointly issued by EPA, OSHA, and ATF. ATF is for Alcohol, Tobacco, Firearms, and Explosion Authority in the United States. EPA stands for Environmental Protection Agency, and OSHA stands for Occupational Safety and Health Administration. So these are three organizations. There are some requirements from the FDA on fertilizer storage, but this document initially was issued by these three agencies in August 2013. They have a couple of different requirements. The first one is the building design. It's required that one-story building and no basement unless the basement is open on the one side. And they have some specific requirements on how the confinement should be, what are the temperature, the ventilation, and the building material, and so on. So we see that there's a trend of the guidelines and the for the ammonium nitrate storage. And if we see like a more detail that that specific chemical advice, same document, but storage in the bulk. So I have two images. On the top one is actually from the storage facility as port of Beirut before the explosion. And the bottom one I collected from
Dr. Noor,
yes.
Please, you have remaining time, 2 minutes.
Here, like the storage facilities, we see that on the Beirut one, that how they are incompatible with these guidelines. And so I'll go a little quicker since I have only 2 minutes here. Again, another the two pictures at the Beirut explosions, like how they didn't follow the guidelines and they didn't maintain the distances that actually required for these storage bags. This is some fire protection requirements that actually I mentioned. I'll skip to this one. This is some UK HEC guidelines, but this is the last part that actually I want to focus, that large storage facilities, although like we're doing all of it, but we have to do some detailed risk assessment, such as like this is the waste fertilizer explosion consequence analysis. We see that at the red one, that was the school, and at the middle of the circles, that is the waste fertilizers, the plant where the explosion occurred. And the different circles indicate that different safe distances by different authorities. So we need to figure out that what might be the appropriate the safe distances. And when we do the risk assessment, especially for the large facilities, no matter what the regulation says, we have to be careful with the risk assessment for the safeguard. And we see here the same, see here the distances like about 190 and 865 meter. And look at the distances here for the Beirut explosion and our recently published paper. And on the right side, we have the overpressure created by the explosion, and see like overpressure was pretty high even after the 1 kilometer range. So this suggested that regulatory oversight is absolutely required. There are some good guidelines, but in-depth risk assessment is required for large scale facilities. Mm-hmm. And the last thing that we need to convey this message to all stakeholders, not only the engineers or the facility owner, but the government, communities at every level, that they need to understand. Otherwise, we will keep seeing these ammonium nitrate incidents in the different part of the world, and which actually saddens us very much. Thank you very much.
I'd like to thank Dr. Quddus for highlighting the international guideline which addressing the process safety related to the storage facility. Dr. Ma'touq.
Thank you very much, my colleague. And now we are going to call upon our next speaker, Mr. Amin El-Wardat. He is the labor inspector and occupational safety and health specialist from Lebanon. He is going to talk about the role of the International Labour Organization in enhancing occupational health, safety and health in the Arab region. Mr. Amin, the floor is for you. Please go ahead. You have 15 minutes.
Good afternoon, everybody. My presentation, as you mentioned, will be on the role of the ILO in enhancing occupation safety and health and labor inspection in the Arab region. But sorry, I have to stop the video because I have some problems. If it continues, I will lose connection. Yeah, so I will share the screen. Okay.
Can you maximize it?
Yes.
Thank you.
So I'm going to start with a brief about the ILO. The International Labour Organization is a specialized UN agency mandated to deal with all labor issues. It was established in 1919 before the United Nations itself was established, and it joined the United Nations in 1946. It has a unique structure by being a tripartite one, as its governing body has representatives from governments, employers, and workers, with equivalent numbers of workers and employers to those of the government representatives. The ILO has 189 member states and has around 3,000 staff at the global level in its offices and projects. The current agenda of the ILO is decent work for all. By decent work, we mean productive opportunities for women and men to obtain decent productive work in conditions of freedom, equity, security, and human dignity. To achieve decent work for all, the ILO has developed 4 strategic objectives. These are the promoting the fundamental principles and rights at work, ensuring decent work employment opportunities for all, social protection for all, and strengthening tripartism and social dialogue. By fundamental principles and rights at work, we mean 4 main elements, which are the freedom of association and effective recognition of collective bargaining, elimination of all forms of forced and or compulsory labor, effective abolition of child labor, and elimination of discrimination in respect to employment and occupation. To achieve its objectives, the ILO developed a set of conventions, instruments, which include conventions, recommendations, codes of practices, and guidelines and handbooks. And the conventions are open for the ratification by member states, and their implementation become binding to the countries which ratify those conventions. We, as mentioned earlier, we have 189 member states, and we have so far developed 190 conventions covering different aspects of labor, such as child labor, working hours, wages, occupational safety and health, domestic work, etc. And those conventions can be divided into 3 groups. Those are priority conventions, or priority or core conventions, technical conventions, and governance conventions. The priority conventions or the core conventions, they cover 4 areas, which are cover the fundamental principles and rights at work. Conventions 29 and 105 cover forced labor, and 87 and 98 cover the freedom of association and the right to organize. Conventions 100 and 111 cover the discrimination in respect of employment and work, and 138 and 108 cover the child labor, with the 181 being on the elimination of the worst forms of child labor. Out of the 180 and 90 conventions, we have about a third of them, more than 70 conventions on occupational safety and health. And occupational safety and health is one of the main priorities of the ILO for the impact, for its impact on the lives and the quality of life of people. The ILO and the WHO estimated the occupational injuries and illnesses and their impact at the global level as follows. They estimated that more than 200, sorry. They estimated that more than 2.78 million deaths at the global level take place every year due to work-related reasons. Out of those, 2.4 are attributed to occupational diseases, and 350,000 are attributed to 380,000 and 500 deaths are attributed to work-related accidents and diseases. Work-related accidents and diseases also result in 1,000 people losing their lives every year, and 6,500 of them lose their lives because of occupational diseases. These accidents, injuries, and diseases result in the loss of more than about 4% of the gross domestic product at the global level. The ILO conventions on OSH, on occupational safety and health, as mentioned, which form about 30% of or more of all ILO conventions, can be divided into 3 groups. The first one is for guiding policies and actions at the national level for improving occupational safety and health and the prevention of accidents and injuries. Those are, this group includes 3 main conventions: the Convention 155 on occupational safety and health, Convention 161 on occupational health services, and Convention 187 on the promotional framework for occupational safety and health. The second group is for the protection of specific branches of economic activity, such as the Convention 167 on occupational safety and health in construction. And the third group is for the protection of workers against specific risks, such as the Convention 170 on chemicals. Regarding the ratification of those of ILO conventions, the main ones on occupational safety and health, the Benzene Convention number 136, for example, ratified so far by 38 countries at the global level, and only 5 countries out of the 24 Arab countries in the Middle East and North Africa ratified this convention. Convention 155, Occupational Safety and Health Convention, was ratified by 71 countries at the global level and only 3 countries at the in the Arab countries. Occupational Health Services Convention 161 was not ratified so far by any Arab country, while it was ratified by 34 countries at the global level. chemical convention, which is the topic of the this conference, was ratified only by 2 countries, 2 Arab countries, and 22 countries at the global level. The promotional framework for occupational safety and health convention, which is one of the most important conventions on occupational safety and health, was ratified by 2 Arab countries only, which are Iraq ratified it in 2015 and Morocco ratified it in 2019. The main features of the OSH conventions are they are generally applicable. They apply to all sectors of work with some flexibility. Countries ratifying those conventions can exclude some sectors or some groups of workers, but they have to notify the ILO for the reasons behind such exclusion. And those conventions target the governments, workers, and employers, and they include their duties, responsibilities, and obligations. And they are based on tripartism, that's full partnership between the government, workers' organizations, and employers' organizations. And in those conventions, the principle of prevention is accorded the highest priority. Those conventions are structured in a way to provide clear definitions, scope, and exclusions of the provisions of those conventions. They include the general principles on occupational safety and health and on the prevention of injuries and diseases. They include the responsibilities of competent authorities and workers and employers representatives. They also include the responsibilities of the manufacturers and exporting countries. And those conventions are designed to prevent work-related accidents, injuries, and diseases, including major industrial accidents, such as the Beirut blast, which took place in August 2020. The Chemical Convention 170 provides a blueprint for sound management of chemicals in the workplace, as it covers the obligations, the responsibilities, and duties of government, employers, and workers. Also, it refers to the classification system for the chemicals, labeling them, and operational control measures to control them, in addition to design and installation of work systems, practices, and personal protection against those chemicals.
Mr. Amin, you have 2 minutes.
Oh, that's too short time. Okay, thank you.
Thank you.
So the Chemical Convention 170 provides for sound management of chemicals in the workplace in 3 steps, including identification of chemicals and classifying them, determination of potential exposure and risk assessment, and identifying and applying the control measures. Some of the key factors we consider in the ILO as some of the factors we consider key for sound management of chemicals is effective engagement of workers and employers on all related activities, including policies and strategies. We in the ILO provide technical support to the member states to implement those conventions through development of national OSH systems, which include reforming the legislation and enhancing technical capacity of the authorities in charge of monitoring the occupational safety and health at the national level. We also provide technical support for reforming the legislation itself in line with the international labor standards and good practices at the national level through full consultation and engagement of social partners.
Mr. Ibrahim, thank you very much.
One of the, okay, lastly, I would like to mention one of the main things that we work on in at the global level in general and in Arab countries in particular is promoting the strategic compliance planning approach, which is a model developed by the ILO for ensuring efficient use of the resources in labor inspection, including occupational safety and health inspection. And this model is designed with the 6 steps, which includes exploring the labor inspectorate in terms of their technical and human resources, exploring the issues and targets and type of violations of the national legislation, and in exploring the influences and the underlying causes of non-compliance, then exploring the stakeholders and partners for who could contribute to achieving best results, then exploring interventions and actions for promoting compliance with the national legislation. Then the last step includes developing and operationalizing the strategic compliance plan.
Thank you very much. Thank you very much.
Yes, but I want to say that this model now has been being applied in Jordan, Palestine, and Iraq. Yeah, thank you very much.
Thank you, our pleasure. Thank you for very interesting and valuable information about the safety in the Arab region. Now we have the 3 questions for our panelists. The question is, first question to me, actually it's, we will start with Dr. Abdul Latif. How we can say that everyone is a manager, and at the same time, we are talking about central risk management. Dr. Abdul Latif, this is a question for you.
Okay, thank you, Dr. Muhammad.
Welcome.
So first of all, there is a difference between saying everyone is responsible on managing risk and being a manager. So not everyone is a manager, but everyone is responsible for managing risks in their area or in their sections or departments. However, even if it's that everyone is responsible for managing risk, we still have to have a central management system. So, you know, not every employee will come up with his or her own management system. You have one central management system, okay, applied all through the organization, but then everyone in the organization has some responsibility. The old, if you say the old way of doing things is that there is, you know, a number of specialized health and safety personnel in each organization who are responsible for health and safety, and then everyone else is not. This is changing, and this has to be changed. So this is what I meant by everyone is responsible for managing risks, but there is a system for risk management.
Maybe you have a problem with the voice, Dr. Abdul Latif.
Can you repeat, please, Mr. Abdul Latif?
I'm not hearing you. You are muted, Dr. Abdul Latif. Okay, the second question will be to Dr. Saim. Actually, we have more than 1, 2, 3 questions. I will select one of them. If any refinery successfully operates for 10 to 20 years, and any incident after that, how one can conclude that hazard failure could be the reason? This is a question for Dr. Saim.
Is it for me?
Yes.
Okay. Okay. So like if you take example of 2 days ago, the Indonesian refinery, or let's look at the BP Texas City refinery. We look at the actual incident, and then we pick up the HACCP or PHA or LOPA, and we see whether this was discussed in any of the HACCPs or not. If the scenario was not touched or not discussed in HACCP, and it has happened, then surely there is fundamentally something wrong with the way we do our HAZOPs or PHs. And that's what the CSP study found. Yes, please.
Could you repeat it again? Because I couldn't hear you.
Okay, what I'm saying is that okay, you have to look at the cause of the accident.
Okay.
Okay, so look at the cause of the accident, then take out all of your PHAs, HAZOPs, or whatever studies you have done, even your QRAs. Take out those studies and see whether those studies include or have discussed the scenario that has happened. If the scenario has not been discussed, and as the study I have quoted, in 100% of the accidents, those scenarios were not discussed, which means there's fundamentally something wrong with the way HAZOPs are carried out.
Okay, thank you very much. We have another question for Mr. Amin. What is ILO, a plan for training labor? A plan, sorry. What is the ILO, a plan for training labor? Dr. Amin, Mr. Amin.
I can't hear you well. ILO plan?
Yeah. What is the ILO plan for training laborers?
Okay, for training worker.
Yes.
As mentioned during my presentation, we engage workers and employers representatives in all of our activities. And part of the support we provide is on capacity building. It includes comprehensive capacity building programs to workers as well as to employers representatives. And these capacity building programs are implemented either directly face-to-face, but now there are some restrictions with COVID-19. We also organize such programs through our training center in Turin in Italy. We have a big international training center which provides all types of occupational safety and health courses. And every year we provide fellowships to workers to participate on those courses. Since the COVID-19 crisis started, we have been organizing many distant learning courses and online training programs. And if somebody is interested from the workers and employers representatives, they can write to me, and I will see how can we enroll them in those courses.
Thank you very much. The last question to Mr. Saim. The question is, apart the general aspect mentioned like leadership and overspeed or multitask, which are common and impact even environmental studies, what are the technical cause of failing HAZOP and LUPA? Thank you very much.
Okay, so some of the technical causes were discussed yesterday by Dr. Abdulaziz in his presentation at the end of the day. I repeat very quickly. One is unavailability of the ground data, the PSI package. Two, ignoring the ground realities. For example, I give example of the lock open. In one HAZOPs, we consider locked open as a safeguard against inadvertent closure of a valve. During the HAZOP break, I went out into the field and I saw there were many valves marked locked open or locked closed on the P&ID, but in actual they were not. There were no locks. So we have to see whether we are basing the HAZOP based on actual operational practices or not. Another case is taking credit of alarms, where we do not even have any written procedure to respond to alarms, but operations will claim we will take it as a credit. We will take corrective action based on the alarm, irrespective whether there are adequate response time available or not. And one of the technical question that comes out when taking credit to alarm is the human response. And human factor specialists know that, okay, it's one thing to have the response plan available, response procedure available, response time available, okay, fine. The other thing is, what is the condition? If we go back to yesterday's presentation on the confirmation bias, sometimes the operator believes that alarm is false. In terms of like the Gulf of Mexico incident, we were not considering the indications as something is going wrong with the confirmation bias. The other thing is the mode. Is it a normal emergency, a normal operation alarm, or is an alarm during an emergency shutdown? There's a hell lot of difference. The human error rate in a normal situation is, say, 1 in 10 or 1 in 100. But the same human, if he gets an alarm and needs to respond in an emergency situation, the human error rate is 1 in 3. A hell lot of difference. So we need to look at a number of technical things which lead to these factors. And because this is all linked to the risk ranking we do in Hazard Circle. So if we take undue credits of things, our basis is not as is on the ground, you may end up under designing, which we never realize.
Okay, thank you very much for this good answer. And by this will be the last question. And let me, in behalf of our community organization, to thank all our speakers in this session, and also thank to my colleague, Mr. Engineer Yaqub, to moderate the session before me. Thank you, Dr. Azmi, Dr. Stephen, and Mr. Dr. Abdul Latif, Dr. Saim, and also Nur Al-Qudos, Amin Redat, all of you, thank you very much. And now we have our colleague to distribute the questionnaire. Now he will distribute, and I think you can see now the screen. There are some questions. They can answer it and run the polling. After finishing the polling, we will go for the next session. We will start shortly after exactly 3 minutes, and the session will start soon. And I will ask Dr. Faisal Khan to be ready for the next session. And also my colleague Shaima, she is going to moderate this session. So at the meantime, you can see the polling now, and we will see the result soon. Again, thank you very much for your participation, and see you again. And we are happy that we have now a good participant at the same time, more than 700 participants now, if you can see it. Is it okay?
Mr. Chair, can I share the presentations or should I wait for announcement?
Okay.
Thank you, Dr. Faisal.
Good evening. I would like to welcome everyone in this second session for this day, and welcome our first key person in this second part, Mr. Faisal Khan, Professor and Canada Research Chair Associate and the Dean of Graduate Studies, C-RISE Memorial University, Canada. Our title of this lecture is Lesson from COVID-19 Safety and Risk Engineering Perspective. Please, Dr. Mr. Khan, you can share your presentation. Mr. Khan, you can start.
I hope you all could see the presentations.
Yes.
Okay, very good morning and Assalamu alaikum for those who are following the faith. Thank you for the invitees, and this is being a great pleasure for me to be part here, and I'm happy to see some of my colleagues and friends to being part of today's discussions. The place where I'm in is very, very early in the morning, so as you could see, the sun is trying to come out. What I'm hoping to talk today is give you a perspective of what we all are passing through is COVID-19 and what lessons have we learned both in its occurrence and what engineering principles could we or should we be using it in order to manage it in a more effective or better way. And then towards the end, I will summarize some of the findings of our recent work. So first, let's quickly ask ourselves that where we are since. So in a quick summary, we have been 400 days now to this particular pandemic, where at least from where I come from, about 360 days of complete lockdown. Means I'm living in the periphery for about 5 kilometers, haven't traveled more than or beyond 5. And the questions remain, well, we are passing through this challenging time, but what we have learned. The two quick messages that have come out to us in a loud and clear, as we often see by our industrial accidents also, the prevention is better than cure and protection is the must. Now, the remaining part is where I'm hoping to focus, how the principle of safety and risk engineering benefit us to better manage the pandemic risk. And that is particularly from our process industries, from our supporting services who has been greatly impacted, but being critical in nature need to continue operate, unlike many of us who could operate remotely. So how do and we should ensure that that takes place? So my first and foremost is what we have learned about occurrence of this pandemic is something that has come out of simply an act of God, or have we been given a sign of it and we fail to recognize? And towards this end, I will briefly play a video of Bill Gates of a talk which he gave in 2015. So please bear with me for a minute.
When I was a kid, the disaster we worried about most was a nuclear war. That's why we had a barrel like this down in our basement filled with cans of food and water. When the nuclear attack came, we were supposed to go downstairs, hunker down, and eat out of that barrel. Today, the greatest risk of global catastrophe doesn't look like this. Instead, it looks like this. If anything kills over 10 million people in the next few decades, it's most likely to be a highly infectious virus.
So, my dear friends, this is 2015. So you're talking about 5 years before we hit that pandemic. So it is not something that we haven't, or the visionary folks haven't seen it. We had Ebola, we have in Canada SARS epidemic, we have H1N1, and we have Zakia going through as we are through pandemic COVID-19. So there were clear signs of that something major in form of infectious disease is coming. It's simply lack of preparedness from our end had made us to be where we are today. And that's the focus of my talk today, is that likewise in industrial operations, we often consider accidents as simply an act of God. But if we really look into deeply, we see the sign of its initiations or occurrence early. And those of us who have prepared for such eventualities, able to cope and manage it better as compared to those who react to it. So my key questions or key comments remain to be today, should we learn to respond of a situations like this, or should we react to it? And that's something which I'll leave with you to be ponder on for the next 15 to 20 minutes. In field of safety and risk engineering, we often undertake detailed study of any unwanted situations, and we prepare for it so that we can better respond. The activities we undertake as a part of risk assessment to identify what could go wrong, and then we try to qualify or quantify how likely it is, and what it would cause if it occurs. And these outcomes we combine to quantify the risk and subsequently design the management plan to minimize this risk. And this minimization plan or management plan could either be the policies development so that we can able to develop guidelines to manage things better. And that is how our highly hazardous operations such as nuclear industries, chemical industries, or high other engineering projects often work forward. So in case of pandemic, we have the similar challenges. We have human sufferings because of the infectious disease and causes, but that also having issues with our economics, with our other part of our economic system. So when we try to flattening the human suffering, that has to be in combination of the financial and other resources. So through the process of risk assessment, we should be able to identify the policies and procedures that help us to prepare better to respond to such conditions. And in industry, we do that all the time for many of us who have been proactive and deal with hazards on a regular basis. So how do we do that? Using the principle of safety, as we talked about, there are 8 different steps that we undertake as a part of responding to a evolving condition. And I will cite example of all the 8 steps with relation to the pandemic as we are passing through. One of the key elements of these 8-step process is identifying what we call early fault or a case detection. So in the process industries, which deals with hazards, we set up indicators that give us an idea that operations is going beyond normal. And we often call them or characterize them as an abnormal operation. These abnormal operations give us an indication that there's something somewhere wrong. We may not know where and when it's happening, but at least we have outcomes that tell us the sign. And these early indications help us or prepare us to be able to look deeply and find the source of that particular effect. When we apply to pandemic, we have seen that those countries who have acted early in identifying the calamity or the impact COVID could have prepared themselves. Taiwan comes out to be one of the great championing in that, who saw the early sign of it and sealed the border and protected the populations with a very effective management strategies of how they cope up. And that's perhaps the reason why they have, though closest to China, but had one of the minimum caseload. Once we have identified the problem, that there is something major coming because we saw the abnormal operation, the next is to identify the vulnerable group or susceptibilities, the abnormality which we are observing in our process system, where and how could it impact? That's the key aspect for us to be able to clearly understand and analyze where the system could fail. Because if you take a process system, a high pressure in the pipeline, while might be doable with a pipeline, but it might have a severe impact on the reactor. So we need to identify and protect our critical equipment as we are managing this abnormality. And likewise, in a pandemic, if we could have applied the principle and identify our vulnerable population, such as our seniors, such as our healthcare professionals, such as those who have immune deficiencies, we would be able to prepare and protect them better so that their cause rate would have been lower. And that has been an example of many countries who have, rather than isolating the whole population, have isolated the critical group far more restricted than the normal population. And that has helped them better. Once we have identified the vulnerable group, we try to develop the risk scenarios. And that risk scenarios must be holistic in nature, means they consider both fatality and associated risk. In the pandemic situations, many countries had tried opting for a lockdown as a quick, easy measure without realizing the greater impact it could have. And India is an example of it. While they had the first round of pandemic and they locked down, that created a very chaotic situation in the country, perhaps left millions of people on the street as moving through from point A to B. So the country need to consider holistically that how the scenarios they are dealing with, action they are proposing would lead to evolving risk scenarios. And it is proven now that the impact that this exodus in India had a significant impact to the overall COVID cases. Had it been not locked down and better managed, perhaps it would have served a bit more effective way. Now, once we have identified the scenarios, it is time for developing the response. So we now know the problem. We know who are the most vulnerable populations. We know how the situation will evolve if we take an action. Now it is time to develop the policy, procedures, and actions. And that's what we do in our industrial operation. So in the pandemic study, we have series of actions, right, more extreme lockdown to the social distancing call. Each has its impact, each has its probability of failure because of the nature they are. And we consider both aspects as a layer of protection, as many of our colleagues have already spoken about. Once we implement that, our develop a response, we implement these response in a hierarchical way. Means first initiating actions that try to eliminate the possibility of the spread and its impact. And that's the key aspect for our studies. That's something which we are very dear to our heart and we strongly recommend to follow. That first we try eliminating the hazards, then we develop the controls, and then administrative control, and then PPE. So if we take this example to pandemic, we try to remove the pathogens. That means isolating the populations, those who are highly vulnerable, by ensuring that pathogen never comes to that particular location. And then we develop the controls, which means using the basic barriers, physical barriers, so that we can able to maneuver between the people who are likely to get infected to those who are not. And then administering the control, monitoring it. And the last is the personal protective gear, such as what we use these days as a face mask and other activities, or washing hands. So all these play an important role, but they all have their protection. They all have a cheese model, a holes which can lead to fail. So they need to be implemented in a hierarchically structured manner so that we know where and how they're likely to fail, so we can prepare accordingly. Once we implement these responses, we undertake that how the response likely to be once these are implemented. And that's the numerical studies we often take. And both medical scientists in epidemiology undertake these detailed study to see the effect, how in the conditions when we design an intervention, this intervention will likely to be causing an impact or making an impact. So here in the slide, as you see, we have a no response expectations based on the known cases. But as we develop interventions, we see how the scenario would look like. So this is the roadmap which we have simulated. So we know that if we do the lockdown, the next 30 days, this is the caseload would look like. And this helps us so that we know what to expect. And we move to the next step to see if the expectations are meeting. The lockdown which we designed, has it been giving the results we are hoping to get? And if not, then there's something somewhere wrong. And that we need to revise it immediately without further delay. The same thing which we do in our processing facilities. When we take a control actions or a safety measure, we monitor its effectiveness to ensure that the action is serving its intended purposes. And if it is not, then perhaps we need to look into more detail and design accordingly or revise the response accordingly. And that's an important part, because if we do not have this step, we will be continue living ourselves in a dark room, thinking we took the right action, but for some reason, the response is not as expected. And this will make us to go in a darker situation. Once we have this active plan where we have planned to change the plan, we are moving forward into a more what we call a resilient system, which means we now have a system that is adaptable to any impact they receive. And that's our best hope. In the pandemic situations, we wish to have that we have a population which is has herd immunity, which means they have built the resistance to the virus. So even if there is a possibility of a pathogen active, will not have a chance to spread. And that is the resilience in the community we all wish to have. In the processing facilities, also likewise, we design and operate our plant so that they are able to, or plant is able to handle certain level of fluctuation or abnormality without causing the disruption. Or in case if there is a disruption, it reverts back to its normal or close to the normal operations. So this resilience building is not a one-step, but 7-step process to achieve this 8th step. And that's where my key message is that there is a lot what has been undertaken in process system engineering related to safety that help us to guide in this pandemic. And to demonstrate that how effective could it be, we have undertaken a detailed study of some of the global nations, countries and cities. And I briefly mention these work, which one of our graduate students is submitting as a doctorate thesis, is that we develop the tools that help us to monitor the pandemic risk and then consider different criteria of the evaluation technique and manage these risks effectively. So if, for example, we propose a pandemic risk model, which has been communicated and published in the journals. And this risk model follows our traditional, what we do in industry routinely as a layer of protection analysis. So it considers a hierarchy of safety, right from elimination all the way to a procedural safety through the PPEs and other mechanisms. And this helps us to relate the work we do in industrial environment to things which we are observing in our community. Using these, we can able to identify threat, the uncertainties associated with that threat, develop the actions and the command action. So these 4-step process give us the basic understanding and control of the situations to manage the risk. Please remember, we are managing the risk. We are not able to get rid of the pathogen at this stage. We are living with it, but managing it in such a way that its impact remains to be the minimum. It's the same way as in our processing industries, we see the disturbance coming routinely or frequently, but we have built a system resistance so that they are able to absorb these abnormalities and continue to operate. Here is what individual risk models which we have used to demonstrate that help the actions planned and executed in the best manner would give us the idea or situation where we are best hoping for. Example, here from a city of St. John's where we live is how pandemic would be when we have no response to how different responses would be when we take the lockdown, social distancing, and personal protective gears to take place. And these outcomes, what we been is reported, compared, and validated against the field observation. And it's being pleased, I'm pleased to mention that has been observed that these serve the purpose the best. So by using the mechanism of risk management, we could able to better understand evolving situations and design strategies to manage them effectively. With this, I will conclude that pandemic risk is a lot to learn from industry. Likewise, industry has a lot to learn from evolving situations such as pandemic. We have tools and mechanisms in our hand that help us to guide on to these situations to manage better. My basic element of today's talk is to convince you that using the existing knowledge and tools, we can prepare ourselves to respond to a situation like pandemic or an evolving accident situation in our processing facility. If we do so, we will be in far better situations as compared to we react when we see the challenge we are faced. With this, thank you very much for the learned host to invite me, and I'll be happy to take questions on these.
Okay, thank you, Mr. Faisal Khan, for this useful lecture. And my colleagues, Yaqub, want to ask some questions.
Good afternoon, Mr. Faisal. Good morning for you. for very interesting, informative, and integrated presentation. I have questions. We know that the ISO standard, we have occupational health and safety standard, ISO 45001. And we know that due to pandemic COVID-19 issues, ISO specialist for the how to treatment for the COVID-19, ISO 45005. There's some efforts for integrations of the process safety management system with occupational health and safety, and maybe we have questions about the standardizations of the process safety management system. Do you have or do you support the efforts for the integrations between occupational health and process safety management system? And we know a lot of accidents was happened during this COVID-19 due to the lockdown and reducing the number of the employees.
So thanks, Jakub, for a good question. Yes, first, yes, there are many accidents reported due to the actions taken as a reaction by the government or the policies that led to a serious accident in industries. Yeah, that happened across the globe. There are far more in India and China and other countries where the lockdown was quite severe and they didn't have proper planning of how to manage these systems. Other nations have developed what we call as to be industry as a critical operations, and they had the flexibility to manage them a bit better. Your second part, does the occupational safety and process safety have an integration? My answer is yes. These are just like 5 fingers in a hand. All the safety elements are these fingers. You could continue to say this is middle finger, this is long finger, that's all good. But when you talk about the hand, which is what our aim is, all these are integral part of it. So my dear friend, whether we call engineering safety, occupational safety, process safety, nuclear safety, and all these, they're all important integral part of our hand. If we want to remain safe, we need to understand them, their interaction, and manage them in the most effective way we can.
Thank you for your presentations. I have interested for your presentations how to integrate the method for treatment of the COVID-19 and how to integrate with the process safety management system. Mrs. Shaima, please.
Okay, I have another question. You said that the lockdown does not give the result for the world. Do you think that the world will go to the perfect to deal with the pandemic COVID-19 in next days?
Mr. Sharma, I wouldn't be able to say the perfect, but for sure we would be better prepared for a next pandemic once it comes. And if we fail to learn from this and adopt ourselves, then we are going to be doomed. And this is one of the important message I wanted to convey, is that this COVID-19 is not simply dropped from the sky. It was something that we seen happening in past. There were situations, for example, SARS in 2012, then MERS in 2014. So there were a smaller level of pandemic happened or epidemic happened, but they didn't come to the stage because they were quickly being resolved within the boundaries. So if we have learned and adopt to it, we will be resilient and able to manage better for the next round of situations. Now, the question is, will we become back to the normal post-vaccinations? Answer is no. As you all understand that industrial operations, when we have an accident and we retrofit or we revive or renovate our plant, it's not going to be the same as what it was original. In some cases, it might perform better if we have done a lot of changes, a lot of good changes by replacing the old component. But if we simply did a retrofit, then perhaps we might see situations happening again soon.
Thank you, Mr. Faisal Khan, for this useful lecture. And we'll go to the next lecture. Okay. We welcome Mr. Lee Alford, our key speaker, next key speaker. He is work in Energy Institute of Process Safety and Decommissioning. The title of this lecture, the EIPSM Framework. Mr. Lee, do you hear us?
Yes, I hear you okay, Shema. Do you hear me okay?
Yes, I hear you okay. You share your presentation and we see all the slides. And you can start now.
Okay, thank you very much. And thank you for the invitation to present at this inaugural event. Very happy to do so. And for the next 25 minutes, I'm going to be talking about the Energy Institute Process Safety Management Framework, which I have been involved in quite closely for the last 2 or 3 years. So just a little bit about myself. I actually graduated as a chemical engineer back in the mid-80s. And the first half of my career was very much in industry, supporting frontline operations, in safety, in quality, process improvements, and also line management roles as well. In 2000, I began to manage a European company member network, which was dedicated to process safety. And since 2017, I've been supporting the Energy Institute Process Safety Committee and developing its program for process safety and decommissioning. So what I'd like to do is just give you a background to the Energy Institute first off. Okay. So the development of the framework is actually supported through the Energy Institute's technical work program. That program actually publishes through its own in-house publication team 50 products per year. And that's not only in the area of process safety, that includes other themes which are supported by various committees. So these are such as occupational health, very relevant to the topic for of the previous speaker, occupational health, human factors and organizational factors, aviation fuels and fuel handling. So a real wide repertoire of themes which are very much relevant to the energy sector, both the upstream and downstream segments. So the Energy Institute is funded by technical partners and technical company members, and they get free access to all of the Energy Institute products and publications, and these can number anything from research reports through guidance, through briefing notes, animations increasingly as well recently. And if you don't do anything else as a result of what I'm about to say, please visit the EI publishing site and avail yourself of free-to-use the free-to-use process safety management framework and the guidance for each of the elements. They're free to download as long as you use you leave your registration details, so freely available. So that really does provide a background, I think, to the Energy Institute and the technical program. I'd like now to move on to just remind you of what the process safety management framework looks like. It breaks down really into 4 high-level components called focus areas. So we have process safety leadership in the blue, risk identification and assessment in yellow, risk management in green, and review and improvements. So these are the basic building blocks, as you would describe them, for successful process safety management. What we would say is that each of these focus areas are of equal importance. You can't do one without the other. They all work in unison. But as you can see, there are different number of elements in each of these focus areas. So we have the process safety leadership focus area breaks that down into 5 elements, risk identification into 2, and then we've got 11 for risk management and 2 for review and improvement. So they really do describe, I feel, the life cycle management of a high hazard asset. And another way of depicting the framework would be to, and this is really a conceptual view, is to see the framework very much like the Swiss cheese model. Each of the focus areas there, with each of the various elements, and we need to get those barriers right in order to prevent hazards from being realized and creating an incident, causing an incident on the right there. Now, holes do open up in the barriers, but we have to be careful to monitor the flaws and deficiencies in each of these barriers, because if the holes line up, then there's a pathway then from the hazard right through to the incident. This could be result in a near miss. This could result in a loss of containment. If there's a loss of containment, then that could well result in a fire or an explosion or a release of toxic materials that could have impacts both on site and off site. So I'd like to briefly explain what we've been doing with the revision, or as we're calling it, the second edition. And the current edition of the framework, the first edition, was actually published in 2010. And the feedback that we have been receiving from the field, so these are operating companies who have adopted the framework. The feedback is that the current edition holds up very well as far as covering all the bases with respect to process safety management. And for the last 2 years, we have been debating amongst ourselves whether we do need to add in maybe additional elements or additional expectations, or maybe we need to reorder some of the elements into different focus areas. But the news, I guess, is that, and I hope it's good news, is that only modest changes have happened to the 20 elements and their expectations. But the new revision does explicitly acknowledge the risks that are posed by cyber threats. So these have come into prominence, I would argue, over the last 10 years. And also the threats that are posed by natural hazards. So natural hazards, extreme weather events, and the impacts of climate change. So these do need to be, I think, explicitly acknowledged. Also new ways of working. These have come into prominence certainly in the last 12 months with the COVID-19 pandemic. So talking about mention of remote auditing and remote ways of working. And another difference is that the second edition will make more explicit references to human factors considerations and even break down the topic of human factors. Human factors can unpack into various topics such as fatigue and shift handover, organizational change. So there's a little bit more mention in the second edition in respect to those topics. So the core of the document, as I've mentioned, has only undergone modest revision, but there's been more significant changes to the introduction and the annexes. The introduction describes in greater detail, gives more of a help as to how the framework can be sold into an organization. We've introduced new concepts such as the sand cone model and the 6 tenets of process safety, which Dr. Stephen Bater mentioned in his presentation earlier on today. But the annexes, there's one annex which has been added, which is gives some information on how to implement the process safety management framework. So where to start, where you might start to prioritize. There's also an example, and it's a real life example, although it has been anonymized, on the use of the process safety management framework as a self-assessment tool, as a gap analysis tool. And finally, there's an annex on how the framework actually applies to the Energy Institute and its process safety relevant resources. So it's all very well and good, the Energy Institute saying, use this framework, and yeah, that's fine. But we have also started to use it internally within the Energy Institute to look at our ongoing program for process safety, and it's also used as almost like a gap analysis. So it's just one of the factors that we use now in developing resources going forward. So I'd just like to take some time out as to what has the Energy Institute actually produced, as well as guidance for each of the framework elements in recent years, which may be grouped under the 4 focus areas. So for focus area 1, process safety leadership, I think it's of interest that not all process safety relevant publications are produced solely through the Process Safety Committee. Those particular
Mr. Lee, do you have any problem?
We will wait
Mr.
1 minute.
Lee.
We will wait 1 minute.
We will wait 1 minute, and then when we switch to.
Mr. Lee, do you hear us? We will wait for 1 minute, then we go to the next lecture. Okay. I would like to welcome Mr. Arturo Trujillo and Mauro Gotti, Global Director of Process Safety Consulting, Decara, Spain, Technical Operations Manager, Decara, Italia, Process Safety, Italy. Our title lecture, Are You Lucky or Good? How Organizational Process Safety Protects.
Sorry? Shall I continue?
Yes, Mr. Lee, you can continue.
Yeah.
Sorry, Arturo.
Okay. Okay. So yes, the Energy Institute will actually commission specific research to support its guidance, and not just necessarily dive into guidance without the evidence to actually back up the fact that there's a need in a particular area. And then risk management, a number of guidance documents have been produced, which are very much fit into the focus area of risk management. And then finally, review and improvements, documents that have been developed through the Human and Organizational Factors Committee and also the Process Safety Committee. So there's a report, Learning from Incidents, Accidents and Events, a couple of research reports very much related to the use of key performance indicators, and also some guidance on the use of an incident investigation tool, Tripod Beta, where the Energy Institute is very heavily involved in the promotion and development of its use. So finally, I'd like to mention that the Energy Institute's training function has developed a new e-learning course, Introduction to Process Safety Management. And of course, there's quite a few training providers who have started to look to online training over the last 12 months because of COVID-19 and the pandemic. And this training course is very much based on the process safety management high-level framework. It's been modularized, so some of the elements in the framework have actually been brought together under a module so that they're of equal weight. And the modules comprise pre-recorded training presentations, case studies, exercise and assessment components as well. And there's also, on completion of that training program, a certificate of completion. So again, I would urge you at a minimum to find out the website for the process safety management course, and avail yourself of the free module 1 on what is process safety management. So yeah, that concludes my presentation, and I'd be very much interested in taking any questions. Thank you.
Thank you, Mr. Lee, for your useful lecture. Okay. Do you have any question? Mr. Yaqub.
Mr. Lee, I have one question. We know that the biological hazards normally not addressing in process safety management system standard. It's normally addressing in occupational health and safety. We know that the COVID-19, we know that the EI issued many publications about EI JIG, about the aviation fuels and the thing related to the system of the airport. Do you think that it must to issue some publications for how to addressing the biological hazards, especially the consequence impact of the company related to the COVID-19, especially the reductions of the peoples during the lockdown?
Yes, I do. The Energy Institute has published, I think, a bow tie, an example bow tie for operating companies to visualize the barriers to COVID-19, and that's received some good feedback. As far as the framework, though, Yakub, the high-level framework, the framework itself, and certainly there's an element called hazard identification, which is element 6. The framework is neutral as far as the hazard itself. So there's no details supplied on the type of hazard, because I think if we were to go into each of the hazard types in that document, it would be far longer as a document. So there's nothing specific about biological hazards in the high-level framework. There's nothing specific regarding toxic hazards or flammable hazards. I think it just treats those hazards as a hazard, and then the process for identifying hazards and control measures or barriers is very much part of the process.
Okay, another question is Mr. Lee about the successful implementation of the EI high-level framework in the industry. We know that's the standard. You have maybe very in the future, in the near future, will be published the second edition. Do you published already? The same questions for Dr. Stephen. The implementation, the successful story for the implementation of the EI high-level framework in the industry.
Yeah, there is an annex in the second edition, which does describe how you might go about planning for the implementation of the framework, and suggest some priorities as well. As far as success stories, we have, as the Energy Institute, we don't have a formal link with operating companies that have adopted the framework. So what we like to do is we would prefer to promote the framework, and then for companies then to choose whether they adopt the framework. So we don't necessarily follow through the use of the framework from various operating companies, but anecdotally we do know that there are several organizations internationally who have adopted the framework in their process safety management systems. So it's a very good question about success stories, but we haven't contemplated publishing those success stories. I think we would feel that it's down to each of the organizations, the operating companies, to adopt that, and if they want to present on their success story, then probably it would be better for them to do so.
Thank you, Mr. Lee. And we are going to next key speakers, Mr. Arturo Trujillo and Mauro Guti, Global Director of Process Safety Consulting, DECRA, Spain, Technical Operations Manager, DECRA, Italia Process Safety, Italy. Are you lucky? The title of this lecture, are you lucky or good? How organizational process safety protects lives and life. Can you hear me?
Yes, I hear you. Can you hear me?
Yes, I can. Please share your presentation. And let's start.
السلام عليكم. يسرني كثيراً أن أشارك في هذه المحاضرة. سنلتقي شخصياً في المرة القادمة إن شاء الله في عمان. أتكلم اللغة العربية قليلاً لكن الآن سنتكلم الإنجليزية. Dear colleagues, I just introduced myself saying that I've been working in process safety for the last 25 years. And looks like a huge time span, don't you think? during this time, we have seen so many changing, switching from analogical PLC to fully digitalized DCS, Internet of Things. And we would expect that more or less the same change would have impacted the process safety accidents. But if we look at the numbers, we see something quite different. If we look at the small accident, like a very small loss of containment, the number has indeed decreased. But if you look at the huge one, the disaster that has been shown, analyzed, and detailed by our colleagues in these days, they are still there. And the question is why they keep happening. And Director Trish from IKE has illustrated that most of them are related with the human errors. How can we bring process safety and human behavior together? And our process safety director, Dr. Arturo Trujillo, will show you and all of us the tool that we have developed in the last years in DECRA to bring those things together, and we call it organizational process safety. Just a few words about DECRA. We are a huge firm in the testing, inspection, and consulting sector. We do process safety testing in our own labs for the properties of dangerous materials. We do process safety consulting, training, competence development, and all other issues related with the services related with the process safety. At the moment, our team can consider 120 process safety specialists, most of them chemical engineers. So typically when a huge firm or a small company come to us, they are asking for ASOP, management of change, cultural assessment, QRA, training, testing. So what's going on? Why are they asking this? What they are looking for is an increase, an improvement of their process safety performance indicators. And the way to achieve this is what we are trying to give you to help in this difficult path. So I leave it to my colleague Arturo. Arturo, can you join in?
Yes, sorry, I was trying to share my screen. Yes. So when we receive this type of request, something that we typically ask ourselves is, and ask this client that is requesting a HACCP, is why do you want to HACCP all your processes? Or why do you think you need to improve your management of change process? Or why do you need a cultural transformation? As Mauro said, typically we want to improve our process safety performance, and DECRA has developed organizational process safety, or OPS, to do that. Why we developed OPS? First of all, you will see a few quotes in this presentation, quotes from people smarter than us, certainly smarter than me, from the past. The first one is from William Thomson, Lord Kelvin, the guy that invented the thermodynamic scale of temperature that we use today. It's long, you can read faster than I can speak, and you will get the presentation anyways. But a former boss of mine used to summarize it saying, if you cannot measure it, it doesn't exist. So that's basically where we stand in terms of process safety. If you cannot measure your performance, and that is the same for every aspect in life. If you don't measure your performance, you are not going to improve. And amazingly enough, that was also one of the conclusions of the Baker panel after their investigation. Keeping track of your performance is an essential condition to improve. Or in our own words, if you don't know where you are, you don't know how far you are from your target, and you don't know which direction you need to start to move. traditional auditing doesn't necessarily cover these objectives because they usually try to measure compliance against some standard. So you have a standard for, I don't know, for environmental management, for energy efficiency, for whatever. And what you are doing in an audit is making sure that you comply with this standard. And typically, this type of audits do not take into account the softer elements, the cultural and capability elements. So at DECRA, we believe that the relationship between these technical elements and the organizational elements is key to ensure the appropriate performance in process safety. And that's a second sentence that we like. That's from Carl Gustav Jung, the famous psychologist. And that is also applicable to many other aspects in life. You are what you do, not what you say you'll do. And we have seen many times around procedures for, you name it, HACCP, management of change, anything related to process safety that look fantastic on paper, but don't work very well in real practice. And I think one of the former former speakers spoke about why HACCPs and LOPAs fail. They look fantastic on paper, but they don't reflect reality. On the other hand, the quest for excellence in process safety is a never-ending journey, but a thrilling one. And the steps to perform this never-ending journey are always the same. You assess your maturity level, then you identify areas for improvement. You apply some changes to start improving these areas. You monitor continuously the impact on the organization, and of course, you enjoy success and celebrate wins before restarting the wheel by assessing organizational maturity again. To measure, to go along this trip, this journey towards excellence, you need a roadmap. So a way that a mechanism that tells you where you are and in which direction you go. So that's in our analogy, that's a GPS navigator that you have in your car. It tells you where you are and in which direction you want to go. And a vehicle, the system, the process safety management system that you're going to build. And you have the order of these two elements is not at random. You need first to understand where you want to go, and then you can choose your vehicle. I mean, if you are going to have tea with the Queen, that Rolls-Royce would be a fantastic vehicle. But if you want to go across the sea, then you need a different type of vehicle. So that is the system. We have created this OPS. We decided not to invent the wheel. We built on top of the CCPS element, the CCPS model. We grouped a little bit differently the 20 elements. We grouped them in 7 what we call work streams, 5 of them technical and 2 organizational and cultural elements. So culture and capability. And on top of that, we have built a ruler. We have built a system that allows us to measure maturity in every one of the 20 elements and every one of the 7 work streams. So for every one of them, we can decide whether this element is ranked as burden, necessity, priority, goal, values, or world-class. Again, you will receive this presentation afterwards, I understand. So I will not go in detail in every one of those categories, but clearly burden is something that stays in the way and prevents you from doing something else that you want. And we will understand what world-class means in terms of anything. So how it is typically one of these OPS assessments done? We first request some preliminary information. With this information, the paperwork, these documents that may look good but not reflect a real performance. Then with these documents, we analyze them, we digest them, and we build an assessment plan. And then once we hit the site, we have a kickoff meeting to explain the assessment plan. We do site activities, tours, and interviews. And we want to emphasize that while the team of assessors is at site, what we do mostly is do things that need to be done at site. So we speak with people at the site. We look at how the site looks like, how operations are conducted, and this type of thing. So we are not looking at papers during our site visit. Then we have a closeout meeting where we can advance some results. And of course, we issue a final detailed report with this GPS, with this position now and the direction you need to go. So the score on every one of the 20 elements and 7 work streams, and also a list of suggested interventions for improvement. That's the type of result that you get from the assessments. Lots of tables and charts showing you what is your score in every your maturity level in every one of the work streams, and also a list of selected interventions. We have digitalized this measuring tool, of course. So it's in what we call the DECRA safety platform, a cloud system that allows us access from anywhere and collects data in a central location. And that is our GPS. As I was saying, you get this current position, your direction for improvement, and also a set of KPIs or waypoints to measure that you are moving in the right direction. So then we can go back to our initial question and ask ourselves, why do you want to do HACCPs? Because HACCPs are the shortest path or the easiest way, the low-hanging fruit to improve my process safety maturity. Or you want to do a cultural transformation because you have objective measurement that your culture is what is preventing you from a better safety performance. The advantage of this methodology.
Mr. Arturo, you have 2 minutes.
Perfect. Thank you very much. So we can obtain an accurate picture of the performance. This picture is objective, precise, repeatable, and reproducible in the usual terms of any measurement system. It identifies optimal interventions to improve organizational maturity, and it uses a reliable metric allowing benchmarking across sites, geographical areas, business sectors, or whatever. And that was my last presentation, my last slide. And as I understand, we will have an open discussion afterwards. So that was it. And we will be, Mauro and I will be happy to try to answer any questions that you may have.
Okay. Thank you, Mr. Arturo. My colleagues, Engineer Yaqub, have a question. Please, Mr. Yaqub.
Mr. Arturo, you said that you have KPI or key performance indicator or success performance indicator for every process safety elements. What the KPI for the process safety culture?
Oh, it depends. It depends on the because we perform. I mean, we have a standard list of KPIs that we can use for culture. That's clear. But then the advantage of the method is that we can fine tune the KPIs for the specific what we call key features, essential features and key elements inside the element where we find the weakest point. So if in one element, perhaps you are scoring low, but you will have some strong points in this element and some weaker points. So then we issue some recommendations to improve on these weak points. And of course, the KPIs go strongly linked to these interventions. So you need to measure that your interventions are being successful. So out of this list of maybe in case of culture, I'm speaking from my heart, but I think it's like 20 different KPIs. We need to select those that will measure that you are applying successfully the suggested interventions. if you can send me an email, I can send you like a list of the KPIs for the cultural elements, at least the global list, and then you can have a look.
Sure thing.
Thank you, Mr. Arturo and Mauro. Next, our key speaker. Next, our key speaker, James McVeigh, Principal Advisor, Mechanical Integrity, Meteorology and Corrosion, Mistras Group, USA. Our lecture title, Damage Mechanism Reviews, Some Shared Learnings and Practices Regarding the Process Itself. Mr. James, do you hear me? Mr. James?
Okay, there we go. Sorry about that. Let me go ahead and share my screen then. I'm going to, let's see.
Yes.
Do you see that okay?
Presentation and let's start.
Okay, let me go ahead and blow. Can you see it?
Please share it. No. Yeah. Please share your presentation.
Okay, let me go back again. Okay. Can you see it now?
Yes. Start.
Okay, very good. Oops. Let me go back and blow it up somehow. There we go. Can you see it okay now? Full screen?
Just yes. On the full screen, please.
Okay, it is full screen now. Can you see that?
Not yet. Resume slideshow, yeah.
Where's the full screen? Slideshow. From beginning.
Yeah, resume slideshow.
Okay.
Okay.
Hello. Okay. Hello. Okay. Well, let's go ahead and get started. I'm not sure what you're seeing, but the large and small. Anyways, my name is Jim McVeigh. I'm with the Mistras Group, and today I'm going to talk to you about damage mechanism reviews. I'll offer some description of what they are, and I'm going to give you some shared learnings and practices regarding conducting the reviews themselves. Briefly, a little bit about myself to give you my background. So again, I'm with the Mistras Group. I'm the principal advisor in mechanical integrity, metallurgy, and corrosion. Though I spent 30 years in oil and gas as everything from a corrosion engineer through inspection management to a corporate director of a mechanical integrity program for major U.S. refining company. And I'm a metallurgical engineer by education. So that's my background. Let me go ahead and get started. What I'd like to first do is this is kind of where the rubber meets the road, right? This is the damage mechanism review is the foundation of the mechanical integrity element of a PSM program. And let's go ahead. I'm going to move through some of these slides because I gave you lots of reference material to use this document to help ensure you're conducting your reviews well. This is sort of a damage mechanism review is a study of a process unit's process, design, materials, and history. And the history is everything from operating, inspection, and maintenance history to determine potential damage mechanisms that could impact your equipment and piping and everything holding hazardous materials in your unit. And you're trying to determine damage mechanisms for all that stuff, and also the corrosion rates and it's sort of a measure of the vulnerability of those damage mechanisms as they impact your equipment, specifically with regard to things like cracking mechanisms and so on. And you do all this stuff for two things, right? One of them is for risk assessment, and the other is for inspection planning itself. You want to make sure your plans are effective for addressing damage mechanisms that are actually affecting your equipment, and not just developing some sort of or executing a canned strategy. So I gave you an example on the right, and it's a little bit fuzzy, but in the final presentation, you'll get the clear document. And this is sort of what a report looks like for maybe a piece of equipment in a unit, and it's to give you an idea what the deliverable looks like with these types of reviews. So at the very top of it, you're going to see you're going to see a description of the system or the equipment. In this case, this is a piece of equipment in a pharmaceutical plant making very important anti-cancer medication, and so it's very important that the equipment maintains its integrity. The next section, you speak to the process conditions that the equipment's seeing, and everything that's going on, the chemistries and the temperatures and pressures inside the equipment, and also what's happening outside the equipment. What's the environment the equipment's exposed to? In this case, it was a room, but the room's being cleaned with bleach every few days, and that was impactive on the integrity of the equipment. The other thing you consider in operating, the other operating stuff that you consider is also, what are the other operating modes? Generally, we were really good about designing equipment and selecting the right materials of construction for the process, the design process. But what causes equipment to degrade and fail often is the transient conditions, or the unusual operations, or the unusual sort of maintenance exposures that occur. So you got to consider everything. It's not just reviewing the design conditions when you do these types of studies. The other thing I like to put in these type of reports is the like special maintenance procedures you might employ to maintain the equipment, or any sort of special operating procedures. Might be cleaning procedures or sweeps or other things that you want to get documented as well. You really got to think about everything, because damage can happen in moments with some damage mechanisms, and so everything's got to be considered. You also address the materials of construction of the equipment, obviously, because it's important to figure out what degrades what. And then these reports finally, then we get to the results. You list a bunch of damage mechanisms you think are likely or could occur to the equipment, or have occurred to the equipment, but based upon your review and the history you reviewed. You'll put the damage mechanism itself, and then you're going to give like a corrosion rate or a vulnerability rating if it's a cracking mechanism. And then you speak to mitigations. Well, maybe inspection will mitigate it and to an acceptable level, or you got to do some process change, perhaps lower the temperature or reduce the corrodant or something. Another thing that's often captured in these reports are significant events in the history of the equipment, in part so they don't happen again, and or at least they're considered in managing the degradation of the equipment. You also, in these types of reviews, like to identify operating windows for the equipment based upon your review, to both validate the corrosion rates and degradation and potentials you've identified in your report, and more importantly, just to make sure the equipment's being operated in a safe manner, and that if degradation occurs, it occurs in sort of a controlled way that you can manage. And then every once in a while, you've got some special recommendations you got to make with regard to a maintenance practice you saw, or an operations practice. In this case, we got to make sure when they're grinding that equipment, they're not using, grinding wheels with iron on that stainless steel, because that could accelerate corrosion. So, in fact, I just finished a study with about 1,600 of these things, issuing 1,600 of these reports. And they're just so powerful to help people understand what affects equipment, and from an expert standpoint, how best to avoid that damage going forward. So it's a great document to have. They started producing about 15 years ago. We're getting better and better at it. Now let's talk about the process a little bit, if you haven't been involved in these types of reviews. It's not just the corrosion engineer coming in and doing, you handing a bunch of papers and he issues a report. You got to have inspection and process supervision in there. You got to have the corrosion expert, obviously, or you got to have operations, operations management, operations supervisor. You got to have process engineering involved. If you have corrosion engineers on site or those types of experts, get them involved too. And obviously the inspectors, the guys responsible for integrity, need to be in that process. And let's not leave out, if you've got some experts, process experts in the company, because they're going to want to operate that equipment the way they want to operate, they need to understand, and they can also contribute to these meetings as well. Maintenance people that touch the equipment are important. And also, any sort of chemical vendors, if you're adding outside chemicals to the process, they're important as well. So those people are important to make this process work. It's not a paper exercise. Here's a real high-level overview of what happens in a damage mechanism review. And again, it's from the owner's perspective. First off, the owner needs to identify the requirements for the study. Reference API 5 or 970 and reference 571. Any other kind of documents you have to make sure you get a good product. But that's really known as responsibility. And obviously, you can get experts involved too. The next step is the info and data gathering. And often, the way it usually works is the corrosion expert, after reviewing the process and the operation, creates a list of questions and data requests. And it's imperative on the owner that he respond to that and be responsive to the request, and also give them the best data he possibly can, and also identify sort of the expected accuracy of that data or information as well. And obviously, you got to make sure you're working off good PSM documentation as well, like the P&IDs and PFDs and so on. The next step is, after all that work is done and people, information provided and the reviews conducted, you conduct a meeting. That's so critical to get all these people together. Now, in this new world of Zoom and everything else, but get all those key participants I just talked about in that meeting. And the meeting's typically facilitated by the expert, who kind of goes over what he thought he learned. But I've sat in those meetings, and part of the job of the corrosion expert is to draw out additional information from the participants. Sometimes that's absolutely so critical to getting a successful review done. And then finally, you get a report, right? The expert will sit there and say, like I just showed you on the other page, here's the output for an individual piece of equipment. Here's what we thought was happening to that equipment, the exposures and materials of construction and so on. Here's what we think might degrade it, and here's some recommendations to manage that degradation in an effective way. And after all that's done, lots of people got to look at that and say, he understood the process, he had accurate data, and we accept the report. So that's an overview of the process. And so here's all the information that's reviewed. It's everything from operating manuals and procedures to PFDs and P&IDs, and kind of all the stuff that you guys work with in the process safety world. And then they jump into the inspection history and CML, basically the corrosion monitoring data as well. In their assessment. So there's lots of things that need to be reviewed in these studies for equipment and processes and process units and so on to do an effective study. I want to emphasize this point. You really got to make sure that you guys are keeping track of leaks in your facility and causes those leaks and so on. And you don't ever want, if a leak happens once, oh well, but if it ever happens again, shame on a bunch of people. You track those incidents, particularly with regard to what's being reviewed, and make sure it's communicated to the corrosion engineer. And he in turn is responsible for figuring out what happened in the rest of the world as well. I mean, there's a wonderful AFPM incident portal that I could tap into and figure out whatever's happened in the alkylation plant and so on. So, if it happens once, not great, but if it happens twice, shame on a bunch of people. So what's the deliverable look like? Well, you saw the report. That's a deliverable at the equipment level, but you want to make sure you have a decent report that summarizes, what was the premises for the studies and a study and a process description. You want to capture, the specific data that you looked at too. You don't want to lose that anywhere, because a lot of times, even though it might not show up on a DMR report, that was impactive on the study. And you want to keep it for the future studies too. So you gather everything and put it in a nice report. Obviously, you get your damage mechanisms identified, you get your corrosion rates identified, and again, cracking, you can't really get a rate necessarily. You got to say it's high, medium, low vulnerability, or some sort of rating like that. Also, IOWs, put process controls. You can't do a study and then turn it over and not tell them, what sort of process controls need to be in place to validate that study and the rates determined. And then some other elements are also included. And finally, technical recommendations. If you just don't think the right material is being used, or you think this thing is being operated incorrectly, need to say that in those types of studies. That's an expectation of the expert to do that, in collaboration with the whole team. Okay, some quality control stuff. Let's see. So, again, accuracy of and completeness of damage reviews are just absolutely critical. And, if you miss something, that's just too bad, because it's that kind of stuff that gets you. It's not the normal operation. Active involvement of the owner inspection process and/or operations personnel to supporting the corrosion experts, just absolutely critical to these studies. Again, you can't do this thing in a box. And then ultimately, you want people to, when that report comes out, again, I'm speaking from owner's perspective, supervisor needs to approve it, and all those people participating in that team need to approve it, review and approve it within sort of the limits of their expertise or their participation. But I'd have all 6 signatures on that final document saying, hey, I accept this report, the input I provided was accurate, and I'll go, act on the findings. Again, some more quality control stuff. The supervision should, verify the acceptability of the corrosion expert. Have some sort of standard for who you're bringing in to do the work. Establish standards for degradation mechanism assignment. You don't want to have like 6 different cooks come up with 6 different answers. I mean, there's industry standards for that, and I'll show you one in a little bit if we got a little bit of time. But establish some standards so you get you can expect the same answer, kind of whoever's doing the work for you to some extent. And the supervisor got to make sure that the process flow, PSM information, PFDs, PNIDs, and so on are accurate. I mean, to the best of his knowledge. None of this works if you're working with inaccurate documentation like that. I love this checklist. I put together this checklist when we were doing it, and I said, okay, the corrosion engineer is responsible for this, and supervision's responsible for this, and all those sort of things I talked about, and then some are kind of captured on a checklist. And before that report's finally accepted, this is as important as a well procedure or anything else you do, and you have all these wonderful checklists, critical checklists for everything else. Why not have one for these studies to make sure who did what, and it's being critically reviewed. That's why I put objective evidence in there, and then you got a checklist to validate that it was done accurately and completely. Here's some of the things that happen when you don't, at least my experience, things that have happened when we did these studies, less than ideally. Corrosion engineers, you can grab whoever, and they may not understand your systems and the impact of their decisions on your programming and your risk assessment. So that you got to get them up to speed on that, or hire people that are familiar with the programs and and corrosion control standards that you work with.
Mr. James, you have 2 minutes.
Okay.
Left.
Thank you.
Okay. Thank you.
So some other expectations there for the corrosion engineer. And then the second column there is about the process omissions. Make sure you got MOCs available, and PHAs and so on, and don't allow people to make these reviews at the PFD level only. Get down to the PNIDs. That's where a lot of the most critical information is provided. We'll skip through some of this stuff, but you got this in the final presentation. Final reports. We talked about that. I want to show you just briefly. So here's a couple examples real quick. So, this is an industry. This is what I talk about when you want a sort of a standard guideline for how to assign a damage mechanism. This is for caustic cracking, and there's some clear guidelines. Well, if it's over this temperature, it's over this concentration, I want you to assign this damage mechanism. You can work with the corrosion engineer, get agreement on that, but create some standard for that, and work to that standard when you're doing these damage mechanism reviews. And I got reams and reams of books on stuff like that. And then finally, this is the difference. So you could bring 2 experts in. This is like corrosion rates determined within the same exactly the same unit in 2 different plants done by 2 different corrosion engineers. And you can see, a significant difference in sort of the distribution of what they considered the high corrosion rate stuff with corrosion rates greater than 3 mils per year, and those with it less. And that's with 2 people that, at the surface would have been considered, fairly equivalent and so on. But but operating without some of these quality control features in place to ensure that you get more consistent results from study to study. So that's a little, just if you want to put a snapshot in your head, that's what you get when you don't have more control over these reviews and the outputs for them. So lots of information here, and please contact me if you would like to talk about anything. But at this point, I'll conclude my presentation. Thank you. Thank you.
Mr. James, thank you for this useful lecture. Now, our key speaker, Ms. Rawan Quality Manager, Marine Science Station, University of Jordan. The lecture title, Impact of Applying Total Quality Management on Occupational Safety and Health in Laboratories. Ms. Rawan, do you hear us? Ms. Rawan? Please unmute your phone.
Hello.
Hello, yeah, welcome.
Can you hear me?
Yes, we can hear you. Please share your presentation.
Yeah, okay. Okay. It's good.
No, still.
Yeah. Okay.
Yes, okay.
Good.
No, still not.
Okay. This will stop other screen sharing. Do you want to continue? I think
please continue your sharing.
you can share my presentation. Hello.
Hello. We want to start with the key speaker, Rami Harkouz. Then we will back to you. Mr. Rami Harkouz, do you hear me?
Yeah.
Mr. Rami? We now welcome Mr. Rami Harkouz.
Yes.
Hello, Mr. Rami.
Yes, hello.
A chairman of the Chemical and Petroleum Engineer Department, Beirut, Arab University, Lebanon. Our lecture title, Risk in Oil and Gas Industry, Walk through Environmental Governance System in Lebanon. Mr. Harkouz, do you hear me?
Yes, I hear you.
Okay, please share your presentation.
Okay.
You can start now. You have the mic.
Okay. The presentation is now on the shared. Yes.
Yes, it's shared. Okay.
Okay. So maybe I will stop the camera just for internet issues. Okay. If there is no problem. Okay. So first of all, I would like to thank you for giving this opportunity to be a part of this conference as a speaker. I am the chairman of the Chemical and Petroleum Engineering Department at Beirut Arab University, and this presentation is talking about different risks in oil and gas industry, and to speak a little bit to walk through environmental governance system in Lebanon. So many challenges are faced regarding offshore oil and gas activities, and many steps are currently undertaken to overcome such challenges. In Lebanon, yes, okay. So in Lebanon, existing legislations cover the majority of the environmental issues related to the oil and gas sector. But of course, some requirements may miss, like the drilling fluids and cuttings management, disposal, the produced water, and these are in general the main pollutant streams that arise from the offshore petroleum sector. And here it is important to note that the consortium responsible in the drilling operations in Lebanon, which is Total, Eni, and Novatek, has its own, if you want, a strategy that suits very well the standards, regulations. But on the public sector, these missed issues can be overcome by completing the environmental legislation framework, and it's clearly delineate the roles of the relevant Lebanese institutions in environmental management. And this will also strengthen the capacity of these institutions. So let me first and very fast to surf on the different oil and gas value chain. This will help to better recognize in later slides the environmental issues. So first, the exploration phase is to locate oil and natural gas resources by reviewing the existing geological and geophysical data, and after that, conducting a marine seismic survey, which is typically the next step in exploring an offshore area, as precise information is needed before investing in a drilling. So the result of these seismic survey is essentially a picture of various rock layers underneath the seabed. And it's important, these information, because these data are used to identify the geological structures that may contain oil and gas natural resources. So in general, if seismic data shows a geological structure that could contain oil and natural gas resources, the company may decide after that to drill the exploration well to confirm whether geological formations contain oil and natural gas. So in general, before drilling begins, companies must apply for the appropriate approvals for the relevant regulatory that includes planning for environmental mitigation and safety planning. And in this phase where the drilling fluids and different chemicals are used. So once the drilling is finished, the the hydrocarbons should be conducted to surface in a safe and controlled manner. And during these development phase, the company must outline exactly how it will produce the hydrocarbon and the environmental protection measures that will be put in place to minimize any environmental impact, and as well as the safety measures. So such as the processing and separating of the produced mixture of the oil and natural gas, etc. So after the production, we have the petroleum to be transported via tanker or vessels, drill ships, and or ships, or through pipelines, and that depends on the amount, of course, of the hydrocarbon. And here, the biggest problems are the pollution and the chance of being spilled, since it is very hard to clean up and it is very toxic to living animals. And after that, of course, we have the refining processes to obtain the different petroleum products such as gasoline and heavy products, if you want, as the tars and bitumen. So this fast introduction facilitates more to highlight the different locations where environmental risks exist. And this could be divided in three main different sectors as the following in this table. We have the upstream, we have the midstream, and the downstream. And of course, in each sector, we have its own subdivision, such as exploration, drilling, transportation, refining, and etc. So the major environmental threats encountered by different offshore phases, we have many. I will mention just few of these, and I will start by the noise effects from seismic activities. So as you know, sound is transmitted underwater, and there is potential for noise produced by seismic sources to have adverse impacts on marine animals. So because of this introduction of this additional noise into the marine environment, this could interfere with these animal ability to indicate maybe the presence of predators, maybe the food, and as a result, this could cause short-term behavioral changes. Of course, during exploratory drilling, also sounds resulting from the offshore installation, in addition to helicopters, etc. This will increase also the localized underwater noise level, and the majority of sound will be reflected off the sea surface and consequently will affect animals. Another risk is from the atmospheric emissions. So an important source of emissions is flaring into the atmosphere. And this practice is a major source of waste, as well as a significant source of greenhouse gases emissions. Also, we have in addition the rigs that are powered by diesel engines also will emit air pollutants like monoxide carbon, SOx, volatile organic compounds, and of course CO2. Moving to hydrocarbon spills. So when oil is released into a marine environment due maybe to an accidental blowout or other accident, this undergoes a number of physicochemical changes, and this will assist in the degradation of the spill, while others may cause it to persist. So water-soluble components in general of the oil will dissolve in the seawater, but however, the immiscible components will either emulsify or disperse as small droplets. So one of the areas that are mostly affected after an oil spill is the shoreline, the beaches, leaving the sand and the rocks and the plants coated with the oily residue, and consequently wildlife may eat the contaminated vegetation and will die. So here it is important to mention that it may take months or years to attract tourists back to an area that has been affected by any spill. Another important risk is the produced water. So what is produced water? It refers to water found in reservoir along with the extracted oil and gas, and this is extracted and it is a combination, if you want, of formation water, condensed water, brine, oil, natural hydrocarbons, inorganic salts, and other chemicals. So the discharge of this produced water has the highest portion of waste arising from the offshore operations. And this, of course, will influence the environment through the cuttings and the remain particles of the drilling fluid used to lift the cuttings from the well while the drilling operations. Here, if you allow me to share with you one of real examples of environmental risks in Lebanon is the GE power station oil spill. It is an environmental disaster caused by the release of heavy fuel oil into the Mediterranean Sea after storage tanks at the thermal power station in GE were bombed by the Israeli Air Force on July 14 and July 14, 2006. The plant's damaged tanks leaked up to 30,000 tons of oil into the Mediterranean Sea. A 10-kilometer wide oil slick covered around 170 kilometers of coastline and threatened Turkey and Cyprus. So this slick killed so many fish, sea turtles, and potentially increased the risk of cancer. Of course, a waste management project that was implemented in order to safely collect and transport the polluting material from the shoreline to temporary storage sites. Also, another and a very recent example of environmental risk happened also in Lebanon, unfortunately, and again from the Israeli side, where an oil spill originated from a ship passing near the Israeli coast and reached the southern shores of Lebanon. And here I share with you some photos of the tar and the sticky black deposition on the Lebanese beach in Tyre, and again will take months and maybe years to clean up. So for these reasons and others also not mentioned in this presentation, several management systems concerning the environmental practices for offshore petroleum activities should be adopted and currently are adopted worldwide.
Dr. Rami, the remaining 2 minutes.
Okay, so I will talk very fast. So it is important to mention that there are different environmental regulatory authority around the world, environmental legislation, and environmental risk assessment. Some of these examples, the Bureau of Study of Environment in the US, the ADNOC in Abu Dhabi, others, for example, as in Norway, the Petroleum Act, and etc. So what is important is the study case of the Lebanese. So based on what has been detailed previously, the environmental governance system for Lebanon is, we can divide it as the following. We have the Ministry of Energy, which is the main body responsible for environment protection and management in Lebanon. So its role generally is explicitly defined in the Offshore Petroleum Resource Law, number 132, and the Petroleum Activities Regulations Decree number 10,289. So in several provisions, but also one of role of the Ministry of Energy is to supervise and conduct the petroleum activities and ensures maybe its overall compliance with standards and regulation. Also, the role of this ministry is explicitly defined in these decrees, but there are gray areas, if you want, that need to be better defined. And these include responsibilities maybe and mechanism for environmental monitoring, auditing, inspection, and this could be achieved by signing a memorandum of understanding between the ministry and the Lebanese Petroleum Administration. In turn,
Mr. Rami, I'd like to thank for the very informative presentations and highlighting the relationship between the process safety management system and environmental management system. The next speaker will be Mrs. Rawan Maaita, Quality Manager, Marine Science Station, University of Jordan. The title of the paper will be Impact of Applying Total Quality Management System to QM to Occupational Health and Safety in Lab. Mrs. Rawan, the floor is yours.
مرحبا. Can you?
Welcome.
Okay. Come on.
Can you share your screen, please?
Yeah. Okay. Okay.
Still uploading. Yeah. Okay. Can you maximize your screen, please?
Okay. Done or what?
Start the slideshow. Okay. Okay, you can start, Mrs. Rawan.
Okay. Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullah. Good evening, all. Nice to meet you. In the beginning, I would say it's my pleasure to participate in this great conference, First Jordanian International Chemical Process Safety Virtual Conference among the world's biggest experts in chemical process safety. I am Engineer Rawan Maaita. I would like to present my master's thesis, which was under the supervision of Dr. Salah Al-Jbour from Mu'ta University, under the title Impact of Total Quality Management in Occupational Safety and Health in Laboratories. Okay, in the we can start introduction about the world is attaining a high-speed industrial revolution, which is associated with high requirements for customer specification, severe competitiveness, daunting competition, and environmental burdens. On the other hand, of political and economic transformation worldwide and the emergence of epidemics and disaster affecting several parts of the globe, several industrial sector must enhance their capabilities with respect to rising the level of efficiency, productivity, and more profit. So the total quality management and being certified with well-recognized quality certificate would qualify companies of different sector and a different size to overcome the above mentioned constraints. So in industrial laboratories strive and leading to apply good laboratory practices and follow high standard approved nationally and internationally in the framework of providing physical, chemical, biological analysis services and consulting services. So I want to talk about the integration between a quality management system and occupational safety and health system can ultimately reduce the rate of injuries and fatalities, reduce the cost associated with such accidents, reduce workers' insurance compensations, and meet customers' needs. That is leading to productivity and more profit and more qualified. Okay, my research problem, there are few studies concerning total quality management applications and impacts on Jordanian organizations and enterprises. International laboratories in Jordan are making every effort to ensure approval and accreditation of services provided to customers, like certified with ISO 9001 and ISO 14000. In addition, to reduce errors and to reduce cost to enterprise and increase profit productivity, we face many injuries and risks that may occur to the workers of the organization can be avoided, which will positively affect the workers and thus ensure the continuity of work, minimize the work loss time. But in the Jordan, very few companies are certified with ISO 45001. Among these companies are Al-Hikma for Pharmacies, Sumara Electric Power Corporation, MS Pharma, Fifth Generation for Engineering Services Corporation, and Coca-Cola Jordan Corporation. So in this study attempts to examine the relationship between total quality management and occupational safety and health in laboratories, and how total quality management system and occupational safety and health can be applied to improve the work environment and reduce the rate of accident and losses. In another idea to comparison between accredited and unaccredited laboratories on the impact of total quality management on occupational safety and health. My study objective to explore the impact of adopting quality management system in laboratories, to investigate the factor of total quality management that will effectively contribute to the reduction of work accidents, to evaluate the status of occupational safety and health in laboratories, to find the difference between accredited and unaccredited laboratories with respect to the impact of total quality management, of total quality variables on occupational safety and health. And the last, to provide appropriate recommendation to raise the awareness at laboratories toward total quality management practices for better occupational safety and health. My study model, you can see my independent variable, the total quality management. We know total quality management have many variables. I chose the 5 soft variables: recognition, training, teamwork, leadership, ethics. I studied for these variables, the effect of these variables on the dependent variable, which is status of occupational safety and health, in accredited and unaccredited laboratories in the south of the Jordan at Aqaba city. What is differentiate this study from previous study? That is, you can see from this map, my study considers addressing the effect of total quality management by studying new dimensions. These new dimensions acted as the independent variable. Specifically, his study considers 5 dimensions of total quality management: recognition, training, teamwork, leadership, and ethics. And this study considers the effect of total quality management by studying its dimension on the status of occupational safety and health. Other studies consider studying one aspect, such as safety performance, safety regulation, accidents, and the fatalities rate. However, study considers studying the overall status and reality of occupational safety and health. This study considers addressing the topic from the perspective of people working in industrial laboratories. Other studies consider addressing the topic from construction, IT, educational, medical, manufacturing sectors, and another sectors. And this study was conducted in Aqaba, which is a comprehensive and industrial city as a community to study. Maybe this the only one that investigated in this area the limits of the researcher's knowledge. And this study used a field study in industrial laboratories in Aqaba, where information, data, and will be obtained from its sources, and a questionnaire will be designed according to the problem. So the design and methodology, I choose 2 types of laboratories. The first type of laboratories applying quality management and has accreditation certificates. The second type doesn't apply quality management and hasn't accreditation certificates. And as mentioned, the variables recognition, training, teamwork, leadership, and ethics, and data collected and analyzed using descriptive statistical analysis and multiple regression analysis and analysis of variance for all the dimensions of the study. The questionnaire was presented to a group of reviewers who have scientific and a particular experience from Jordanian universities, professors with experience and specialization in this subject of the study. The questionnaire paragraph consists of 36 statements. The number of paragraphs assigned to each variable are 6. 5 independent variables are believed to have an impact on occupational safety and health. Filled out questionnaire will be collected and analyzed by SPSS software, and Microsoft Excel will be utilized to carry out. The result of my study, which is from these tables that shown indicate clearly the importance of all variables proposed in this study to affecting the dependent variable, which is occupational safety and health. This variables is approved and reflected by the perspective from accredited and unaccredited. And that is indicate a high degree of agreement of means equal 4.23 and 4.26 for accredited and unaccredited, and indicates very small degree of a standard deviation for 0.421 and 0.379 for accredited and unaccredited. The result indicates a training ranks first among the variables believed that affecting on occupational safety and health. The importance of a training and its rank being first is approved and reflected in accredited and unaccredited. In addition, we can see the result indicates teamwork believed to affecting occupational safety and health. The less importance of teamwork and its rank being last is approved and reflected by respective respondents for accredited and unaccredited laboratories. And the importance or the order of importance of variables affecting occupational safety and health, we can see by examining the B and beta value, the B value reflects magnitude of change in the dependent variables as a result of the change in the independent variable. The beta value could be viewed as a correlation coefficient. This coefficient range from 0 to 1, yes, having a value closer to 1 implies a strong effect to the independent variable on the dependent variable. Such coefficients can be utilized to identify the order of variables. My study conclusion: this study revealed that the 5 total quality management variables have an overall impact on the status of occupational safety and health in accredited and unaccredited laboratories. This study revealed that there is no significant relationship between recognition in accredited and unaccredited laboratories, but there is a significant relationship between training, teamwork, leadership in accredited laboratories, but couldn't be revealed in unaccredited laboratories. But is a significant relationship between ethics working in unaccredited laboratories and couldn't be revealed respond working in accredited laboratories. We can see leadership and training that is the most important variables that affect on occupational safety and health in accredited laboratories, but in unaccredited, the ethics is the only important variables. So we can say the implementation of total quality management tool within laboratories will affect the status of occupational safety and health in these laboratories. Recommendation: my recommendation is the government shall encourage industrial laboratories to obtain well-recognized quality certification as a means to ensure occupational safety and health. The government shall prioritize assigning its tenders to quality certified laboratories and raising the awareness of the administrative leadership at laboratories with respect to the importance of total quality management on the status of occupational safety and health, while insisting on accredited laboratories to conduct continuous and obligate worker training in issues related to quality management and occupational safety and health. And my suggestion for future research is studying the impact of other dimensions like employee encouragement, top management competence, continuous improvement, innovation, and many variables, and extending the study population to include laboratories from other cities in Jordan. And I hope to continue my PhD study in occupational safety and health for its importance and of its implication in the region. I wish a word the freak accidents and disaster and epidemics. And thank you for listening, and welcome for any questions.
I'd like to thank Mrs. Rawan for very excellent work. We know that the chemical lab have a lot of accidents, and that's why the Center of Chemical Process Safety was issued in this year publications for the process safety management system in lab and biology plant, and also he issued some matrix for the compatibility between the component during the mixing in the lab scale. I want to thank Mrs. Rawan for excellent work, and we hope to complete your PhD in occupational health and safety. The next speaker will be Mr. Venkachari Narasimhan, partner and chief industrial safety consultant in his associate India. The title for this paper will be Sustainability of Safety Culture in Process Safety Management. Mr.
Hello.
Hello. Good afternoon.
Good afternoon. Dani Daha, I am a friend of you. I just had your things that I'm going to start with all your blessings.
I am happy for your friendship in LinkedIn, and you can start your screening, please. Share screen.
Yes, yeah. I just I'm having about 45 years experience in fertilizer and ammonia in safety. Safety I do have for the last 15 to 20 years. So shall I start now?
Yeah, yes, of course. Yeah.
So I am a chemical engineer by profession.
Can you share your screen, Mr. Vinka? Mr. Vinka?
Venkatachari Narasimhan.
No, it's not clear in our screen.
My name is Venkatachari Narasimhan.
Oh, okay. I get it. I get it. Can you share your screen, please? Still not shared.
Narasimhan.
Okay. Can you share your screen, please? At the bottom of the...
I'm able to hear. So shall I start now?
Yes, but please share your screen. At the bottom, there is a green icon, share screen, so that you can share your presentation.
Okay. Shall I know? Are you able to do it?
No. احنا نسوي له اياها أنا.
We have a copy for presentation. We can share. I know.
Okay, I will share.
Okay. Now I have given. I sent the PowerPoint presentation.
Yes.
Already.
We will share it. Just a minute.
Oh, okay.
Just a minute, please. أنا مشيرها.
PowerPoint presentation has been already sent.
Okay. We will share from our
This
side.
is the one, yeah?
Yes, it's true. Can you maximize, Mr.
Narasimhan?
Narasimhan. Okay.
Yes, Narasimhan.
Yeah,
Narasimha, that is a god of Hindu culture. I just wanted to talk to you. Now, I am chemical engineer by profession. I have been in the line for the last 45 years. So to say that I have joined ammonia stream in the year 1971. And I've worked in different capacities, fertilizer, ammonia, and ammonia terminal. Then I got retired. And I was internal auditor for the company in process safety management for say about 10 to 15 years. I was doing all sort of things.
So Banco.
Then I got retirement 2008. Then I was working for RAM Safety Consultants. So I did safety risk management, general safety audit, and fire safety audit, and to my credit, about 70 to 80 papers. And then I went to United States in the year 2016. I went there. I saw a lot of industries like DuPont and Dow Chemicals and so on and so forth. So I wanted to start my own consultancy in the year 2016. So I came over to Chennai, and we started a safety consulting named as NS Associates. And now we are doing well. We have done a lot of lectures on risk, safety, and hazard, and then environment. So to say, we have presented three to four papers in to DuPont Institute of Chemical Engineers, and then Jordan Chemical Engineers. And we have done a lot of things, though I'm going to talk about what is measurements. Before that, I wanted to tell you what is safety, risk, and is a small 5 minutes. What is safety? Safety is a relative freedom, free from disease, fire, or floods, or by any other means, an accident. Suppose you go on a pathway, and suppose you don't see the small stone, you trip and fall. It is called personal safety. Is it not? Then I'm coming to what is risk. Risk is a specific effect with specific period of time due to complex of probability and consequence of vulnerability. Suppose you are going by any highway. I don't want to mention about in India or United States or Middle East. You are going in a highway in India. Suppose you are going by a car. Suppose a man crisscrosses the way. You have to avoid the accident. Then you have to go right or left. In the melee, you got injured. So this is risk. The safety and risk are brothers and sisters. So you cannot, if you enforce safety, you can be very, very, very well. So risk can be avoided. Then I come to hazard. It is a hazard which can be of anything or change. This is a physical hazard or anything we can say. Then comes to lost. I come to environment. Environment is free from pollution or air. Then comes to what is OSHA. This chapter comes under OSHA 31, 32, 31, 33. I have not gone into the subject. I am giving you what is OSHA. In 1912, the industrial first revolution took place there. Then the people don't know what is safety, and so many people died. And altogether, then the First World War came in 1914 to 1919. Then people not aware of what is going on. Then came the Second Industrial Revolution in 1925. A lot of accidents did happen, and so many things. People were not aware what is safety. People crying for help. Then the main Second World War came into being, and 1939 to 1945. So not reported, no accident were reported. People were dying in retrospective. Then came then people wanted to have some kind of agreement, or we can't say one rickshaw. It is called callous. That is agreement between workers and the management or so on. It's some pakka arrangement for the welfare of the being. Then came the OSHA. OSHA, after the Bhopal, 1982, December 4th, because people mayhem because of the union carbide. They didn't care for anything. They don't care for anything. Then resulting people died. 2,000 people died. 20,000 people. Still people are suffering. Indian government has filed a writ petition in the court of The Hague for compensation. But union done in the melee, in the way in which they have handled the situation, that is very bad. Then I am coming to what is safety culture. So the creating safety culture among industries. Our basic concept is to create safety awareness in the industry, keeping this mission as our vision, and started our consulting in the year 2000. We have been doing continuously performing lectures on process safety management, a system under OSHA 3132, 3133, and hazard identification risk and risk. Our priority is to conduct safety audit for industry. During the last 4 years, done many lectures on the above subject. Particularly, we are chemical engineers and safety engineers with 40 years experience. The lecture performance increased considerably. During 2019, we have done 5 lectures. During 2020, we have done 10 lectures. So I am coming to what is measuring safety performance. Measurements can be made in number of ways, through output indicators and input indicators. Measuring performance allows the review of an industry, of organization, safety with performance over time. This may identify trends or clusters of incidents that can be tackled to prevent workplace death, injury, and disease. What is safety performance? Safety performance should be in one place. People have to go and take training given by the management. Safety performance information can also feedback on the effectiveness of control and system of work, allowing continual improvements can be made. Identifying trends in safety performance. Industry is required to large variety of information or in the department regarding to incidents and workforce numbers. The industry data and results of selected investigation are frequently released as annual safety performance. And then and there, you have to choose the safety things, how they have done for the past 1 year. Then you have to give the performance reports. Then they have to do annual safety performance occasion. Quarterly performance snapshots. For every person individual, they have to take the individual performance that should be taken as snapshots and given to the management. Monthly safety and health snapshots. Monthly and safety. For every person, monthly safety healthy snapshot should be done. Summary for industry awareness. Summary of safety of industrial safety awareness should be done by the management. Fatality summaries. Fatality summaries should be given by the management to the Department of Safety and Health of the government. Significant incident reports and safety bulletin. Significant incident report, how it has happened, how the incident happened, and how they are able to analyze things, and the audits be sent to the Department of Safety for safety bulletins. Additional report surveys. Additional report surveys always should be given by the management to the employees. The safety department of the industry produces these chief users of industry, trends in safety performance, making the necessary changes. When combined with operational statistics, these tools can be assessed in improving that safety performance and moving towards their safety culture. Yeah, what is leading safety? What is safety indicator? A leading safety indicator is a measure of preceding indicating a future event used to drive and measure activities carried out to prevent and control injury. The example, what a given safety training. Everybody should be given under OSHA and 14 elements. You should give 14. The training should be given then and there. Ergonomic opportunities rectified and corrected. What is ergonomy? Ergonomy is a human development to safety and opportunities rectified and corrected. Reduction of MSD factor, reduction of masculate reduction of factors, reduction of masculate dispersion, that is called MSD factors. Employees perception survey. Employees should be given what are the things that have taken place. They should be given perception survey. Safety audits should be done every 3 years or 5 years. Why use leading indicators? The leading indicators are found on safety performance and improvement. These measures are proactive and report doing a regular basis to prevent injuries. Best practices of using leading indicators. Companies
Mr. Vin, the remaining time is 2 minutes.
2 minutes already. Leading indicators are found on safety performance and improvement. These measures are proactive and report doing on a regular basis and prevent injuries. Best user practice for using leading indicators. Companies dedicated to excellence are shifting their focus to leading indicators to drive continuous improvement. Lagging indicators measure failure, leading performance. Allow you to see according to workplace safety indicators. Allow you to see performance in performance. Measure the positive. Enable the frequent feedback to all stakeholders. Be credible to performance. Be productive. Increase constructive problem around safety. Making it clear what needs to be done to get it better. Lagging indicator measured to company's incident in the form of past incident static, injury frequency and severity. OSHA recorded injuries, most working days, workers' compensation law. Why you use lagging indicators? Lagging indicators of the traditional safety metrics and used to indicate progress forward compliance with safety rules. These are the bottom line that are over evaluate effectiveness of the facility. They tell you many people got hurt, how badly. The drawbacks of lagging indicators. The major draw only to use lagging indicators of safety performance is that the highlight of the incident and accident and its implication, not the importance of the positive taken to prevent accidents. The reactionary nature of lagging indicators make them a powerful gauge of prevention. Managers see a low injury rate, they become complacent in safety on the bottom to-do list, when in fact, these numerous risk factors present in the workplace that will contribute to future injuries. During our industrial visit, that is disaster management, it is in the OSHA 1411. We used to incite the client to conduct the reversal of the safety awareness on regular basis. We involve ourselves along with the safety department, approach the unit to conduct the rehearsal on a given day. Accordingly, the firefighting person will be informed to refill the equipment, which has to be done periodically on annual basis. The old stock may be utilized for awareness and the new stock will be refilled. We advise and convince them.
Mr. Vin, thank you very much for this interesting...
I have been given 30 minutes, is it not 20 minutes?
Okay. You have remaining 5 minutes.
I will just turn in 5 minutes, I will finish it, everything go. We used to insist the clients and rehearsal of the safety awareness on regular basis. We involve ourselves along with the safety department and to conduct the rehearsal on a given day. Accordingly, the firefighting person will be informed to refill the equipment, which has to be done periodically on annual basis. But challenge safety and business. The awareness of safety cannot reach the expected level both in the industry and the public throughout the world. In certain cases, the cost of the measures may be higher, which has to be absorbed by the management, for which they give secondary preference. If any accident take place, they are forced to spend heavily and the tension. It is advisable that the association and council should come forward for creating awareness by conducting workshops and seminars periodically. Achieving a higher level of health and safety in an industrial environment is a complete goal. Because of the myriad components of industrial safety, detailed organization is critical. Manufacturing and industrial facilities rely on EHS software to plan, execute, and maintain strategies. Everything from updates to safety regulation and safety performance within software causally, functionally to EHS department. In addition, you can track workplace of observation, incidents, and other hazards, and monitor over time. This is a huge, cheaper human development issue because usually manifested over time. Investing a deeper intent will take care to element deeper intent in the beginning of workplace. So case studies. I worked as and retired as a senior executive from Coromandel International Limited Company. I received a phone call from during the midnight 2000, that is 2010 something. It is wrongly reported that there are facing a technical problem in the ammonia tank and requested me to visit the site in prison and study the problem and suggest solution. There were two safety valves in the atmospheric tank where liquid ammonia was being kept in stored liquid form -33 centigrade was started leaking. There were two valves, none of them prepared, none of the operating personnel to go near the tank. So the effective steps to arrest the leak. So I went with courage to arrest the leak and isolate them. The pressure connection from the pressure gauge to attached to nylon flow disconnected to the safety valve with great care. Nylon flow line was disconnected and the leak was averted and the valves were closed manually. The next day, Uday did the constructed the plant and rectified the problem. Who constructed the plant rectified the problem. I received again second case of study. I received a phone call from J.M. Bakshi, Vice President at Chennai on 2010. They have some problem in handling ammonia unloading operation. Request to visit the plant, study the problem, and suggest solution. Of course, I got my retirement as early 2007. The call received after a period of after my retirement. Since I was the process manager in ammonia terminal and studied the plant well, ammonia ship will be anchored in the mooring buoy system in the Big Sea. The pipe will go from
Mr. Vin, a lot of thanks for this interesting presentation. Now my colleague, Mr. Amro, will be start the open discussions and will be asked for the answer or manage the discussions about the questions. Please, Mr. Amro.
Yeah, thank you, Mr. Yaqub. Our first question to Dr. Faisal. Faisal Khan, what does T stand for in the fertility graph? Oh, he left the session. Okay. The next one is for Mr. Lee Alford. What are the requirements for remote auditing? He also left. Okay. Fourth question is to Arturo and Mauro. At companies where process safety management system is not established so far, what are the initial steps required to properly build such system? What is the order of PSM elements implementation?
Mauro, do you want to answer this one or shall I?
Oh, it's the same from. So I think that the first step should be something related with the organization. What will really need to be established is a strong focus of top management on the target they want to achieve and to develop a proper organization. So it's strictly related with the resources, how you train them and how you manage them. And then a cultural program to spread the process safety culture within the organization. Of course, if you start from zero, it's really a long path. Anyway, if you have any other management system, you can easily rely on them as a support for preparing a procedure, issuing them, having them applied, keep documentation under control. So if you take into account all the different safety management system, occupational safety and health ISO 45,000 or 14,000 or 9,000, they could be a basis on which you can build the additional elements that are needed for process safety management system. Arturo?
Yeah, only to complement, it is very seldom that we find a company that has nothing regarding process safety. You may not have an organized process safety management system, but at least you have some process safety practices, that you have procedures to do things, you manage perhaps some changes. Then one of the outcomes of an OPS assessment would be, okay, that is your strong point, your weak points, or your long list of weak points are those ones, and these are the actions that you need to implement. So such an implementation in an organization that is very immature in our words will mean that you will have a lot of suggested interventions, so you will have a long roadmap. But yes, the first point would be to assess where you are in terms of what practices you have, maybe spotty practices here and there, but usually you have something. If you have nothing at all, then Mauro's point is extremely valid. I mean, you have to start building some organization, and you can piggyback on any other systems that you may have.
Okay, thank you. Next question, also for Arturo and Mauro, received. Do the OPS comply or incorporate the typical due diligence requirements?
We are proposing to use OPS for due diligence, and this is because we have participated in a few of them, and due diligence are incomplete because you go and you typically verify compliance with regulations, which is one of the elements of the process safety management system. But there are other elements, and we have found very often that a company acquires another company, for instance, or merges with another company. They have done a perfectly standard due diligence process, and then when the process safety experts of company A go to company B, they say, oh my God, we have to do things here because the maturity level they have is not comparable with ours. So we have to spend an amount of money and resources and effort that was not budgeted when they planned the acquisition. So yes, it is included because one of the things that we verify is compliance with standards and regulations, but it is only a small part. And we strongly believe that OPS is also a good tool to avoid surprises.
Thanks a lot, Arturo. Next question is to Mr. James McVeigh. How would this process be used to complement the FMEA assessment? Are these methodologies consistent, and if not, how different are they?
Well, I mean, you know, all degradation mechanisms are considered in these types of reviews. Let me get the video going. Yeah, I mean, these types of reviews are foundational for things like FE or FMEA evaluations, and yeah, in the studies, we're not just considering, for instance, there's another question related to corrosion. It's really anything that causes deterioration or failure of equipment is considered, and so if nothing else, as a foundation for the rest of the things that occur within the FE or FMEA evaluation, you know, these types of studies are. These are sort of failure analyses plus sort of contributing equipment exposures that cause those failure analyses that sort of evolve into something called a root cause analysis too, which then sort of supports FMEA type of evaluations. So it's a piece of it, and a very critical piece and a very helpful piece for those types of studies, I think.
Okay, thank you all. We will go directly to the third and last session of the conference. I will be the chair of this session. Our first speaker is Anas Al-Zaid from the NFPA Kingdom of Saudi Arabia, Director of the NFPA Middle East and North Africa. The title of his presentation is NFPA Contribution to Chemical Process Safety. Please, Mr. Anas, can you start now?
Bismillah wa salatu salam wa rasulullah. Good afternoon, everybody. I'm very honored to join you today in this important conference. This is the first time NFPA participate in Jordan, actually. NFPA is new in the office in the Middle East and North Africa, and I think it's a good gesture to have you with it. The time allocated is very slow; it's very low, so that's why.
Sorry for the interruption. Can you share your presentation, please?
Yes, I am. Okay, so the time is 15 minutes, I believe. So I base my presentation on 2 or 3 ideas only. And the idea is, what's the relationship between tragedies and accidents toward the standards and codes? So I use standards and codes are written from human tragedies. And if you look back to our history, 125 years, National Fire Protection Association, you will see each and every incident happen worldwide did affect our codes and standards, and we changed them to prevent another accident to happen. So please, whenever we're using codes and standards, we need to make sure that the minimum line of standards and the minimum line of safety is available. If we go back 125 years back, that's the first 2 tragedies which initiated NFPA in 1871 and 1872. That's 125 years ago. There was a fire, a famous fire in Chicago Grand Fire and Boston Grand Fire. And the people start reacting and putting sprinkler systems and water spray system in their buildings just to make sure they don't have another fire. After 20 years, in 1895 and 96, the people from firefighters, insurers, engineers, manufacturers, building officials all gathered in a very famous meeting and they decided to formulate the NFPA, National Fire Protection Association. So basically 125 years we were doing codes and standards worldwide, and it's now adopted in the Middle East and GCC countries and a lot of countries, and in most of the industries, commercial, residential, heavy industries, oil and gas, all is being used by the NFPA. So what's triggered now NFPA to be global, more global? We had 4 incidents worldwide: the Bangladesh Dagga fire, the Greenfield fire, the Brazilian museum, and the Notre Dame church fire. All that triggered NFPA to be more international. That's why even our logo and motto, let's protect together, it's a very big word. So that's why. In my presentation here, I would like to go over what's the famous incident in the chemical processing. This is our vision, of course. And basically, we are a non-profit organization, neutral, and we consensus all our codes and standards is a consensus between all the codes and the members and the technical committees, the impact and the implementation, all our codes and standards. We measure the impact before we release them, and we make sure it's implementable if we release any codes and standards. This is we have more than 300 standards, and this is some of the standards codes being used worldwide. NFPA 1, 10, 13, 20, 25. Most of the industries now use our codes, oil and gas, chemical, light industry, heavy, all of them use our codes and standard in a daily. So the main thing here is just to emphasize, these codes and standard is being developed from accident and incident happened in the last 25 years. 125 years, plus the second very important point that these codes and standards is the minimum line. That's the minimum requirement. So anybody choose to break these codes and standards means he is he's going to himself, exposing himself to unnecessary risk. That's basically what we are saying on this presentation. The codes and standards developed through a rigid process. It's not a normal process with multiple revisions on it. So that's why the codes and standards are through the years. And every 3 years, we review the standard and code to make sure it meets the technology, the new technology, and any changes in each industry. This is some of our certification. We have 16 certification in the NFPA, which is the flagship. What certification is? But what we are saying is we introduce codes and standard, we do the trainings, but also we certify people that we're saying these guys are certified. He knows the code and standard and he can interpret it. That's basically what certification means. So that's very important. And also to get certification is not an easy process. It's a long process and needs a lot of training and field experience to get the certification required in each industry. Also, we do certification for the firefighting services. We give all the standards and codes. The certification itself, the accreditation done by the Pro Board and the FSAC, two independent organizations for it. This is the membership in the worldwide, and you can see that MENA, although we make 5% of the world population, actually within the NFPA, we only represent 1%, which is underrepresentation of our in the Middle East. So that's why I'm asking everybody to join so that we can change the standards to meet our culture and the area in the Middle East. Also, we have our own research foundation. So all that now was the introduction. I have only 4 or 5 slides, which is very important now. Now, I just want to show you how chemical processing and the incident happened in the past affected NFPA codes and standards. Okay, so I will start with the clean energy plant that happened in 2010 in February 7th. And basically, these guys used natural gas to purge a system. And what happened is 6 fatalities, 6 people killed in that incident in 2010, because they used natural gas, pressurized natural gas, to purge some pipes to remove debris from the system. And there was an ignition on the system. There was ignition, so there was a big explosion and fire. So what's that triggered in the NFPA? It triggered NFPA 56, okay, Standard for Fire Explosion Prevention during cleaning. So see, what I'm trying to say here is, whenever we had incident in the past, it is affecting NFPA standard and codes. So basically, these codes and standard is the humanity knowledge accumulation. That's the main essence of this presentation. That whenever you see a code and standard, it's not some people, academic people sitting in an isolated office trying to have the best. No, it is accumulation of people, humanity tragedies, accidents, and we incorporated in these codes and standards to prevent from repeat this accident and incident. So that's one of the this incident in 2010 triggered the NFPA 56, and then we had the Imperial Sugar incident. Again, it's from sugar dust. That was in 2008. Again in February also. Usually in the United States, February they use it to do maintenance on the system on the plants, and they had 14 fatalities when the sugar dust, there was 2, and then ignited, and they had a major fire there and Imperial Sugar plant. And what's that triggered from NFPA? We issued NFPA 652, standard for the fundamentals of combustible dust. So you see, there is an incident happened in the past. Either we introduce a new NFPA standard code, or we change one of the codes and standard which is being used currently, NFPA 13. And if you sit down with one of our old NFPA instructors or SME, subject matter experts, he will tell you, whenever you even open a code, a standard or code, he will tell you this code, this paragraph was changed after this fire. For example, the station fire or the Imperial Sugar plant, or whatever incident, he will tell you exactly this changes happened on the codes and standard due to these tragedies. And again, we had the Excel Energy incident. It was a tunnel, and they were doing a painting inside it with a flammable epoxy paint, and that was in October 2010 also. And there was 5 fatalities on it. It's unfortunate to have these fatalities and injuries. I did not mention the injuries. Each incident had 10 to 15 injuries, plus some of them are a major incident on it. The Excel Energy plant, hydroelectricity plant, triggered NFPA to issue the NFPA 350 guide for safe confined space entry and work, because the tunnel was under, it was linking 2 reservoirs. They use it to generate power, and the people were trying to paint with epoxy, flammable epoxy on the tunnel, and they caused the explosion and this incident. The last incident I'd like to just mention how it affected NFPA codes and standard is the carbide industries that happened in March 2011 and triggered NFPA to issue NFPA 85. It was a furnace, and the furnace was overheated and has multiple issues with it through the years, but the carbide did not take that's an official report. That's not our not NFPA conclusion. It was the agency, the investigation agency report that there was indicators before it, and then they had this major explosion on the furnace itself, and there was 2 fatalities on it. So basically, again, if you go back to the codes and standards, each one of them is changed due to accident and incident happened in the past and triggered NFPA, either to change an existing code and standard or to issue a new code and standard such as NFPA 85 about the boilers and combustion systems hazards code. Just a final word before I leave you. NFPA in 2018 came with a question. The question is can the community be fire safe? Okay, that's a very important, especially the chemical plants does affect the community. And I don't want to mention India Bhopal incident. I'm sure it's been covered more than any other incident, but it did affect the whole community. So NFPA actually came with this, we call it ecosystem. It's an 8 cogs, 8 element module, which tells you if you want to have a safe community, a country, a city, or even a small community, you need to have from the government responsibility, development of codes and standards, the reference standard and codes, investment in the safety, a skilled workforce, and that's one of the Jordan Engineers Association part, and is to develop skilled workforce. And Jordan is doing very well on this side, actually. And then we have the code compliance. Somebody have to go and make sure that these industries do code compliance. Then we have the preparedness of the emergency services. Whatever you do, there's always a chance you will have emergencies. That's why you need to develop your own emergency teams, civil defense or fire departments in other countries. And finally, you need to have the informed public. All of these elements, they need to be developed. And that's what we are trying to, in the NFPA, to develop, to make sure all of these 8 elements is available in the community, so you will have safe community. That's all from me today. Thank you very much, Chairman, for the opportunity. And I hope just I covered a little bit. The 15 minutes is barely, I had too many ideas, but when I say it's only 15 minutes, I compressed it, actually. Thank you very much.
Thanks a lot, Mr. Anas. Maybe in the future we will hold a webinar more, and you can give more details about this. Thanks a lot. We will move to the next presentation from Rawan Farashhouri. The title, from Rawan Farashhouri. She is from she's a petroleum engineer from Beirut Arab University, Lebanon. The title of the presentation is The Influence of Temperature on CO2 and H2S Corrosion Rates of Steel Pipelines in Lebanese Oil and Gas Offshore Environment. Rawan, you can go ahead and share your slides.
Okay. Is it shared now?
Yes.
Okay.
Thank you.
So good evening. Today I'll be talking about the influence of temperature on CO2 and H2S corrosion rates of carbon steel pipelines in the Lebanese offshore environment. This study was done by the usage of the Alloy Select software. Okay. Now let's talk briefly about what I'm going to talk about today. First, I'm going to be defining corrosion in the scientific terms, and then I'll move to the corrosion in the oil and gas industry, and then I'll take a case study in order to show how corrosion is really dangerous in many fields, and then I'll move to some case studies and some accidents and incidents that took place throughout the history concerning corrosion. And then I'll move up to the oil and gas in Lebanon, and I'll move to the CO2 and H2S presence in the oil and gas industry, their sources. And then I'll talk about briefly about the history of the oil and gas exploration and production in Lebanon, the latest updates that took place, and then we'll talk about the experiment, the Alloy Select software that I used, its launching background and the main sections of it, And then I'll talk about the experiment that took place, its methods, the resources, who's gonna benefit from my study, and a detailed description of the experiment that took place. And then we'll move to the conclusions that are estimated after the analysis of all of these experiments. Now let's start with corrosion. Corrosion is the spontaneous type of attack of specific types of material, such as iron and steel, taking place due to different types of interactions between metals and the surrounding corrosive environment. How does this take place? First of all, several or one of the corrosion boosting factors are present, which makes the environment becoming more corrosive, which will lead to the reduction of the lifespan of the equipment and the compromising structure safety which takes place. This factor might include the temperature, organic and inorganic acids, pressure, moisture, and impurities such as H2S and CO2. What I'm concerned about in my study is the H2S, CO2, and the temperature. These factors are the main key factors in my study. Now let's move to the corrosion in the offshore oil and gas industry. First of all, we have to know that the oil and gas industry is divided into three main sections: the upstream, the midstream, and the downstream. The upstream is about discovering and producing oil and gas. The midstream is about transportation of the oil and gas via the pipelines and storaging of any excess. And the downstream is about the distribution of the refined oil and gas to the end users. Now, where does corrosion take place? Unfortunately, corrosion takes place in the upstream, midstream, and downstream. And that's what really makes it important for us to talk about corrosion in the oil and gas industry. This scenario is actually illustrated by petroleum companies that are losing up to several billions of dollars just because of corrosion each year. And many reports were reported around the world that had confirmed several losses that took place in the oil and gas industries just because of the corrosion, and mainly due to the rupturing of the pipelines due to corrosion. Let's take this case study in order to show how corrosion is really affecting directly and indirectly many companies. This case study took place in Mexico in 1992, where a sewer exploded, and it led to death of 200 people and losses up to 75 millions of dollars, and 600 buildings were damaged. So today I'm going to be talking about the influence of temperature on CO2 and H2S corrosion rates of carbon steel pipelines in Lebanese offshore environment. This study was done by the usage of the Alloy Select software. I would thank Dr. Rami Harouz for his guidance throughout my work and supervision. Now, starting with what I'm going to be discussing, I'm going to be talking about corrosion briefly and the corrosion in oil and gas industry, and then we'll move to the case study in order to show how dangerous corrosion is being on many parts, and then the annual cost of the corrosion. And then I'm going to talk about some incidents and accidents that took place throughout the history concerning corrosion. And then I'm going to be talking about the oil and gas in Lebanon, and then CO2 and H2S, their presence in the oil and gas industry, moving to the history of oil and gas exploration and production in Lebanon and the latest updates. And finally, I'll be talking about the Alloy Select software that I used. I'll introduce it, and then I'll talk about the main sections of it. And then I'll move to the research methods, resources, and beneficiaries. And finally, I'll talk about the experimental part, what I did, what are the input data, and what are the results that I came up with. First of all, concerning corrosion, it's a spontaneous type of attack on specific types of materials such as iron and steel, taking place due to different types of interactions between metals and surrounding corrosive environment. How does this take place? First of all, the presence of one of or several of the corrosion boosting factors are present, and then the environment becomes more corrosive, leading to the reduction of the lifespan of equipment and compromising structure safety taking place. These factors may include temperature, organic and inorganic acids, pressure, moisture, and impurities such as H2S and CO2. My main concern will be about the temperature and the H2S and CO2 impurities. Now let's move to the corrosion in the offshore oil and gas industry. First of all, we have to know that the oil and gas industry is divided into three main sectors: the upstream, midstream, and downstream. Concerning the upstream, it's about discovering and producing oil and natural gas. Concerning the midstream, it's about transporting the oil and gas via the pipes and storaging of any excess. Concerning the downstream, it's about marketing and distribution of the refined oil and gas to the end users. Now, where does corrosion take place? Unfortunately, it takes place in the upstream, midstream, and downstream. And that's what makes it really important for me to talk about corrosion and to research more and more about corrosion in the oil and gas industry, because different scenarios are illustrated by petroleum companies losing up to several billions of dollars each year just because of corrosion. And many reports around the world have confirmed several losses that took place just because of corrosion, and mainly due to the rupturing of the pipelines that are taking place due to corrosion in many steps throughout the procedures. Okay, now I'll start with this case study just to show how corrosion is dangerous, okay? Concerning this case study, it took place in Mexico, 1992, where over 200 people died, $75 million were lost, 600 buildings were damaged, and 1,500 people were injured. After investigations that took place in order to know why did this sewer exploded and led to all of these casualties, it was investigated that what really happened is that there was a gasoline pipeline under the sewer, and this gasoline pipeline, due to corrosion, it ruptured a little bit, and the gasoline started to leak into the sewer, and due to pressure build-up, this corrosion took place. Now, who had the responsibility? The oil company has the responsibility, and that's why I'm showing you that mainly, if it's not a direct cause due to corrosion, there are indirect causes also due to corrosion, which makes the companies, the oil companies, hold responsibility and compensate for the losses. Okay, now let's move to to some incidents and accidents that took place due to corrosion. As we can see that the OGP incident distribution between the period between 2009 and 2018, the second main cause of these incidents was corrosion, which came after the material welding equipment failure with a percentage of 17%. Concerning the OGP top most fatal accidents throughout history, it was noticed that the second most fatal accident throughout history was due to corrosion, and specifically pitting corrosion, where 650 fatalities took place in Mexico in November 1984. All of these incidents and accidents and the case study that I presented to you shows how really dangerous corrosion is. Now let's move to Lebanon, my beloved country. As we can see that, as you all know, that Lebanon is passing now in a crisis, an economical crisis, and the last thing that we might want is to lose more due to corrosion or any other cause. And what makes it really important for this topic to be discussed is the fact that Lebanon is on the verge of producing its very first well. And 1.7 billion barrels of recoverable oil might be found in the Lewis Basin province, and 122 trillion cubic feet of recoverable natural gas as well. Okay, now let's move to the sources of H2S in the oil and gas industry. Its sources are the well stimulation, drilling, plant operations, and the sewers. Concerning CO2, its sources is the oil and gas reservoirs, the usage of the CO2 in the enhanced oil and gas recovery and in the enhanced coal bed methane recovery, and the deep saline formations in the offshore and onshore. Let's talk briefly about the history of the oil and gas in Lebanon. In the period between 1947 and 1967, the first onshore exploration wells were drilled. In 1993, the first seismic survey offshore Lebanon was acquired. In August 2010, the first sector-related law enacted. In 2012, the first SEA for petroleum activities offshore Lebanon was completed. In December 2012, Lebanese Petroleum Administration was established. And in March 2013, the first pre-qualification round was completed. Moving to the more important steps, in January 2018, the first EPAS signed in blocks 4 and 9. And in 2019, the first baseline environmental survey was completed. Now let's move to the most recent updates. In February 2020, drilling campaign of the first exploration well in Block 4 was conducted to a total depth of 4,076 meters from sea level and water depth of almost 1,500 meters. However, on 27th April, Total E&P Liban unfortunately announced that the results of BBLOS reported that only traces of gas were present, but no reservoirs were present. Unfortunately, that's what happened. But further studies were to be made in order to know exactly where there is reservoir, where there are reservoirs that are present. But unfortunately, also the exploration took place in August 4th, and everything was paused. Until now, nothing new happened. We are aiming, inshallah, to resume all of the work. Now let's move to the aim of this study, is to study the effect of the temperature on H2S and CO2 on corrosions on carbon steel pipelines in Lebanese offshore environment. The temperature range is between 10 degrees Celsius and 200 degrees Celsius. We took the 200 degrees Celsius because it's the worst case scenario, in order to see what is the worst case scenario that can take place. Now, moving to the research method, I used the Alloy Select corrosion software, where first of all, I started to study some specification of the Lebanese seawater in the lab, such as the salinity, density, acidity, alkalinity, and hardness. And then I filled all the needed data in the input data and the software part. And the key factors in my study were the CO2 and H2S and the temperature. And then at the end, comparison of the results were done in order to get out with conclusions. Who's going to benefit from my study? Pipelines engineers, field operators, corrosion engineers, contractual parties, and designers will benefit from my study. Moving to the Alloy Select software, this software was launched by the Oil and Gas Corrosion Ltd, where its goal is to estimate the carbon steel corrosion rates upon different input data and process conditions. As we can see the input data, this software allows us to input the data of temperature, pressure, H2S, CO2, Cl, HCO3, design life, and the corrosion inhibitor availability. This software is divided into three main sections, but I'm interested in the evaluate and the select sections. Concerning the evaluate, it evaluates and estimates the corrosion rates that will be detected upon the input data that we placed. Concerning the select part, it's about the verification of the most suitable material under different temperature, CO2 and H2S conditions. Now let's move to the input data. As we can see that I placed the maximum hydrogen sulfide and CO2 percentages in order also to take the worst case scenario, and also the temperature. The maximum allowed temperature was 165 degrees Celsius. As we can see that the results of the material selection, the rejected ones, the material that were rejected are the stainless steel, the cold worked solid solution nickel-based alloys, the martensitic stainless steel, the precipitation hardened nickel-based alloys, the duplex stainless steel, the ferritic stainless steel. These were rejected because they can't handle the maximum H2S concentration and the maximum temperature and the maximum CO2 concentration. Regarding the accepted ones, as we can see that the highly alloyed authentic stainless steel were accepted, the copper and aluminum-based alloys were accepted, the cobalt-based alloy was accepted, and the titanium alloys were accepted, and the solid solution nickel-based alloys were accepted. But all of these were accepted with limitations except for the copper and aluminum-based alloys. They were the only grade that was accepted with no limitations at all. And that's why we can say that the copper and aluminum-based alloys are the best choice in our case study. Now, moving to the second part, which is the evaluation section. As we can see, I took three temperature ranges, the low, medium, and high. And then I correlated it with percentages of H2S and CO2 combinations. And then each case was designated with a letter A, B, C, D for the low temperature range. The A is for the high H2S and CO2. The B is for the low H2S and CO2. The C is for high H2S and low CO2. And the D is for the low H2S and low CO2. Same is for A prime, B prime, C prime, D prime. And same for the A double prime, B prime, double C prime, and double D prime. But the A prime section is for the medium, and the double prime section is for the high temperature range. Now, after I put this input data and after designating all of these conditions, I then came out with these results. As we can see that the maximum or the highest corrosion rate was noticed when we had high temperature, low H2S, and high CO2, where it is in the case of D double prime. As we can see, it's 3,237 millimeter per year. It's the highest corrosion rate obtained. And the lowest one is C C, where it's 0.13 millimeter per year, and it is for the low temperature with high H2S and low CO2. Now, the same experiment was then repeated, but I included a corrosion inhibitor. As we can see that the maximum corrosion inhibition took place as a percentage. Also, it's calculated. We can see that it is when we had high H2S percentage and low CO2 percentage. So as a conclusion, we can say that CO2 is the main reason behind the corrosion rate, okay, in compliance with high temperature. It means when we have high CO2 percentage, high CO2 percentage with high temperature with low H2S percentage, we are having the highest corrosion rate, and that's what made us conclude that the main reason behind the corrosion is CO2 and not H2S in our case. Moreover, that the main inhibitor's effect is targeting H2S more than CO2, because as we can see that when we have high H2S percentage, we are having higher inhibitor activity, and apparently CO2 is mitigating the function of the inhibitor. So we can say that more studies are needed in order to verify exactly what's happening. And that's it. Thank you. And nothing destroys iron but its own corrosion. Thank you. That's all.
Thank you, Rawan.
Thank you.
Valuable presentation. We will move to the next speaker, our colleague, Engineer Khalid Al-Nubani. He's a senior safety engineer at Jordan Petroleum Refinery. The title of his presentation is Entropy Inherent Safer Design. Mr. Khalid?
Is this sharing is good?
We can see you and we can hear you. Just if you can share your presentation.
It's not moving.
Okay, we will share it from I will share them if that's okay with you. Okay, just a second. Okay, we can hear the alarms in Jordan indicating the start of the lockdown. Just a second here, we have your presentation.
Okay, good afternoon for all of you, and good morning for some of you. Actually, we are talking in the first Jordanian International Chemical Process Safety Virtual Conference. I welcome the GEA for its cooperation with us. I will talk about entropy inherent safer design. Actually, entropy inherent safer design is not a new project. It is a new idea. We sell ideas sometimes, and this new idea is for exploration. It is not a final research. Thermodynamics deals with more than 2 laws. But we are sure about the first law, or we think we are sure about the first law, but we are not sure about the second law because it is a probability issue. It is most probably that the second law always hold right. Entropy actually, we can describe it as disorder, but it is not disorder because it is not an equidistant process or random process. Always it is its entropy, it's described as disorder. Actually, how it is measured, it is energy versus temperature. We decrease the energy of the material below to 10 Kelvin, and wait after we add energy slowly to reach our temperature. Then all the energy added, we calculate it and investigate it, and the collection of energy is the entropy until the desired temperature, from 0 to our temperature. It is used in the second law of thermodynamics. Actually, entropy is a property. Because of that, it is not disorder. We always reach the same property from a given state. How related to temperature change? It is irreversible process. Temperature change is an irreversible process. The entropy difference, change, transfer, and production is different issues. Actually, every one of them is a different issue. I again ascertain that this is not a new issue. I want everyone to explore entropy and the second law to give us insights about the second law and new ideas about it, because mechanical engineering uses it for the utmost benefits of it, while chemical engineers are seldom encounter it other than legendary transforms. Mechanical energy conservation is actually holds for most of us. Mechanical energy conservations holds for the most processes, but when mechanical energy turns into heat, it will be lost because of the delta S problems. Friction converts mechanical work into heat. Friction in the mechanical work turns into heat, and heat turns into entropy, and it is lost. For our for our benefit, we must take all the work that heat attains for us, but the nature doesn't give us all the work we can get from heat. Some heat goes into entropy. We are, when designing or operating a chemical process or chemical technology process, we introduce energy and material when operating it. Heat is most likely the kind of energy we introduce, like in kitchens, when we cook materials in kitchens, we introduce heat to be for the food to be developed. The shell of the food material change with entropy proceeding with it. Natural processes, delta S greater than or equal 0, equal for the equilibrium case, and greater than 0 is for the natural cases, while less than 0 is for the unnatural cases. Rate versus equilibrium. Thermodynamics give equilibrium information, while heat transfer gives rate information. Actually, chemical engineer don't look to entropy, because at the end he will go to the laboratory to get the rate data. So he don't go to computers to calculate entropy, because entropy don't give rate information. Because of that, I emphasize that chemical engineers should find a way to calculate entropy for their knowledge before they incept the project, before the inception of the project. In the design state, they should give us information about the system we encountered in the technology. As entropy is a property, it is a property of equilibrium state. And it is the most probable state, which is the equilibrium state. When we calculate entropy, we calculate it for the equilibrium state. Rarely we encounter equilibrium states in the industry and technology, because entropy is a property that holds for thermodynamics. We don't hold equilibrium in dynamic systems. We always change with time. Within the scope of equilibrium, we change with time. It is a dynamic state, not a static state. Although it is fixed with time, but it is a dynamic state at the end with respect to equilibrium view. Actually, quantum state, it is a number. Quantum state, it is a number about the outcome of the entropy measurement. There is a probability state, which is equilibrium state, and other probability states that give us other outcomes of entropy. Manipulation of process variables through entropy parameters. Process variables in inputs and the outputs, we want the output. Like the potash crystallization problem, we always withdraw the crystals from the solution. This act drives the reaction rate forward, always push it forward. So the reaction, if we can call crystallization a reaction, it always go forward. If we can calculate entropy, we can explore all operation envelope within this crystallizer. I insist that crystallization or chemical processes operational envelope could be developed in calculations, not in pilot plants or laboratory. I want to say that we must explore our technologies, our projects, before we begin with laboratory and pilot plants.
Thank you, Mr. Khalid. Let me just stop the share. Stop sharing. Okay. Our next presentation will be with Mr. Alan Borman. He's the director of PDQ Scotland Ltd in the UK. The presentation title is Case Study of an Explosion at a Polymer Manufacturing Plant. Mr. Alan?
Hello. Hope you can hear me okay. I'm going to share my screen.
Yeah, clear and your screen. Yeah.
Can I use presenter view?
Yeah, sure.
Can you see that okay?
We can see, if you can go to the advanced share, then you can select the square to share only the slides instead of the presenter view.
I'm sorry, can you repeat that? I didn't quite understand.
From the share screen, you can go to advanced share.
Okay, I don't see that.
And the Zoom application.
Yeah, okay. Sorry, I don't have that on my screen. It says you are screen sharing or stop share. Yeah.
Okay, you may start, no problem.
Is it okay? Yeah. Okay. Well, good evening to everybody from the UK. My name is Alan Borroman. I'm a chemical engineer and I've specialised in process safety for the last 30 years, but I'm never too old to learn. My paper discusses the events leading up to an explosion at a polymer manufacturing plant, and it also discusses the lessons learned about failures in process safety management. In summary, a serious incident occurred and it revealed various failures in process safety management. It concerns the change in use of a valve, and that change of use had not been fully considered. There were aspects of poor design and inadequate procedures which had not been properly addressed. So I'm just setting my stopwatch so that I finish on time. And the various weaknesses had been present during 10 years of operation, and no serious incident had happened before. However, a single human error exposed these weaknesses and it resulted in a catastrophic incident causing 1 death and injury to 4 people. My paper discusses the lessons to be learned in terms of the design of the vent system, how to manage change, how to implement hazard actions promptly. It discusses the inadequate operating procedure at the time, and it also covers human factors such as poor ergonomic design and alarm management. It's necessary for me to describe the process in some detail. This is a simplified schematic of the process, and there are 3 main areas of interest. There's what's called area 200, which is where the reactors are. The reactors are producing polymer at 40 bar. There is a product recovery area where the solid material is separated out and recovered. And then the main area of interest is what's called the blowdown, or area 600. And blowdown is a term which refers to the routing of vented vapors from the reaction area to the flare stack. So it's to do with the safe disposal of vented vapors. In the blowdown, there were 2 main vessels, 2 blowdown vessels, a high pressure vessel called D601 and a low pressure vessel called D602. There was also a cyclone separator in the common vent system from those 2 vessels, and the outlet or the vent from the cyclone led to the flare or the flare stack. So the blowdown system was a means of routing vented vapors from the reactor to the flare. However, there was powder in, or there could have been powder in those lines. So the purpose of the blowdown was to separate powder before the vapors were sent to the flare. And then, of course, periodically the vessels would have to be emptied of powder. The main vessel that I'm interested in is D601, which is where most of the powder in the blowdown system was removed. There was a way of temporarily diverting the process stream from a filter called F301 in the product recovery to D01 through a diverter valve. In fact, there are 2 diverter valves on the feed to D602. The route from F301 would be used if the level of powder got too high in F301. And that was quite relevant in this incident, as we'll see. Just some details about D602. It was a pressure vessel with a design pressure of 3.5 bar G. Now it had an open vent shown. I don't know if you can see my cursor, but I'm trying to show the vent from D602 going to a common header through a cyclone and to the flare. And in that vent line, there was a valve. It's called V1, and it's shown marked in black here. And that valve was normally locked open. That valve was located about 15 meters above ground level, and it was accessed by a ladder. However, in the original design, that valve was intended to be open at all times, and therefore there was no operational requirement to close that valve. So it was purely a maintenance isolation valve. Now, the reason for having a valve in that line at all was that the company had other parts of the site connected to the same flare. And if the blowdown vessel had to be maintained, it was desirable to isolate it from the flare system to allow the other parts of the site to continue using the flare. So it would have been used very infrequently and for maintenance purposes only. That was the original design intention. There was a procedure for controlling the opening and closing and locking of that valve. It's called a car seal lock procedure. I'll explain a little bit more about that in a minute. You'll notice that the cyclone is in the vent path from the blowdown vessels to the flare. And in my opinion, that was a potential blockage. Another point is that when the design was carried out, there was a design HAZOP, which did not raise any concerns about high pressure or overpressure in the blowdown system. Now, I come to talk about the discharge of powder from D602. At the bottom of D602 was an inlet of steam and nitrogen. And there were two reasons for that. Steam and nitrogen together were used to deactivate catalyst in the powder before the powder was discharged. And then nitrogen alone was injected to purge out any hydrocarbon vapors before the powder was discharged. I think that really covers most of the important parts of the process. So I'll move on to the next slide. This is a picture of the plant as it was built, and on the left you can see the two blowdown vessels, D601 being the high pressure vessel and D602 being the low pressure vessel. The valve V1 in the vent line from D602 is not shown here, but it's at the top of that vessel. As you can see, it's a long way up to operate that valve. So the valve was accessed by a vertical ladder. And this is the picture of the same plant after the incident. D601 is still there. D602 is gone. And you can see that from the position of these adjacent columns, you can see both the force of the blast and the sort of general direction of the blast wave. Okay, so I said that in the original design, the vent valve was used purely for maintenance. However, there was a change in the procedure sometime during the commissioning of the plant or during its early production, which caused quite a fundamental change to the blowdown operation. It must have been the case that there was some difficulties in discharging the powder from D602 because the operating procedure was changed such that D602 was pressurized slightly to 0.3 bar G using the nitrogen supply to assist the discharge of powder. In order to do that, the vent valve had to be closed to allow the pressure to build up. And this activity of discharging powder occurred roughly every 5 to 7 days. When this change happened, there was no formal management of change review carried out, which should have been the case because V1 changed from being a maintenance only valve, an isolation valve, to being a routinely operated valve. About 3 years before the incident, a HAZOP of the plant was carried out, and in the section for blowdown, various recommendations were made. These included providing a remote display of the position of the vent valve, V1. And if you remember, I said it was located about 15 meters above ground level. Therefore, it wasn't in a position where people could walk past and see which position it was in. So it was recommended that a remote display of valve position in the control room should be provided. There was also another recommendation, which was to provide an interlock between V1 and the inlet valves to the vessel D602. Now, the interlock between those valves would have prevented a high pressure being achieved in the vessel by preventing any material coming into the vessel when the vent valve was closed. So there would have been position indicators installed on V1 and the two inlet valves to D602. However, the actions were not implemented straight away. In fact, at the time of the incident, they hadn't been implemented. And it was argued that the improvements would have required a plant shutdown, and they were not prioritized because the justification for those actions was one of improving operability rather than plant safety. Now here's a picture of the vent valve, V1, after the incident, and I'd like to draw your attention to the left-hand side of the drawing showing the spindle of the valve. Now the spindle is in the extended position, which indicates that the valve is open. Okay, so that's how the valve should normally be. I seem to have missed a slide. I wanted to show the valve in the closed position. Okay, I don't think it really matters. Now, I want to discuss the sequence of events leading up to the incident. About 5 days before the incident, an operator had been required to discharge powder from D602. And to do that, he had to close the vent valve on D602. So therefore, the operator had to climb up to V1. And for some reason, even he didn't know why, he failed to reopen it after the powder discharge. And he therefore, well, he forgot basically, and he didn't inform the control room supervisor. So the control room supervisor was not aware that the valve was in the closed position. About 1 day before the incident, the plant was being restarted. Some equipment had broken down and had been repaired, and the plant was being brought back online. And there were some transient problems, some irregularities, some process upset, which caused high levels of powder to accumulate in the product recovery vessel F301. And if you remember, F301 could be the feed into it could be diverted to D602. That's what actually happened. In order to get around the problem of high levels of powder in F301, the flow was diverted to D602. What that meant was that D602 was then exposed to much higher pressures than normal. And the pressure increased and eventually reached a figure of about 5 bar G. And the importance of that is that the pressure sensing device on D602 went out of range at 5.1 bar G. At that point in time, it was calculated that the vessel contained approximately 10 tons of propylene vapor and about 33 tons of powder. In the last 45 minutes before the incident, there were multiple alarms sounding in the control room. And it was calculated that the rate of alarms was averaging 75 alarms in each 10-minute period on average, okay? A huge number of alarms. The pressure increased above the measured range. We obviously don't know to what pressure. And it was calculated that D602 ruptured at a pressure of somewhere between 24 and 37 bar G. Just going back to point 9, the average of 75 alarms per 10 minutes compares to a maximum recommendation in the alarm standard of 10 alarms per 10 minutes.
Sorry, Mr. Allen, 2 minutes.
2 minutes, good,
yeah.
okay,
Yeah.
Thank you.
Thank you, thank you.
The main findings of the investigation were that the root cause was obviously overpressure of the vessel. V1 should not have been used for a routine operating task. V1 was not really accessible and there was no remote position indicator. There was inadequacies in the procedure for locking and unlocking the valve. The standard operating procedure didn't tell the operator to lock the valve open again at the end of the powder discharge. And of course, we had the excessive number of alarms. There were various improvements suggested from the investigation. The obvious one being to install a separate pressure relief valve and vent to reduce the alarms, to improve the procedures and the valve locking procedure, and to carry out the HAZOP actions more promptly. The main lessons learned was about the design of the venting arrangement, not just for having a valve in the vent line, but also having the cyclone in the vent line, and of course, no pressure relief valve. The original process designers did not foresee the need to pressurize D602, and when that happened, it changed the risk completely. The risk was dependent upon a procedure, and of course, all procedures will eventually fail. There were various recommendations for improving the alarm management. And my final slide is some questions to you. Why would you not want to shut down when the plant exceeds its design rating? Are all safety critical tasks identified in your plant? And is your valve locking procedure robust? Do you understand what should trigger a management of change review? And who has overall responsibility for alarm management? Alarms are often driven by code requirements, but somebody should take a helicopter view of the overall effect. And finally, are you sure that your HAZOP actions are implemented promptly? Thank you very much.
Okay, thank you, Mr. Allen. We can discuss these questions at the end of this session in the open discussion. We will move to the next presentation with Mr. Wadad Al-Dahan. He's an assistant professor at Al-Nahrain University in Iraq. The title of his presentation is Chemical Risk Assessment for Urea/Ammonia Production Plant. Okay, Mr. Wadad. Dr. Wadad, you're with us?
Assalamu alaikum.
Alaikum salam. Okay. You may share your presentation.
We are talking about ammonia urea complex. First, it is important to know that this industry is urea ammonia complex based, especially for ammonia, based on the reaction that feeds the world, which is the producing of ammonia from the air. We can see from the left picture, there is, without this reaction, people have enough food for 4 billion people. Now it's about 7 billion people on the earth. That means that without this reaction, people will remain without food. 3 billion people will be without food. An ammonia plant, most accidents are related to the release of ammonia. However, the possibility of explosion or fire-related accidents where natural gas and hydrogen are present in high pressure. We will take a look next about the details of this process. In a manufacturing plant, there is a possibility of ammonia release as well as explosion due to formation of explosive gases, mixture of oxygen and hydrogen in units like urea reactor, carbon dioxide gas purifier. Now, let's take a look about ammonia plant to consider some of the equipment, the materials in this plant. We can see in this point, we have hydro decertifier from natural gas. By hydrogen, it is important for sulfur compound removal. In the next step, we have a primary reformer, which is the steam reformer, which is working in a degree 790 degrees Celsius, used to produce hydrogen from natural gas. The secondary reformer, which is working in the temperature at 1000 degrees centigrade, which is used to convert the unconverted methane to hydrogen. So the main action for the primary reformer and secondary reformer is to produce hydrogen from natural gas. The other steps based on high temperature shift or low temperature shift, which is mainly to convert carbon monoxide to carbon dioxide. The other step for this plant is the carbon dioxide removal. In this part of the plant, it is important to remove carbon dioxide, which is considered as impurity in the gas stream. We can use methyl diethanol amine in this step to remove carbon dioxide. And the other step, methanometer, in this step, methanometer used to convert carbon monoxide or carbon dioxide to methane. The final step is the synthesis of ammonia. We can see in this plant, we are dealing with high temperatures, some equipment dealing with high pressure, or some materials which is highly hazard, which is hydrogen and natural gas. We will highlight the dangers of these materials in the next slides. The major hazards of hydrogen and natural gas, we can see the physical properties for these gases from the picture. We can see the flammability range, of hydrogen. It is a very important property to be taken in consideration, which is the difference between low flammable limit and upper flammable limit. We can see that hydrogen low flammable limit is 4 and the upper flammability limit is 74. So the different or flammability range you can see is about 70. This is very dangerous gas. We can compare with the natural gas. The natural gas low flammability limit is 5 and the upper flammability limit is 15. So the flammability range will be 10. It is very different from hydrogen and natural gas. The flammability range is about 70. The flammability of natural gas is about 10. Flammability range defined as the percent of vapor in air necessary for combustion to occur. Flammability range, we can see we are talking about the flammability range, the difference between low flammability limit and upper flammability limit. This is important because the wider this range, the more hazardous the chemical may be considered from fire standpoint. The relative vapor density shows that these gases.
Mr. Udat, can you raise your voice, please? Sorry for the interruption. Just please.
Okay. Okay. Thank you. Okay. Thank you. Now we can see about the relative vapor density for hydrogen or natural gas. The relative to air, the relative weight of gas vapor compared to air, which has an arbitrary value of 1. If the gas vapor density of less than 1, it will be generalized to air. If the vapor density is greater than 1, the gas will gradually sink to air. This is important in case of gas spill to know the gas will rises or sinks in air. The minimum energy, of hydrogen air mixture is only about 0.019 millijoule, whereas the other flammable gases such as petrol, methane, ethane, propane or butane, and benzene is usually the order of 0.1 millijoule. This means that the hydrogen is easily ignited, which is one of the most important material in this plant. The major hazard of this process is the raw materials, which is natural gas and hydrogen. We can see the hazard statement, which is extremely flammable gas, may explode if heated, may cause damage to central nerves. The hydrogen hazard statement, it is also extremely flammable gas, contained gas under pressure, may explode if heated. Now we can see from the most important document we used in safety purposes, which is the MSDS, in the material safety data sheet, or SDS, in the safety data sheet. This is the main precautions. We can say that these gases must be kept away from heat, hot surfaces, spark, open flames, and other ignition sources. No smoking, this is important. These signs, which can see from the hazards of these materials, which is the first sign, which is extremely flammable gas. If we can't deal with compressed gases. We can see this sign, which contains gas under pressure, may explode if heated. The other sign, which is cause damage to organs through prolonged or repeated exposure. These signs, it's very important to be used in urea ammonia plant. Several accidents have been reported at ammonia and urea plants. On March, one of the accidents we can focus on March 2005, a fertilizer plant in China, the urea sensitive reactor exploded. The explosion, we can see this is the urea sensitive reactor. The explosion killed 4 people and seriously injured 32 people, raising the direct economic losses to $4.3 million. We can see the urea synthesis reactor exploded in the picture that I mentioned. Other accidents include fire and explosion due to mixture of hydrogen, nitrogen, and ammonia in the Terra nitrogen plant, UK. We can see from this part of the plant is the synthesis of ammonia, which is dealing about the hydrogen, which is we discussed before. These pictures can see explain the explosion of a mixture of hydrogen and nitrogen plant in the UK.
Sorry for the interruption. 3 minutes remaining, Mr. Wadad.
Okay. A case study, the major explosion erupted through the ammonia urea factory in Norb 2 unit in India 2020. The blast destroyed several machines and caused extensive damage. However, it have been reported some injuries. According to locals, the blast could be heard even 10 kilometers. The blast took place in pipeline connecting a high-pressure ammonia sensitive gas compressor and ammonia reactor. It goes through the preheated furnace. We can take the conclusion. The ammonia urea production plant is considered one of the important factories that benefit the increase the global food production. The material used in these production units are considered hazardous from the point of view of toxicity and explosion, as we explained. Following safety and instructions is very important, and risk assessment procedure is very important. Education workers about the nature of risk will help in increasing safety and reduce accidents rates. Thank you.
Thank you, Mr. Wadad.
Thank you.
We will move to the next presentation with Mr. Makram Shiyab. He's a lecturer in the Islamic University of Lebanon. The title of his presentation is Environmental Risk Management Using Geographic Information System, GIS, Delimitation of Groundwater Pollution. Mr. Makram, you may start.
Okay, thank you. Good evening, everyone, and maybe good morning to some of you. First of all, I would like to introduce myself. My name is Makram Shahib. I'm a geomatics engineer and urban planner, and I'm a lecturer at Islamic University of Lebanon. Today, I will present a research on behalf of myself and my colleague Kamel Allaw. This research has been done at Islamic University of Lebanon. Okay, first of all, the good governance of groundwater is at the heart of Sustainable Development Goals, or SDGs, since it plays a crucial role in ensuring food security, sustainability of ecosystems, and it helps us facing the challenges of climate change. As we all know, geospatial technologies such as Geographic Information System, GIS, and remote sensing could play a relevant role in the domain of environmental risk assessment. So, the aim of this paper is to determine the zones that could be affected by the pollution caused by the bad treatment of wastewater and to propose a plan for risk management. First of all, I will define what is groundwater recharge. Groundwater recharge could be defined as the process of water circulation from the top surface to feed aquifers. The factors that affect groundwater recharge are precipitation density, soil, geology, land use, topography, lineament density, and drainage density. I will define each one of them and I will explain how each one of those factors affect the groundwater recharge. First of all, precipitation.
Sorry, Mr. Makram, can you raise your voice, please?
Yes, okay.
Oh, perfect.
As we all know, rainfall is known to be the dominant source of groundwater recharge across all climatic regions. So, when the quantity of precipitation is lower, the recharge will be lower. And when the quantity is higher, the recharge will be higher, as the following image shows. Second factor is soil. Soil type affects groundwater recharge. Some types could be considered more favorable for recharge than others. Third factor is geology. Geology affects the recharge process. Some geological features could be considered more favorable for recharge than others. This is explained using the following images. Fourth factor is lineament density. Lineaments are linear or curvilinear structures on the Earth's surface, which indicate the variation of rock's resistance or the presence of fractures. These fractures promote the infiltration of water. So, when the lineament density increases or the presence of lineament increases, the groundwater recharge increases. So, we are a higher potential for water to infiltrate towards the aquifers. Fifth factor is land use. Land use plays a significant role in the development of groundwater resources. It controls many hydrological processes in the water cycle, such as infiltration, evapotranspiration, surface runoff, etc. As you see in this image, the type of land use affects groundwater recharge. So in urban areas, for example, the recharge is lower than in other regions, for example, the green areas. Sixth factor is slope. Slope has an important role in precipitation's infiltration and then in groundwater recharge. Higher degree of slope results in rapid runoff and increased erosion rate with feeble recharge potential. Larger slopes produce a smaller recharge because water runs rapidly off the surface of steep slope during rainfall, not having sufficient time to infiltrate the surface and recharge the substructed zone. This is shown by the following image. When the slope is lower, the recharge is higher. Drainage density, the structural analysis of a drainage network, helps assess the characteristics of groundwater recharge zone. So when the drainage density increases, the groundwater recharge decreases because the permeability decreases. Why is it important to determine groundwater recharge potential zones? Because determining groundwater recharge potential zones helps in specifying zones that have to be protected from pollution in order to guarantee the sustainability of this resource. Second, orienting land use planning to conserve those zones. As it's shown by the following image, those are the zones, for example, it's an example that are a potential for groundwater recharge. So we will orient the land use planning in order to protect those zones. Why GIS and remote sensing are important in delimiting groundwater recharge potential zones? First of all, let me define what is remote sensing and what is GIS. Remote sensing is the acquisition of information about an object or phenomenon without making physical contact with it. The term is applied especially to acquiring information about the Earth from satellites. Regarding GIS, a Geographic Information System, or GIS, is a framework for gathering, managing, and analyzing geospatial data. Analyzing the data provided by satellite using Geographic Information System could help in delimiting groundwater recharge potential zones. The methodology of this study consists in 2 steps. First of all, each one of those factors will be studied and the map will be established as a result of the study. Then those factors will be combined using GIS in order to obtain the map that shows groundwater recharge potential zones. The second step is a fieldwork surveys where each municipality in the study area was asked to give a description about the treatment of wastewater. The description has been transformed into a numerical indicator that represents the wastewater treatment status. After that, those 2 sources of data has been combined to obtain the map of risky zones. After that, a plan for risk control has been established. The study area is the Nabatieh Kaza, which is one of the 4 districts of Nabatieh Governorate located on the southern border of Lebanon. As you see, the maps of each factor, for example, land use, lineament density, geology, soil, topography, precipitation, and drainage density, remote sensing data helped us to prepare each one of them, and the analysis of data has been done using a geographic information system. For example, this map shows that these regions are bad for groundwater recharge, while these zones are good for groundwater recharge because the quantity of precipitation is higher than this zone. The combination of those maps help us obtain this map. This map shows the groundwater recharge potential zones. High recharge area are distributed over the study, especially in the northern parts. The map shows that 70% of the study area presents high recharge. After that, the result of the study or fieldwork survey allows us to obtain this map that shows the wastewater treatment status in Nabatieh municipalities. For example, the municipalities shown in green have a bad treatment status or 0%, which means that they don't have the needed facilities to treat wastewater, and then wastewater is not treated. And municipalities that are shown in white have a percentage of 100% of wastewater treatment. So the combination of those 2 maps, this map and this maps, allow us to obtain this map that shows groundwater pollution risk because of bad wastewater treatment. Because the overlay between the groundwater recharge potential zones map and the map of wastewater treatment status has resulted in the following map, which represents the risky zones. For example, the green areas has a low risk level, while the red area or areas have high risk levels. As a result, we established a plan. I'm presenting a summary of the plan. The following steps must be taken: development and in some cases establishment of wastewater treatment networks, protection of high recharge zones through the establishment of new plans respecting those zones. I mean by that land use plans, imposition of fines for not respecting the condition of wastewater treatment. As a conclusion of this paper, the conservation of water resources and especially groundwater should be a public priority. The use of geographic information system, GIS, and remote sensing technology was efficient for the delimitation of groundwater recharge potential zones. The performed survey allowed the authors to evaluate the status of wastewater treatment and to quantify it. The combination of the map representing the recharge zones and the map representing the status of wastewater treatment was relevant to determine the zones which suffer from pollution risk due to the inconvenient wastewater treatment. It is necessary to take immediate measures related to the planning of the region and the establishment and development of wastewater treatment networks. At the end, I'd like to thank you and hope you enjoy this conference. Thank you.
Thank you, Mr. Macron. Now we will move to the next presentation with Mr. Mahendran Gundar Gursami. I hope I spelled it right. He's a process safety manager in an oil and gas company in Qatar. His the title of his presentation is Process Safety Culture Through Learning from Incidents. Mr. Mahendran.
Good evening to all. Am I audible?
Yeah, just share your presentation with us, please.
Yes. Can you see my presentation now?
It's loading. Yeah, just enlarge it, please. Perfect.
Right. So shall we start?
Yes, yes.
Okay. Good evening. Salam alaikum to all, ladies and gentlemen. My name is Mahendran Guruswamy. I'm a process safety manager working in a major oil and gas company now. It is my immense pleasure to present this presentation to the Jordan Process Safety Conference. So many thanks to the organizers, peer reviewers, speakers, and participants. So my email ID is kgmahendran@gmail.com. If any one of you would like to be in touch with me after the presentation, please feel free to drop an email. So as an introduction, so I'm Mahendran Guruswamy. I'm basically a chemical engineer with the Shell and major Middle East oil and gas refineries with the 26 years experience. So we are briefly going to discuss about why process safety and process safety culture, Buncefield, UK explosion incident, Venezuela refinery explosion, fire incident at naphtha hydrotreater unit in one of the Middle East refinery, and a boiler explosion incident in ExxonMobil Singapore, bow tie concept in process safety, and maintaining the process safety barriers and how it will influence the process safety culture. If time permits, we will discuss the question and answers. So process safety culture. The operating environment in the oil and gas industry around the globe experiencing catastrophic process safety disaster in the history. These events were followed by other notable incidents across the world, including several pipeline ruptures, spills, and explosions. Carefully designed, well-implemented process safety management systems are essential to keep people safe and protect environment and asset. As you all aware that process safety management primary concept is to save the people, plant, and environment. So we have to keep the people, the contractors, whoever working at the site to the safe, and next our plant to be safe, and the environment. The recent comparative study of several major industry accidents that occurred between 1980 to 2020, it's indicating that most of the affected organizations had not maintained their process safety barriers. If you notice that, I can notice that many process safety experts are in this meeting now. If you notice that many companies have started the process safety management system implementation after a major catastrophic process safety incident. So to avoid and to be a proactive approach, so we have to learn from others' mistake. And we have to start a process safety culture as a first beginning starting of the process safety implementation. So next slide, if you see here, I have put the famous incidents here: Sivoso, 1976 Italy incident, Flixbro in 1974. You can see Longford incident, Buncefield incident, Pfeiffer Alpha, Texas City incident, and Bhopal incident in India. So some of the photos to create a chronic unease. If you are hear this word chronic unease, is the major step that we should not be relax and sit back that okay, I'm operating the plant in many years, so nothing will happen. No, that is not the case for the process safety disasters. So we have to be always be prepared to manage the emergency situations. Right. if you see the Buncefield UK explosion, some of you might have been heard about it. There, the many process safety barriers were failed in this one particular incident. There was a, the gasoline tank was filling, and there was no process safety barriers maintained in that particular area. That the level switch high was not activated, level was not building up, and the panel operator did not see the the level is going up. So finally there was a loss of primary containment, and the ignition source were there. There was a big explosion and fire and explosion. So there was a huge loss for the company. This is one example that the process safety barriers to be maintained. So in case, if you want to maintain the process safety barriers, you have to have a proper process safety culture in your organization. So next famous incident, Flixbro incident. A reactor was bypassed with the temporary pipelines. If you see here in the right side, this pipeline was not there, and they made a temporary bypass line, and it was not discussed. There was no risk assessment, no management of change. They straight away fixed, and when they started the plant, it was there was no proper engineering was not done, so MOC procedure not followed. Highly flammable hydrocarbon releases from the pipe, which gives away due to the vibration. There was no proper support in this particular pipeline. So this is the famous incident for the management of change. So next one is a Venezuela refinery. If you see in the picture, there was the big explosion happened in this particular refinery, but this happened due to a minor leak from a LPG pump. A minor leak from a pump seal, which was left unattended and for a month, because they were not giving there was not proper the process safety culture. The process safety was not giving a first priority, so it was a minor leak from a pump seal, so which was created a catastrophic incident and proved more than 50 people were died in one particular incident. So the previous incident in the Flixbro incident is it's a classic example for management of change, and this incident is a very good example for reporting. Even it is so small, report it, find it small, fix it small, report it, so that we will avoid a major catastrophic incidents. So this is another major accident happened on one of the Middle East fire and Middle East refinery. So this happened one of the naphtha hydrotreater unit in the refinery. So you can see in the background in the picture that chemical drums are kept over there. You see this black color chemical drums are kept over there. There was some excavation was going on, and you see another chemical drum here. And this unit is a very congested area. So there was a fire in this naphtha hydrotreater unit area. So it happened in 2014, 4th December. If some of you remember that, exactly 4th December 1983, the Bhopal incident was happened. So this incident, coincidentally happened on the 4th December 2014 at 2:39 afternoon. A fire broke out in an naphtha hydrotreater unit in the feed surge drum. Within the first 12 minutes, the fire was spread through the sewer system. Emergency level 3 was declared, and the fire was brought under control approximately after 2 hours with the multiple people involved. Refinery was shut down for 14 days. Asset damage and reputation loss. Repair cost was around $2 million US. Production loss was 100,000 barrels per day. So more about the incident. One day before, the naphtha hydrotreater unit was experiencing a water, the water level was increasing. Hot work permit issued for for a civil work. 6 contractors started excavation, closed the naphtha hydrotreater unit. The work consists of cutting the concrete topping. Waterboard drain was, okay, I will not go through all the point, but I will quickly explain to you what happened was. The contractor, civil contractor was working in the next to the naphtha hydrotreater unit. But in the naphtha hydrotreater unit, they are having a process upset. They were draining a naphtha, which was not informed to the civil contractor. So when they were draining a naphtha, and simultaneously these people were using a jackhammer. If you see in the picture here in the right side corner, they were using a jackhammer and removing the concrete pavement. And when they were using this jackhammer, simultaneously, if you see in this picture, they have draining the hydrocarbon, and there was a fire, and they kept many chemical drums next to the unit, so it was exploding, and which was a major accident, and 10,000 people were evacuated from that plant. And why I'm mentioning here, this all, if you call a OSHA process safety incident 14 elements, or if you take a CCPS element, all the elements were failed in this particular incident because they did not have a proper process safety culture in that particular plant. So the next slide is talking about the boiler explosion in ExxonMobil Singapore. You can see in the background of this picture how the impact of this incident, and this is also due to a minor problem. I will tell you what happened there. On December 9th, 2000, at around 2:30 hours, 3 personnel were trying to restart the boiler when an explosion occurred inside a furnace. All 3 were badly injured, out of which 2 were died later in the hospital. So this is a overview of the boiler. Total heating the surface is 2,203 meters square. Design pressure is 120 bar. Can produce 160 tons per hour of steam. Burner can burn 8 different type of fuel. So what happened there? You can see before the incident how beautiful the plant was. After that, how it collapsed. So what went wrong there? Deviation from written operating procedure, they did not follow. The boilers were in commissioning state at the time of the incident. The bypass method was used by a startup team, and they had stopped using when the permanent solution was found. Process technician continued using a bypass method without knowing the hazards. No management of change, approval for the temporary changes, especially for the ESD bypasses. No control of defense procedure for opening a bypass valve, which were car seal closed valves. No PSSR conducted before commissioning, so pre-startup safety review is a critical barrier to maintain the process safety barriers. And lack of training. 2 operators was not trained, so both died operators were not trained by the boilers. So here, bow tie concept in the process safety management. If you see there, we have many process safety barriers are available in the plants, and all of them have to be maintained well. If you are not maintaining any one of them, then it will lead for a catastrophic incident. If you see the left side, it is a prevention barrier, detection barrier, control, medication, and emergency response. So we have to maintain all these barriers, but to maintain these barriers, we have to have a proper process safety culture in your organization. Even though if you have an intrinsically safe design, even though you have a management support, but you should have a basic concept of culture, we do it right, that kind of concept to be established. If you go to the next slide, so our hazard normally is, the hydrocarbon or hazardous chemicals. So this is our asset, which is the people. We have to save our people. So we are having a barrier in between. So those barriers to be maintained well. So here we have a prevention barrier, detection barrier, control and medication barrier, and emergency response. If you take, example of a tank overfilling, which I was talking about, the Buncefield incident. So they prevent to overfill because the operator was not taking care of the level is going high. Second one, their hard barriers were failed. It was not maintained, or they don't have it, that the level switch high was not maintained. When it was start overflowing, that nobody was noticed that it is overflowing, including the panel operator and field operator, and their detection system was under bypass, so it was not activated. So when they came to know that it was the leak, but the time it was out of control, they were unable to go for an emergency shutdown because the ESD system was not maintained well. And of course, the final defense emergency response also failed because they did not have a proper emergency drill. So if you notice here, all their barriers were failed. Here you see all the barriers were failed in the prevention, detection, control and medication, and emergency response. So to emphasize to all the participants that process safety, the incidents are very expensive. So we learn from others' mistake and create a chronic unease across the organization. And implementing a process safety, you need the great support from the board of the directors until the field operators. Process safety is not one single person or process safety department's responsibility. It is everyone's responsibility to make this, the culture have to be created and be prepared in case of process safety incident happen in your organization. Thank you very much for listening.
Thank you, Mr. Mahendran. We will move to the next presentation with Muhammad Al-Naimat. He is from the CBRN Training Center at the JAF, Jordan Armed Forces. The title of the presentation is Chemical Support Unit at the Royal Engineering Corps. Mr. Muhammad.
Yep, I'm with you.
Thank you. Can you share your presentation with us?
Yeah, sure. بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. This is Major Muhammad Al-Naimat. I'm chemical engineering working on the Jordanian Armed Forces Royal Engineering Corps and the Chemical Support Unit in the CBRN Center of Excellence. This is a good opportunity actually and to be here with you guys and this community because we also meant that the Army community is one of the communities that should be involved with the, let's say, civil communities working on the in terms of security and the safety in terms of the CBRN staff. So we appreciate that invitation as a Jordan Armed Forces from our colleagues like Engineer Yaqub, who represent the engineer or Jordanian Engineer Association. Let's start my presentation under this agenda. The Chemical Support Unit mission, which is the CSU, the abbreviation of it, our capabilities, our Joint CBRN Defense Training Facility, which is the CNU Center, the CBRN Training Center of Excellence, and finally, I will talk about the SVA, which is the Process and CBRN Training Center of Excellence applied on it. Moving to our unit, so basically, really in 1972, the Jordan Armed Forces heads up about the chemical, biological, nuclear, and radiological weapons, especially in our region. Like the threat is pop up from that time. So they develop a new sector of the army as a new formation, like specific on a chemical. So we started in 1972 as a chemical platoon. Then we changed our size in 82 to the battalion. In 1986 for the chemical group until now. So our mission is basically provide all the Army, Air Forces, and Navy units with a cyber support to conduct their mission in cyber environment, which is very important to get the soldiers, first of all, working free and safely in that unconventional environment. The new thing for us is basically how to build a trust and how to complete the cycle of the knowledge from the civil authorities and civil association who are basically our the piece or the complete piece of the cycle, which is support and train security agencies and the civil authority in order to give the defense for the cyber stuff. Our mission in peace, it's assist the JAF, which is Jordanian Armed Forces chemical, biological, radiological, and nuclear requirements, and also inspect and issue the equipment to formation and training them in order to give that defense. Talking about our main tasks, there are 5 main tasks. We are basically implemented on our missions, which is the protection, training, giving the training and do the protection for our forces and our colleagues from the civil authorities, recon, which is the reconnaissance, especially for the reconnaissance teams, and also the decontamination, doing the decontamination process, and also supply all the authorities for the decontaminations. Modeling, which is the big piece for us, which is the prediction thing. It's basically talking about how we predict after the accident will happen, something like leakage, starting from leakage of the any like pipe in the line on the process itself until like attack from the missile or something like that, or in terms of talking about dirty weapons or something like that. And finally, we have the capability or the task, which is the verification. We do the verification thing piece inside our laboratories. Talking about the decontamination, so we have like 4 different ways to do the decontamination process. It depends all the way after the accident has happened. So we have the 4-line mass casualty decon system. It's basically designed to a casualty or a mass casualty happened on an exterior, like a big, very big accident. We do the decontamination process for the personnel inside this line, which is I pointed to that system. Here we have the personal decontamination kits. It's RSDL M21, M295, M291, plus the M12, M17, which is a big apparatus to do the decontamination with showers and do the decontamination, which is chemical decontamination, and kill the agents on the skin. Finally, we have the sprayer bars for the airfield decon, which is basically a special design to do the aircraft or the airfield decontamination and for the whole areas. Our capabilities in terms of detection, we have in the chemical agents like a lot of devices. We're familiar with like the latest one, M41, A1, which is JCAD, M21 plus true and first defender. We basically rely on these devices on the ground zero to take like a quick view and quick sample, and to determine if we have like a deadly weapon used in that area. Talking about radiation, we have the Falcon 500 and the isotope identifier plus the polymaster. This is the famous and devices in the Jordanian Armed Forces. We use that to again doing the recon and specified if there is radiation or any isotopes like in that area. Finally, we have biological detection. It's simply with the handheld assay and Razor EX, which is basically detect all the bio agents, including the anthrax, all the bio traps with the protein. In terms of verification, nowadays we applied our laboratory with a new injection of the new instruments. We are talking about the GCMS and the microscope, gram centiunit, which is talking about the microscope, staining and searching about the biological and chemical agents. Also, we have the FTIR, PR2, and Razor EX, which is three smart devices can detect easily the biological in terms of anything attack on that area. So the Jordan Armed Forces nowadays is turned on like we need to spread our knowledge and build our knowledge, sharing with our Jordanian, firstly, Jordanian Association developer researcher, especially with the universities. So we have a lot of agreements, let's say, with the Hashemite University, with the Jordan University, and also new technology of the Balka University. After that, we built our Cyber Training Center of Excellence, which is this facility is built to apply all courses inside this facility. I will show you something like what's inside this facility. It's basically a small city that simulates that we have a site, a real site, consists of a laboratory, class and control room, residential building, factory, as you can see, and governmental building, theoretical field, special training field, which is the tunnel working like underground, and we have a hospital. So this training facility is built basically to apply it or to give a chance for our students to apply their knowledge inside that facility. Again, our mission in Cyber Training Center of Excellence is train the JAF, which is Jordan Armed Forces and national authorities, and all the international, our trainees, enhance their capabilities in terms of counter WMD, weapons of mass destruction, and ensure an effectiveness for the response in case of any confidential incident. Here you can see the courses that held in our center. We have the 4-line mass casualty decontamination system, WMD basic survey, fast response teams. I think one of our colleagues that mentioned the fast response teams in his presentation. We teach our students about this field, and actually the Army was the first trigger on that cycle for training, because in early of 90s, the Army, the Jordanian Army, was the first community or association who built our national plan in terms of the Cyberni. So one of our big piece of that plan was how to respond if there is something happen, like starting again from a leakage from like a factory or chemical factory until like a terrorism attack, something like that. So we applied that and implemented that to our contingency plans. Finally, we have the national plan, which is against terrorism, national plans. The big piece of that plan is basically a fast response teams in terms of WMD, counter WMD. And we have also WMD advanced survey. It's a big piece of the reconnaissance system, and it's basically an advanced how to discover and detect and also do the sampling procedures inside the ground zero, the hotline. And we have the latest WMD detection devices, biological security and nuclear security, also the chemical security. It's basically 3 courses held in the Cyber Training Center of Excellence. Nowadays, we are building our curriculum based on the current situations, especially in terms of security. Because I noticed that we have a lot of like mentions in our colleagues in this conference that we mentioned a lot of safety, no mention on security, because the security and safety is basically close together. But the security for us is a big piece because we deeply doing the research about what's the risk for even the personnel who works on the ground or back in for the material itself. So we think it's a very big piece, and we focus on that. I will show you a slide about how we're dealing with SUV or how we're dealing with security vulnerability lenses inside the center. And also we have the chemical lab instruments, which is basically describe all the lab instruments we have as I shown in the previous slide. And also we have the duration here in the weeks. So as I told you that we have the security vulnerability assessment here in center. So we are an intentional personnel in any factory who will get an permission to build inside Jordan. Because of that, they rely on us like to do especially the step 3 and 4 for the threat assessment, because the background of the army and the intelligence reports, also the background and the knowledge from our scientists for the material itself. So we applied that in table and given the manager or the safety, let's say, team of the factory who will build on inside Jordan that information to help them to build that process in safe environment. Also, we applied on like from step 1, project planning. So we given advice on that planning piece, starting from choosing an area until like doing the calculation of the storage for the material itself or the out product of it. Step 2, the facility characteristics or the characterization of the facility, which is basically again we are one of the person who signed that paper for giving the permission of the factory, because we're doing a lot of inspections through the governmental let's say authorization of that. Again, step 3, which is the threat assessment. We do a lot of research about the threat assessment in terms of person and the material itself. I'm talking about the person, so any threat like attack area or something like easy to attack, and until the storage of that material or the end of that process material. The vulnerability and the countermeasures, we close together, working together for our community to build a trustship between the factory, the civil factory, and the governmental authorities by that. Finally, this is the whole steps of us, like doing from project planning until the identify the countermeasures of the process itself. I re-emphasize that the threat assessment from the like adversary or the enemy identification, then who are the enemy, and any assist or threat matrix and pairing with in terms of like approaching for the material or the target, and also giving a scenario, especially the CSU and the center have the let's say modeling capability to do the after the accident what will happen. Sorry. That's all we have. Thank you very much. And again, I appreciate this opportunity to be in my person in this good conference. Thank you very much.
Thank you, Mr. Naimat. We will move to the next presentation, Mr. Muhammad Hima. He's a corporate risk associate in the UK. His presentation title is Analyzing the Effect of Human Error Calculation Techniques in Quantitative Risk Assessment. Mr. Muhammad, you may start. Mr.
Yeah, so give me 1 second, please.
Yeah.
Just trying to share my screen. Okay, desktop. Okay, can you see my screen?
Yes.
Okay,
you can go. Please.
Okay. Assalamu alaikum and good evening, everyone. Firstly, I would like to thank the Jordanian Chemical Process Safety Engineers Society for organizing this event and allowing me to present here today. So the purpose of this presentation is to review a case study which I created to review the different ways of which human error can be quantified for use in risk assessment studies and the effect that which these different human error quantification methods can have on the results of a risk assessment. As the host mentioned, I'm a senior consultant at Corporate Risk Analysis, specializing in safety, risk and reliability studies. And my experiences have been predominantly working within the Middle East with many operating companies over there. So before we begin, it's important to understand what is risk. I'm sure, you know, as safety engineers, you all know what risk is, but it's always good to reiterate it. So what is risk? A risk is a combination of the frequency of occurrence of a harm, of a hazard, or a hazard is known as a source of potential harm. So it is a combination of a hazard and the severity of that harm itself. For example, a hazard could be a more flow into a tank, leading to potential carryover and loss of containment. Whereas the risk could be that this tank is manually filled 10 times a year, and as a result, the operator could make an error 1 in 10 times every time he does, 1 in 10 times he does that operation. And 1 in 10 times that could result in a fatality. So it is that combination of not just the hazard, but is the severity or occurrence of harm and the severity of that harm as well. When we talk about risk assessments, there are a number of different techniques that can be used in order to conduct a risk assessment. We have the qualitative risk assessment. Yesterday, there was a very good presentation by one of the presenters on looking at hazards and hazard studies. So that is a form of qualitative risk assessment. That is where we look at things, but we don't quantify the numbers of it. Then the other type is a semi-quantitative risk assessment. This is, for example, a layers of protection analysis, a LOPA, or a fault tree analysis. And again, yesterday we had another very good presentation from one of the loss prevention department consultants at Saudi Aramco talking about LOPA and some of the limitations of the LOPA itself. And the third type of risk assessment technique is, for example, a quantitative risk assessment, which looks at quantifying all the risk and contains a number of different elements to it. This presentation will focus mainly on the semi-quantitative and quantitative risk assessments and how selection of human error probabilities can affect the results that you get from these sorts of analysis. So how can we quantify human error? Many years ago, the most predominant way of quantifying human error was through techniques such as human error assessment and reduction technique, which is known as the HART assessment, as well as the TESIO. So they were normally done in these sort of methods, but then more recently, over the last decade or so, you've got prescriptive methods which have come around where you put a single value to an operator without doing any additional analyses to it. And this is becoming a lot more common these days it's with a lot of operating companies. And there's a number of issues that could be, that could arise from this. So, but it does have its benefits. It eliminates the needs for calculations. There's no need for long calculation spreadsheets to, calculate, okay, what is the error that a person might do this, going through all these different questions that you might get in a HART and TESIO assessment. So it eliminates the needs for that. And sometimes, not often, but sometimes it is based on a company's operating experience. So the company might choose these prescriptive values of maybe 0.1 times per year based on what they've seen within their own industry, within their own company, of how often their operators make these sorts of errors. However, the single most biggest disadvantage to this is that a single value cannot fit all types of operational errors. Doing a scraping operation is a lot more supervised and a lot more proceduralized than, simply closing a valve here and there. There's a lot more checks and verification that goes on. So applying the same value for both instances, it would not be a good way of doing it because you could be overestimating the risk. So this is a remodel of one of the ways that, an example of the ways that some operating companies have used this prescriptive method to create these initiating event frequencies of errors. It's, it goes from 0.1 times per year to once every 100 years, depending on how many times the operator does that action. So for example, if you take the first row, it says the operator, does this action more than once per week. And the initiating event frequency is thus that they are making this error at least once per year. Now, is that really true? So that is what we are, and what effect will that have on the risk analysis? Then we have the HART. The HART is a quick and easy method to use. It addresses ergonomic, task-related and environmental factors that can have a negative effect on human performance. It's based on scoring a series of questions. So it comes with a number of questions and you score each question depending on how the operator feels or how you feel the operator will react in those sort of scenarios. And the tasks are analyzed independently without considering the effect of other tasks. For those of you that may not have seen some of the questions that arise in a HART assessment, these are some of the categories that they look at. How frequent is this operation? Is there a short time? How long is there for you to detect the error? And you go through each of these different questions. This is only a snapshot what I'm showing you on the screen. The actual list is a lot bigger. But you go through all these different questions, looking at what are the different ways that this operator could make an error, and you score each one based on that. And then you get an end value giving you a human error probability. And then after that, we also have the TESIO. TESIO was something a lot more common many decades ago, and its popularity within the process industry was because it was very, very easy to use. It's based on scoring of 5 factors. It depends of the type of task, the time available to perform the task, how well the operator is trained, what their emotional state is. Are they stressed or are they happy to do their job? And what are the plant interface characteristics? And based on this, it follows very similar to how the HEART one does. And you have a scoring and you put in the numbers and it gives you out a human error probability. And then you use this within your risk assessment in order to quantify the numbers. So that's just the background. Now, to go on to the actual case study. So the case study is based on a simple offshore facility, which has multiple wells coming into a tie-in platform. And the case study focuses on overpressurizing the tie-in platform and the downstream facilities. For the purposes of this case study, we're going to be assuming that these wellhead platforms are fully rated to withstand the deadhead pressure from the pumps, which are on the wells, so that you cannot overpressurize these wellhead platforms. And it's only the downstream of this TP, of this valve here, that you can overpressurize. So let's get into it. What this assessment, what this case study was part of was part of a larger HIP study, which I called it, which is known as a high integrity pressure protection system study, which looks at the implementation of a HIPS or the need for a HIPS on a facility. The HIP study contains a number of different studies which go into it, which I'm showing you on the screen. So, there's 2 main areas where you would get the actual human error probability calculations used, and that's within the LOPA and the quantitative risk assessment, and also the fault tree analysis. So, for those of you that haven't seen this, haven't seen something like this, this is an example of a LOPA worksheet. So for this case study, I did a LOPA study on the facility in order to see the effects of what it would have on the SIL requirements. So a LOPA study is done in order to identify the risk gap and thus quantify, and thus set a SIL target for the system that is to be installed, in this case, a HIPS. And this is just a snapshot of a larger study itself. So it doesn't show all the initiating events, but the ones highlighted in yellow are the ones that we're mainly focusing on, and these are the human error events. At the moment, there's nothing there, just to show you that, there's no numbers, and we're going to see how the numbers change when you change the type of calculation method that you use. So using the prescriptive method, MOV that is operated 6 times a year based on the definition that I showed you earlier. Unfortunately, I can't show 2 things at the same time here, but if you saw it before, it was an operator that does something more than once per year but less than once per month. Then they set a frequency of initiating event frequency of 1e to the -1, which is that means that the operator will make an error once every 10 years. So in the first case, the MOV is operated 6 times per year. So we have a frequency of 1e to the -1. In the second instance, we have a blind which is operated once every 5 years. So he very, very rarely uses that. And based on the guidance of the prescriptive method that I showed you earlier, it gave you a title of maximum of once per year. In this case, it doesn't even he doesn't even do it once per year. It's once every 5 years. So how can you, is 1e to the -2 really applicable here? But because there's no other guidances and it just ends at that maximum of once per year, then we've used 1e to the -2. So the operator will make the error once every 100 years. And then after that, we've got another spectacle blind 1e to the -1. So at the moment, I'm just showing you the figures that I'm using, and then we'll see an overall summary of what the actual effect was on the actual LOPA study itself. So that's for the prescriptive method. Then when we go to the heart assessment, I haven't, because of the limited time, I haven't been able to show the actual heart assessment on the actual screen. 15 minutes, there's a lot to cover. I'm having to talk really fast. So heart assessment, if we look at this value over here for the same MOV being closed 6 times per year, 2.62 e to the -2. That's a factor of 10 difference compared to what the prescriptive method was suggesting, with that being a lot more conservative. With the spectacle blind, it's operated once every 5 years. And as a result of that, we've got a much lower frequency. So if you look at the differences between the two values, you can see that there is a very, very big difference, with one being significantly more conservative. And then we have the TESIO. The TESIO is a lot more optimistic for the scraping activities where you are doing something 6 times per year. But when you look at it on the spectacle blind, it's 2e to the -3, which lies in between of the heart and the TESIO methods. So heart and the prescriptive methods. So just to bring everything together, what does that do in terms of the actual results? So if we look at it, the prescriptive method gives us the SIL requirement of a SIL-3. Now, for those of you who may not know exactly what a SIL is, but SIL is a safety integrity level. And the higher the safety integrity level, the better the probability of failure of demand of that system it requires to be. So a SIL-3 is a very, very robust system. And it will require significant operating expenses from maintenance as well as capital expenditure. The heart and the TESIO, on the other hand, give you a SIL-2, and that's a whole level less. And if you look at the risk gap, it's a significant difference. It's a 1e to the -1, a factor of 10 difference. So the prescriptive method is a lot more conservative, and being conservative is not always good. It can lead to significant more costs for the operating company. And the results of that was followed through to a quantitative risk assessment done in FAST and Safety. And this is the results which are shown here. Again, if you look closely, you can see that the blue line is for the prescriptive value. That is giving you a high risk. It is in the intolerable region over here. The heart assessment is slightly above the intolerable region. So, this risk is slightly high, but not as high as the prescriptive value. And then we have the TESIO, and the TESIO lies just on the maximum risk criteria. So it's almost a lot, but not there yet. So you have to prove that it is a lot. So to conclude, the prescriptive methods has the potential to estimate the risk. So you need to be careful when using that. And as I mentioned, being over conservative can increase the CapEx and the OpEx costs for a firm, which they won't necessarily want. For larger studies, especially in the instances of implementation of protection designed to protect large portions of the facility, the heart method is identified to provide the most balanced result. And most importantly, all 3 methods are based on human judgment. So there is a base of human, there is a basis of human error within those own calculations within and of itself. A couple of years ago, there was a study done where a company gave 4 different consulting companies to do a risk assessment with all the same inputs, and all 4 of them came back with different results. So it is based on human judgment, and there are possibilities of some human elements there in and of itself. That is the end of my presentation. Thank you very much. And if you have any questions, I will endeavor to answer them when in the discussion. Thank you.
Thank you, Mr. Muhammad.
Mr. Muhammad, I have just one question. We know that based on your material, there's a human error quantification.
Yes.
And use some special techniques. This data will be comply or what the uncertainty related to the CCBS reliability data for the operator error?
I haven't looked at, I can't remember what the CCPS operator error data is. So I will come back to your question if that's okay in the discussion. Is that okay?
Okay, fine, thank you.
Thank you very much.
Okay, sorry. We will go to the last presentation in this session and this conference with Mr. Muhammad Najmuddin. He's the head of Planning and Studies Department in the Ministry of Environment in Iraq. His title of the presentation is Environmental Impacts of Al-Qayyara Oil Fields and Al-Mashraq Plant Firing Accident During Mosul Freedom Operations. Mr. Muhammad, you may begin, please.
Assalamu alaikum. Hi, everybody. I will introduce my presentations about the environmental impact during the Mosul City Freedom Operations.
Mr. Muhammad, can you raise your voice, please?
Yes, yes. Assalamu alaikum. It's good now. Assalamu alaikum.
وعليكم السلام. بس ارفع الصوت لو سمحت.
Okay, okay. Hello, everybody. Assalamu alaikum. I will now introduce my presentations entitled Environmental Impact of Al-Qayyara Oil Fields and Al-Mashraq Plant Firing Accident During Mosul Freedom Operations. During the liberation of Mosul Governorate from ISIS, there is accident of a huge fire of about 3 million tons of sulfur, pure sulfur and foam. From this 3 million, about 250,000 tons burned during the military operations from 21st of October 2016 till 27th of October. This led to produce yellow cloud cover radius of circle with about 200 kilometers. The area affected by emissions estimated to be about 40 to 50 kilometers downward. Also, beside the firing accident of sulfur dune, there is also another accident in the place near the first one. That was Al-Qayyara oil fields, which contain about 25 oil fields, producing oil field. Also have accident of firing under attack by terrorists. About 17 wells were burned for a long period of time, about nine months, from June 2016 till end of March 2017. So now we just produce some data about the accident which happened to the sulfur factories, sulfur mining factories. This is two accidents happened. One of them during the third Gulf War, the fall down of the Iraqi regime in 2003 for 40 days firing about 450,000 tons of pure and foam, which is kind of waste of sulfur product. And also our case study in 2016, about 7 days, quantity estimated to about 250,000 tons of pure and foam. Here the map, we can see the general company of sulfur production in the north of Iraq, in Mosul Governorate. Here we can see the white colors represent or due to firing of sulfurs, and the black one represent the emissions of oil field firing. Also have some aerial photo from NASA World View. We can see two kinds of bloom, white one and the black one. Here also we can see obviously here after 6 days when the control of sulfur factory is firing, but oil field is still firing. Here we can see in these tables about the smoke frequency of the two accidents and to how much kilometer area affected by these emissions. So we can see a very large area affected by these emissions. Also, from the Moody's fire detection, we can see from 1st of May to 28th of October 2060, a number of detection has very long and rise. We use the assessment, the impact of two accidents. We use the same assessment adopted by UNEP, United Nations Environmental Program, which applied in hotspot assessment during 2005 in hotspot in Iraq. Also, we used or rely on a rapid overview of environmental and health risk related to chemical hazard in the Mosul humanitarian response, which was reported by UNEP and WHO and OCHA. This is our assessment methodology. We assessment the soil, sample of soil and water, including surface and groundwater and the air sampling. And also we estimated the effect of emissions on the biodiversity, plants, fish, birds, amphibious animals. Also, there is another health impact assessment on people. We can see from these maps, the white bloom, the effect of sulfur SOx emissions. Here we can see obviously the sulfur dioxide in Dobson unit, how covered a large area away from the location of accident. We can also notice obviously that the smoke or the emissions also over the border of Iraq to the Turkey and Syria. Well, this is the aerial photo of the first day of oil burning. And here we can see the situation, how bad is it? Cover a huge area and with different wind direction. When the wind direction change the effect. Here to the north, here to the east, here to the west. So we can see the effect change with the wind direction. Here, this is the actual field photo, what happened after the finishing or controlling of fire. Here we can see a lake of oil. Oil spill was very easy to reach Tigris River as the polluted area contain valleys, that natural valleys all ends to the river basin. Also contaminated soil, a very huge area, and air pollution, mainly PM 2.5, PM 10, SOx and NOx. Also food chain problem and the chronic health effect. For the surface and the groundwater assessment, sample of surface and the groundwater were tested and examined, comparing the result with Iraqi legislations, which was river protection system. So this is the sample of our result of the groundwater and surface water with the area affected by the emissions. We can see the numbers with the yellow represent the numbers higher than the standards. We found some area in the river have a high percentage of cadmium. And also we have some nickels in some samples and high sulfate. Here we can see the nickel in groundwater in area affected by the emissions, because most of the oils industry emissions contain some heavy metals. Also, we have cadmium in the surface water. Here we can see the result of air pollution, which measure SO2 and CO and NO2. Most of result was an estimation done after 6 months of the control of fire. So, in my opinion, the air pollution result will not reflect the real situation at that time because of the dilution factor. For soil assessment, 148 soil samples were examined using mobile inspector instrument called Newton for heavy metal measurements. Here we can see we measure heavy metals, lead, mercury, zinc, nickel, chrome, cadmium, etc. We have some point of sampling point. We have over the limitation or over the standard in for mercury and chrome and nickel and cadmium in these sites. For the cadmium, for the 148 total samples, we have about 57 samples over the limit in area related to the affected by the accident. Also for the mercury, we have 2 samples over the limit, which one of the sample point was near the oil field, and another point was in area away from the oil field. For the economic impact to the village or the human in the village near the area, which was agriculture area, we have some questionnaires to the peoples and the villages. There is some problems and death of animals like cows and sheep in this area because of the effect by the emissions during the firing accident time. For the sampling of fish, carp fish, we examine heavy metals in their muscles, and inside the body of the fish we have examined zetane, cadmium, and lead, nickel. We found little about zinc, and this was within the limit of WHO. We don't find heavy metals higher than permissible limit. Also, for some polyaromatic hydrocarbons examined in fish, also we found some result of polyaromatic hydrocarbon, which indicate the polluted river by the emission of oil field. For the sample of plant, also we examined some plant which was natural plant near the area affected by the emissions. Some of them near the river, some of them near some villages. We take samples and examined for heavy metals. We found higher percentage or higher value of cadmium and lead in these samples. Regarding our results, which was in some point we have high pollution, we recommended strongly to urgent intervention to control these area affected by these accidents and to do environmental cleaning and monitoring for this area. Thank you for your attention.
Thank you, Mr. Muhammad. Now we will by this presentation. We will finish all the presentations now. We will go to the open discussion. We have a number of questions. We will start with the questions directed to Mr. Anas from the NFPA. The first question is, do NFPA KSA participate in incident investigation activities in the MENA region?
We don't have any mandatory examination. However, we do participate in the USA and other countries here. But MENA, we are just starting. And we start doing it.
Okay, the next question is, do or will accidents in the region, such as the Beirut ammonium nitrate explosion, be incorporated with NFPA standards?
Can you open the camera, Amro?
Yeah, just 1 minute. Sabah? Okay, so
anyway,
you can start the video if you want.
No, you are blocking me.
We gave you the access now.
No, you didn't. Okay, now you did.
Yeah. Okay.
Basically, NFPA just started in the MENA, Middle East and North Africa. Let me just to emphasize that MENA office in Riyadh, in Saudi Arabia, covers the Middle East and North Africa. We do investigate with many authorities in the region, but mainly in the GCC country. What happened in Beirut explosion is important. If you go back to NFPA codes and standard, there was one big explosion in Texas. And after that, we have a special standard for ammonia nitrate. And if you go back to it, you find everything about it. And unfortunately, in Beirut, nobody implemented the recommendation or the code and standard in the NFPA and that incident. Okay.
Okay, the third question is, what are the major updates in NFPA standard that took place in the last 3 years?
Now, every 3 years, all our standards, we have a 3-year cycle. So if we're talking about NFPA 10, NFPA 1, NFPA 13, 72, 99, 101, each one of them goes in a cycle every 3 years to review. And in these 3 years, they review the feedback from the public, they review any incident, major incident, and they relate it to that code and standard. So, and each standard, for example, 13 has the different cycle than 99 and 101. And each one has different, each code has the different changes in each cycle. So I cannot go back and list all the changes in each standard. That will take a few days for me.
Sure thing. The last question for you, Mr. Anas, is, do NFPA and Saudi Arabia offer training and certification?
Yes, we do offer training and certification, not only in Saudi, we cover the whole region now. And I'm happy to assist any member in Jordan, Lebanon, Egypt, Morocco, all of them. And we are now started in GCC mainly, but we are open to do in Jordan with the Jordanian, for example, Engineering Association, or in Egypt. I'm representing the whole MENA region, so we are open to any collaboration with all the institutions and associations to do training and promote the code and standards.
Sure. We can maybe arrange this in the future. Okay, the next question is for Mr. Arafat. It is extremely difficult to achieve minimum spacing, especially in the case of existing old refineries or chemical plants. So what are the main safety measures to be taken in this case? Okay, it seems Mr. Arafat is not with us. We will go to the questions for Ms. Rawan. Please clarify the concept of using percentages in H2S and CO2 measurement, as these are gases. Usually we use partial pressure for measurement. And the
Yes,
second question
hello. I
is also
explained
relevant.
actually.
Yeah.
Yes, I explained this in the question and answer part. Actually, percentage is 10,000 parts per million, and then we put the value of the ppm, the parts per million, over 10,000, and then I multiplied it by 100 to get the percentage. Okay, so that's why I use the percentage.
And okay, the second question was the pressure to be entered in this tool, design pressure, or the maximum or the operating pressure.
Okay, it's the design pressure, and it's based on the pipeline design standard. There is a table of the pipeline design standard based on the temperature and the percentage of CO2 and H2S, and upon this, the maximum allowable operating pressure was introduced.
Okay, thank you, Rowan.
You're welcome. Thank you.
Mr. Mahendran, we have one question for you. It's what are your recommendations for proper integrity management of pumps, especially the pump seals?
Yeah, I believe that this question because of the Venezuelan refinery incident. So, you know, to have a, proper maintenance plan, we have to identify the process safety critical equipments, and those process safety critical equipments have to have a, RCM program. And next one is that process safety leading indicators. So every month in the process safety leading indicator, it has to present to the management that there is a zero overdue for the safety critical equipment. So if it is a small or big, it has to be attended. If it is not able to attend it, then they have to go for a deferment process, especially for the rotating equipment. Thank you.
Thank you. Next question is for Mr. Al-Naimat. Are the courses you mentioned available for the public audience, or they are inclusive to Army personnel? How can we enroll? Mr. Hamad.
Yes, I'm with you. Thank you for this question. Basically, we offer this courses for our friends from the society. It's basically a simple process just to direct ask that for the Jordan Armed Forces with the authority of that, and we can accept our friends with pleasure.
Okay, thank you, Mr. Muhammad. The last questions are directed to Mr. Allen. The first one is several times in the industry, we have witnessed the bypass of the management of change and the pre-startup safety review systems due to multiple reasons like production constraints and so on. So what are the main or your main recommendations to prevent this?
Yeah, okay. If you're talking about a new plant, a new project, there is usually a handover authorization between commissioning and operation teams. So it's possible to have a question in the handover documentation which says something like, has there been any change from the basis of design or the process description or the operating procedure? And then if so, has it been considered by a management of change or pre-startup review? So that's one way you can do it. If it's an existing plant and maybe you've done a modification, you can do a review of the operating log to see if there's been any significant changes. Or if you're doing a modification, there will be an authorization of the modification. And one of the questions in the authorization will be, have you done management of change review? So those are the ways in which you can identify the requirement to do management of change review.
The next question is, what is the role of employee training in preventing such accident?
Yeah, I was thinking about this in terms of my case study, where somebody operated a valve or didn't operate a valve correctly. That was a human mistake. Humans make mistakes, and I don't think training will eliminate mistakes. What you can do is train people to understand the concept of safety critical activities. In other words, there are some activities carried out which are more critical than others. And there is a technique to identify them. It's like HAZOP. We all know about design HAZOP. You can do a procedure HAZOP. And the procedure HAZOP starts with taking the main hazards from the design HAZOP, the normal HAZOP, and then using a different set of guide words, asking questions which identify those operating activities which are critical. So it's a different kind of HAZOP. I've done it many times in the oil and gas industry, and it's very useful for operators because they have practical experience that they can contribute. The difference is it's HAZOPing the procedures, not the design.
Yes, okay, thank you, Mr. Allen. For your questions that you presented in your last slide.
Yeah, shall I show them?
If you can go back to the slide.
I can, yes, just a second.
Yeah.
I need to get rid of that. And here we are. That's the one. Okay, can you see them? Those 6 questions?
Yes.
Okay, I'll do them quickly. Why should you not shut down the plant when it exceeds its design rating? In my experience, which is mainly offshore oil and gas, it's always the case that the plant shuts down automatically when you reach the design point, let's say design pressure. So you may have an alarm, a pre-alarm, which represents the maximum allowable operating condition. And then you have a second alarm and trip when you reach the design condition. I don't really understand why you would not do that. In other words, why would you have a manual shutdown rather than automatic? So that's my question. Why not have automatic shutdown? The second question, really, I've already covered. Are all safety critical tasks identified? The third one is about valve locking procedures. In my case study, there was complacency because a valve which was designed to be operated very infrequently became a routinely operated valve, and people became very complacent about using the locking procedure because it was inconvenient. The fourth point, what should trigger a management of change review? There are many things which can do that. I've got a slide which summarizes it, which perhaps I could show you quite quickly. I'll come back to that in a minute. The fifth question, number 5, who is responsible for alarm management? What I mean by that is that design engineers will specify alarms according to code requirements, okay? Nobody is responsible for looking at the total alarm management in many companies. Somebody should be looking at the consequence of having too many alarms. And the answer is there should be a technical authority for alarm management. The final one, are HAZOP actions implemented promptly? Essentially, when a HAZOP action is raised, there ought to be an assessment of the risk of delay in implementing it. Obviously, HAZOP actions can be high priority or low priority, and it's not really allowable for a high risk or a high priority action to be delayed. The reason is often inconvenience because the plant manager doesn't want to shut down his plant. That asks the question of whether production is more important than safety. So could I show my management of change?
Yes, yes.
Yeah, okay, let's just come out of that one. And I think I might have Okay, can you see the slide? What is a change? So it says here, it's difficult to give a complete listing of all the changes that you should review, but a guiding principle is anything which can adversely affect process containment, integrity, operation control, or safety systems. And these are the areas of change. Now, these are headings. You would have to have more detail, but typically these are the kind of changes that ought to trigger a management of change review. The important statement is at the bottom. It's more than just a change to the process drawing.
Okay, thank you, Mr.
Okay, that was very quick.
Thanks a lot.
Okay.
Now I would like to thank you, everybody, to attend this conference. For the final speech by Dr. Mohammed Ma'touk, the head of the organizing committee of the conference. Dr. Ma'touk.
Okay, let's wait for the question.
Okay, for the poll first, okay. You may answer these questions. Okay, we hope everybody was able to answer these questions. We will move to the closing speech by Dr. Ma'touk, the head of the organizing committee of the conference. Dr. Ma'touk.
Yes, thank you, Chairman. Actually, it is my pleasure to be the last speaker in this conference, to thank all our distinguished and respectable speakers from different countries. I'm very happy to see today all the speakers that we have experienced for today's. We have 40 lectures from yesterday, and we have 7 keynote speakers. So we have about 74 lectures from 19 countries, and participation reached more than 2,000 yesterday. For today, this is a big success for our conference. Let me explain what had happened for today's. We have come over different case study had been introduced in this conference. Also, there's a lot of speech about software and its application in safety industry had been introduced. There are different accidents and lessons learned from these have been introduced in our conferences in 2 days. Also, we have some lecture dealt with other potential accidents and what is the risk will be happen. More attention on what we need to focus on in the coming future. This will be a good experience for us. Better and necessary need to collaborate in both regional and globally. We come up with different speakers from different regions that we need really to cooperate for such as a risk and safety in the process, because we don't know when will such kind, God forbidden, will happen. We have a good outlook and some risk in certain industry and what precautions we need to take from different perspectives of our audience and speakers today. We have different questions from audience. We received more than 1,000 questions for 2 days, and hopefully we answer all of them. We are not, let me see, not able to answer all these questions. Some questions have been selected. We come up with some kind of, let's say it's not a conclusion, some kind of remarks. We need to have this conference as periodically. A lot of people has mentioned that we need to have such kind of conference. We promise them that we have this every 2 years, every 1 year. We will let you know. Please keep up with our conference website. We need to have a platform to share our experience from our partners in different regions. And this we are going to work on this to place different experience from our partners from this region. We will share in our website. We need to keep our audience and our distinguished expert as a human network. We are really very proud that we have a good connection from different world, from different region. This will be a big success for all participants, and we are really happy to have such kind of distinguished experience, many experience we learned from this conference, and we will keep this human network with our help of our website. We will place in all materials, as many people were asking, they need the material. We'll place it after the conference finish. We'll place in the website. The record will keep in the website, but we give us a little time for such monitoring and make it available on the net. And we will upload all of these presentation. Also, we'll some scientific paper after the speaker, if any person from our respectable, distinguished expert, if they want to publish their work, we are now in the process that we can accept this paper to follow in our national journal. We call it Jordan Journal of Engineering and Chemical Industry. We're going to publish a special issue in this conference and will be dedicated for this conference. I am the editor of this journal. I'll be happy to accept this selected paper. Any person is ready to submit this to our journal. And really, in behalf of my colleague and all the people who are working with us now at this late time, and we appreciate the difference time between the two countries, Jordan and other country, and all people and their patience to stay with us. Thank you very much, and we are really happy to see all of you. It's our great pleasure and proud to be with such distinguished and experienced expert people. And I will leave my speech to my colleague, Engineer Mohammed Al-Mahamid. He is the head of our chemical engineer branch in Engineer Association. He will salute you with our final grade. Thank you very much, and my pleasure.
Thank you, Dr. Mohammed. On behalf of Jordan Engineer Association Council and the Chemical Engineering Board members, I would like to present great thanks, firstly, to the speakers from all countries for your participation, valuable presentations, and high-quality information through the 2 days of conference. Also, the participants from all countries, thanks to all of you, and we hope that you benefit from this conference. It is nice to announce for all of you that this conference achieved a great success, started from your participation and effective efforts. The participants for the 2 days exceed the border of 2,500 participants, which represent the biggest conference in Jordan and the region. I think that related to these numbers, we are proud of that. Many thanks to our partners, Arab Fertilizer Association, Arab Institute for Safety Sciences, British Energy Institute, and the sponsors, Arab Potash Company and Jordanian Islamic Bank. The Jordanian Process Safety Association, you have made an incredible efforts in preparation for this conference. And let me mention you as a heroes of this conference. Engineer Yaqub Bani Taha, the association chairman, Dr. Sami Amarne, Engineer Amro Kisht, the conference preparation committee head, Professor Muhammad Ma'touq, Engineer Shayma Akhrisat, and all association committee members. Many thanks also to conference logistic teams from Jordan Engineer Association, Engineer Ibrahim Abu Sbeh, Engineer Rahaf Qaddoumi, Engineer Sawsan Qtayshat, Engineer Fatin Waqad, Engineer Omar Abadle, Engineer Ma'moun Skour, Ahmad Abdul Karim, and Raid Abu Shaib. You were one of the success reason for this conference. Thanks to all of you, hoping to see you again in the upcoming events. Thank you.